Hello friends, this is Rupesh and you're watching C Minutes video series on C++ and today's topic is inheritance in C++. And this video is going to be a very basic introduction part of inheritance where I will explain a single inheritance example and rest of the examples will come in coming videos. So here we are going to understand what is the need of inheritance and one basic example. So this is the core feature of object-oriented programming. So this is not only in C++, it is there in Java, Python, or to say all the programming languages whichever supports object-oriented programming. So the first question comes in mind is what it does. So it inherits the features, properties or characters, whatever you call, of base class into derived class. So base class means you will be having some class like class A and another class B, and you are inheriting that class inside your own class. Okay, so this class is called base class and this is called derived class, or you can call this one as parent and this one as child. So either you use this terminology or this terminology. I am familiar with this one, so I'll be using this one. So there is a class and you are inheriting it inside your class. So this is your class and this is some another class, and maybe this also was created by you only. Okay, and we'll see how to inherit that. So let's go through the points and why we use inheritance. One of the biggest reason is code reusability. It was initially created for code reusability and it is used for creating interfaces also, but I won't discuss that part because it will be little too much if you are beginner. So if you want to know what all you can do with the inheritance, I'll create another video maybe for uses of inheritance. So the terminology is base or derived, as I explained, or parent or child. Okay. So having said that, we have number of inheritance type. So there is something called single level inheritance or single inheritance. Another is multi-level, multiple, hierarchical, hybrid, multipath. So in single level, a derived class with only one class, base class, is called single inheritance. So the example we saw here is the example of single level inheritance because we have one base class and one derived class. Okay, so I'll just simply write all those types of inheritance so it will be easier for you guys to understand. So in single inheritance, we have one base class and another one is derived class. So only this much. So that is called single level inheritance or single inheritance. And in multi-level inheritance, a derived class with a base class and that base class is a derived class of another is called multi-level inheritance. It is nothing but multi-level. My writing is not that good, but that point is just like this. You have A, B and C. There is this another class which is inheriting B now. So this is multi-level. There is not single inheritance, there are multi-inheritance. Multi-level inheritance. So B is inheriting A and C is inheriting B. And you might be thinking, what if I am inheriting this C into D? Yes, then also this is multi-level inheritance. So no matter how many levels are there, if they are in this order, they are multi-level inheritance. So let's look at another inheritance. Another one is multiple inheritance. Multiple inheritance is nothing but a derived class with multiple base class is called multiple inheritance. What it means? Let me just give you this multiple inheritance. In multiple, you will have several base classes and you will inherit those base classes into one derived class. So this is B1, this is B4, and you are inheriting all these classes inside your derived class. Okay, so this is multiple inheritance. You are inheriting multiple base classes into single derived class. Okay, so it is very easy to remember all these things. So the fourth one is this hierarchical inheritance. In hierarchical inheritance, there will be multiple derived classes with same base class. Okay, so that would look something like this. Hierarchical, and as I said, there will be single base class and there will be multiple of derived classes, and this is base. So reverse of multiple inheritance is called hierarchical inheritance. You can see that. So this is how you denote the inheritance. This is the symbol of denoting that this particular class is inheriting this class. So this is the fourth one. Let's look at the fifth one. It is hybrid inheritance. So it is the combination of multiple and hierarchical inheritance. So as you can see, if you will go for multiple and hierarchicals combination, it would look something like this. So hybrid would be the combination of this one and this one. So let me draw the combination. This one is inheriting this one, and this one, this one. So something like this. So if this is the structure of your inheritance, that is hybrid inheritance. And don't think it is too much to remember. When I was studying, I also thought that, okay, these many types of inheritance, oh my god. But when I really started working on them, studied 2-3 times, they become really very easy for me. And when I was studying C++ that time, I was studying it from some books, okay? So no videos, nothing, internet was not that easy, and no one was there to explain me like this, what I'm explaining to you here. So enough talk, let's look at the last one, and that is MultiPath inheritance. So MultiPath is like a derived class with two base classes, and these two base classes have one common base class is called MultiPath. I know this is a little confusing, but I will sort out that doubt. So MultiPath, there will be this base class. So we have inherited these two, and then we will inherit these two into further this one. So this is, let's make it A, B, C and D. So this is a multipath example. Why it is multipath? Because this A is coming inside this D from multiple path, from B and from C. Okay, because A is there in B and C both, and B and C are inherited into D. That's why this A is coming from multipath. Okay, so this A is coming in D also, but not directly, indirectly. So this is the example of multipath. We'll see all these examples in detail when I'll explain each and every part differently. And as this is an introduction video, I'll keep it this much only. So far we have seen what are the types of the inheritance. Now let's look at the modes of inheritance. What do I mean by mode of inheritance? For that, I need to give some example here. So let me just create two classes. I'll quickly create them. So as you can see here, we have base class and derived class. We have not inherited anything so far. So let's see what are all these inheritance types are. So if we will use this public, or let's see how to inherit first. So this is the syntax for that. You have to write this colon and write the mode of inheritance you are using. Okay, so it would be like public if you want to inherit base class with mode of public. So public and then name of the class, what you want to inherit. So this is the syntax. You have derived class and then inheritance mode and what class you are inheriting. Okay, and then your class starting curly bracket will start. So this is the mode. And if you don't know what is public, protected and private keywords are, I'll strongly recommend please go ahead and understand the meaning of these, or I'll quickly tell you this. So if you have this public data member inside your class, so let's quickly create that public and integer x. So this particular data member is public inside your class. So it means it is visible to everyone. I mean, you can access this particular x inside this main function or any other function because you have made it public. So anyone can see this. So that's why it is visible to everyone. But if it is protected instead of public, if you wrote protected, in that case, this is visible only to the current class. So it means in base class. So if base class function, or to say data members, wants to access this particular data member, they can access that, or the derived class only. It means if you have this base class and you have inherited that class inside another class, so in that case, if you want to access this x inside this, you can do that. But only restriction is you cannot access this x outside this class and outside this derived class. It means you cannot access inside main. Okay, so this is one more level of restriction, because public doesn't give any restriction. Protected gives one restriction, that you cannot access this integer x from outside this class, but you can access it if you have derived this class inside some another class. Okay, what I mean to say is, if you want to print, you can simply print this x. Okay, because this print belongs to this derived class, and then this print can access this x. But if you want to access inside this main, you won't be able to do that. So that was protected access specifier. And yeah, these three things are access specifier. You specify the access type of your data member or your member functions, and these access specifiers are used to specify the type of inheritance, not type of inheritance, mode of inheritance. What is the mode of inheritance here? It is public. If you want to make it protected, you can make it protected. If you want to make it private, you can do so. Okay, so this particular table is used to identify if you have derived publicly, then what all members will come inside this. What I mean to say is, if suppose inside base class you have some private data member, let's make this private, and let's suppose you have this derived class and your inheritance mode is public inheritance. Okay, so this is full inheritance mode row. Okay, so in public inheritance case, if you have private data member inside your base class, that is not going to inherit. Okay, so this is the result. But if you have private, it will not be inherited in any type of mode. See, if it is private mode here, I mean, if I will write private, then also you cannot access whatever is private inside base. Okay, so if it is private, not inherited, not inherited, not inherited in all three types of inheritance mode. Okay, so here you write the inheritance mode. So if you're writing public, private, protected, and whatever is private here, it will not be inherited. So this is the table. It is very easy to understand this table. So let me just show you that if it is public mode, and let me give you the example. We should go with the examples, right? So let me compile this. It is saying that one error generated and declared private here. It means you're trying to access this X here. You can see that it is giving you the errors exactly what I told you. So X is accessed here, but it is private. So you cannot do that. Okay. X is private member of base. So this is the error. So we cannot do this. So if it is private, you can see whatever mode you use here, private data members are not going to get inherited. Okay. But let's suppose you have protected. So let's make this protected, and this X is protected now. And let's suppose you're inheriting it inside derived class using public mode. So this first mode. So this protected data member, which is of base class, will become protected inside derived class. So protected will become protected, but you can access this X now. Okay, so let me just compile that. See, it has finished compilation. It means there is no error. Okay, so this is how it works. So if it is public and you are inheriting it with public mode like this, in that case, that data will be public in your class also. And in protected case, yeah, I forgot to mention, this protected data here is inherited as public, so it becomes protected. What it means? It means that only this derived can access this X. You cannot access this particular X from outside this derived or outside this base. What I mean to say is derived object D and D.X should be printed. And if you will try to access that X, which is coming from top, you won't be able to do that because you are trying to access this particular X outside this derived. So let's compile now. See, it is giving you the error. See, it is telling that X is protected member of base. So you cannot do this. And as I said, if this is public, then everyone can access that. This derived can access that X, this main function can access that. So let's make that and verify it. So if it is public, I'll compile this. Oh, one error is there. What is this? Okay, some typo has happened. ENDL. Okay, see, it is printing 0. The point is you can access it. Okay, I think you are getting my point, right? Or if you're not getting it, revise this video 2 or 3 times, then you will be able to understand this very clearly. It doesn't come in first time. Okay, so don't panic. So you saw that if we had this protected here and we are trying to access this here, we can't do that. But we were trying to access that X here and we was able to do that. And just to demonstrate that, d.print. So if I'll compile this, what is this error now? Okay, this print is, again the access specifier problem. One more thing guys, here I have not given any access specifier for this particular function. By default, classes will make everything private. Okay, so that's why it is giving me the error. Print is private member of derived. So you cannot call from outside. Private means it is accessible from inside class only. Okay, so let's make it public. So this is how you make it public. So now this print function is public and we can call that. Okay, and here we can see that it has compiled, but it is printing some garbage value. That is not the issue. The point is we are able to access this X inside derived. Okay, because it is protected, and protected data member of base class become protected inside derived. But it is coming inside derived. That's why you are able to access it. Don't think that it is becoming protected here. So how you are accessing it? It is becoming protected here, and if it is becoming protected here, it means you are not able to, you are not allowed to access this particular X outside places. From here, from main or something. Okay. Now let's look at this public one. So if it is public and inheritance mode is also public, it means if this is public and your inheritance mode is also public, then your data member is becoming public inside derived class. Okay, so this X is public here. It means you can do something like this. Let me do this. So as this X is public inside derived, so using derived object, you can access that publicly, and this is public domain. Okay, so let's compile that. See, it has become 0. So there is no error. And similarly for all these things, like if you have data member as protected and you are inheriting it as private, then it will become private inside derived class. Okay, so this column is for derived and this is also for derived, but different mode. This is private mode, this is protected mode. Okay, so if it is protected, it will become private in private mode of inheritance. If you will write private here and this is protected. So if this is like this, this particular X will become private here. Okay, so you might be asking, what is the use of making private here or protected here? So if it is becoming private here, you cannot inherit that further. It means if you have some another class derived 1, and if you are inheriting this as public like derived, in that case this particular X will not derive here. So if you will have some another public print 1, and if you will try to print that, you won't be able to do that. So let me just show you that. I need to write this void here. If I will compile, what is this? So many errors. Oh yeah, it is giving you the error just because of these things, because we have changed this access specifier here. Okay, so Let me compile this again and see if it is okay. No, it is not okay. Oh yes, this is giving you the exact error. You cannot cast derived 1 to its private base class base. So the error is here. See, it is print 1 and you're trying to access this X. So it is not allowed. And in compiler term, it is telling that I cannot cast derived 1 to its private base class. So another way is it is not allowed because it is private here. Because you inherited privately, so protected become private here, and now you want to inherit this one here and trying to access that X, so that X will not come because that access has become private here. Okay, so this is how it goes. So I think you got the points. So as I said, I will be giving you the example of one level of inheritance, which is called single inheritance. So let's look at that example. If this is becoming very big video, pause it, go for some tea, coffee or water, come back and watch again. And that's what I'm going to do now because I'm tired of talking. So I'm back now. So I wanted to discuss this with single inheritance, code reusability. There is a traditional example to understand this topic, and I'm also going to use that particular example only. Okay, so let's look at that example. So that example is, let's suppose you have some animal class. So what are the functionality of animal classes? Animals, they eat, they walk, okay, and they do so many things, but we'll take these two examples only, okay? So they eat and they walk. Now let's suppose you wanted to create so many animals classes. I'll take only cat and dog. So cat also walk and eat, and dog also walk and eat. So if you are supposed to create cat and dog classes, you have to give walk and eat here and here also. Walk and eat. Okay, so these are the functions. So if you was supposed to create two class cat and dog, then as you can see that you are creating similar functions again and again. Let's suppose if you are creating a dinosaur. Okay, so in that also you will have this walk and eat. What I mean to say is, if all these classes have some common property in them, then what we should do, we should create a common class. Let's say it is animal, and we should inherit that in our class. That is the best use of inheritance. So you won't write this walk and eat in every class. What you will do, you will write in particular class and you will call it animal and derive that class inside different classes. So the benefit is you don't have to write those similar looking functions again and again. And one more point, if you want to give some specific function to this cat or dog or dinosaurs, you can do that as well. So if you will take that example, that could be like talk. So they all will have talk, but they all have different talking way. Okay, so this is also talk, and here also it talks, but it is like wow. So it is different for this one and this one. Okay, what I mean to say is cat will do something like meow, dog will be bow bow, this is bow. So they all have some similar function, talk and talk, but they all do it differently. Our point was, whatever common thing is there, we will put in some base class and inherit that, and whatever is not common, we will put inside individual class. So let's see the example here. I'll quickly write the code for you. So as you can see that we have this dog, cat and dinosaur class and this animal class. Okay. Similarly, what we had here. Now, I have not given any inheritance here. So let's do that and inherit this animal inside all these three classes. And I'm going to use public for that. And yeah, one more thing. If you are inheriting it like this, just simply like this without writing anything here, then also it is possible, but by default, if it is class, your compiler will assume you are inheriting it in private mode, okay? Not in public mode. Remember that. in structure it is by default public. So if it is not class, if it is structure in C++, by default it is public inheritance. So we have to give public here. Okay, and similarly for these classes, so I'll just simply copy and paste. I don't have much time. This video is getting a little bigger, I know that. Yeah. So what you expect here? Exactly. You are having this eat and walk function in all these classes. So let me give some message, eating, and here walking. So it will be easier for us to understand this. Now let's create dog class D and cat class C and again dinosaur class DI. And if you will print d dot eat, you would be able to do that. And c dot eat, and again dinosaurs eat. So they all eat, right? So let's compile that and see. It is telling that eating, eating, and eating. So the point is this eat function is not there inside dog, cat, and dinosaur. It is coming from animal. Okay, so it was common in all the classes. That's why we put it inside one top class and inherited that. So we don't have to write it again and again. That's the only point. That's the only point of code reusability. I know it has made your points so clear. And yeah, one more thing. If you will call this talk, and as I said, it is different for every animal. So let me just give here talk and here also talk. So if you will compile now, let's do that and see, it is bow, it is meow, and now how. So they all have their specific talk also. Okay, so this is how you go with inheritance. This is not the only use. We created for interfaces also, but I don't think it should be included in this video. I will create another video, so don't worry. If I have not created it after some time, you can please remind me for that. I'll do that. Okay, so let me check if I'm missing some point here. I don't think I'm missing. So we have covered this single level inheritance, but actually it is not looking like a single level inheritance. This is not a single level inheritance. Can you guess what type of inheritance it is? It is hierarchical inheritance. So in hierarchical inheritance, there was only base class and multiple of derived classes. So I think you got the point. We use inheritance for code reusability. I know my spelling is maybe not correct or my writing is not good. So this is one of the reasons. Another reason is we can easily create the interfaces. I'm just writing that so that you can keep this in your mind, and I'll explain this part in coming videos. So I think we are done now. Thanks for watching. If you like the video, don't forget to hit the like button. And yeah, make sure you subscribe to my channel so that you will get the notification for upcoming videos like this. See you. Bye-bye. Hello there, this is Rupesh and you're watching CPP Nerds video series on C++ and today's topic is single inheritance in C++. So notice that this is not the introduction part of the inheritance. If you are looking for the introduction, please go ahead and watch my previous video where I have explained what is inheritance and draw all the examples like what is single inheritance, what is multiple inheritance and all that. So if you are looking for something like that, please go ahead and watch that one. I'll give you the link in the description field. Otherwise you can get something like a pop-up here. You will get it with this link. Okay. So this single inheritance is a very basic type of the inheritance where it requires only one base class and one derived class. What I mean to say is there will be this base class what you will derive inside your derived class. And this is what single inheritance is. So for that purpose, I have taken this vehicle and car class to show you the example of that. And one more thing guys, I wanted to explain that why you will inherit one class into another class. I mean, is there any rule or soft rule you can say? Actually there is. There are two types of relations. First is has a relation, has a, and another one is a relation. So there are two types of relation. This inheritance comes inside is a relationship. So you will derive any base class into some derived class when this is a relationship is fulfilled. As you can see here, we have this vehicle and this car. So I'll be deriving this vehicle inside my car when it has some meaning. What I mean to say is, I won't derive base class into derived class when I cannot associate this relationship between them. So your derived class should be one type of base class. If this car is vehicle, then only I can inherit that. And if I have another class, let's say bike, then that is also a type of vehicle. So I can inherit that inside my bike. But let's say for the example, you have this vehicle and you want to inherit that into maybe some another type, maybe Apple. So this is not good idea. Okay. So even though you have the code reusability, what I mean to say is, let's suppose you have some vehicle class or say base class and you want one function from that class. There are several functions, and as we are learning this inheritance, because I said that there is a code reusability, but that code reusability comes when there is a meaning associated. It is not like there is one function and that function is needed inside your class, so you will include that full class inside your class. No, that is not a good idea. So whenever you inherit something, this is a relationship should be followed. You must be able to say that bike is vehicle, so I am inheriting that vehicle inside bike. Car is vehicle, so I am inheriting vehicle inside car. But if you have apple in your hand and you cannot inherit vehicle inside that, actually you can, but that is not a good practice. So if anyone will see your code, that's not going to make any good impression of yours. Okay. And you might be wondering what is this has a relationship, because I have explained is a. Has a means if you have, suppose, car as a class, inside that car you will have tire, correct? And let's suppose you have another class called tire somewhere here, and you can include that tire inside your class. So car has tire, that's why you are including this tire inside car. What I mean to say is, let's suppose you have this class car and here you are using some class tire and T. So you can do this when this has a relationship is fulfilled. Okay, this car has tire, car has engine. Okay, so if you have some another class called engine, you will include that engine class inside your class because you have this has a relationship fulfilled. So I'll create this another video for this has a and is a relationship. These are two different topics. So let's talk about the single inheritance. So as I said, in single inheritance, there will be only one base class and only one derived class. So let's implement this vehicle and car example. So I have not inherited that yet. So let's go ahead and inherit. So if you have watched my previous video, you might be knowing what is the meaning of inheriting it as a public, private or protected. So for simplicity, I will go for public. Okay. And inside car, I will create car specific functionalities, but I will not go into much detail. Just to give you the example here, I will create get tires. So this will return how many tires are there in car. So 4 tires. I know this is not a great example. Just I wanted to convey the message, and yeah, this should be public. Otherwise we won't be able to call this. So this public, and we need another method here. I'll tell you why I'm creating this get tire inside this car, and here I will be creating something like drive vehicle. So here we can write driving. This is a very small example, and let's create a car C and C dot get tires and C dot drive vehicle. So these are the two messages. If I'll compile this, it is telling that 4 tires and driving. So let's try to understand what is the meaning of this whole thing. So if you have watched my previous video, then you will be knowing that why we inherit one class into another class, and that I explained in this video also, but I'll repeat that again. We inherit one class into another class because we want to use some of the functionality what is already given. So when you are going to build a system like let's suppose you are going to build a game where you will have car, bike, plane, and there is one common feature in all these types, that is drive. So we can drive all these 3. Actually this one flies, but it's okay. The thing is, whatever is common, we don't have to write in each and every class. The good idea is take out all those common things, put it on top. Okay, so and give some general name to that class and put everything whatever is common inside derived classes inside that and inherit from there. So you don't have to write repetitive code again and again. So similarly, in single inheritance also, we derived one class into another class just because we was able to satisfy is a relationship and we wanted to use some of the facilities of that particular class. So we wanted drive vehicle facility in our car. That's why we inherit that. But this get tires is a specific thing to this particular car because car has 4 tires. So if you will push this function up, I mean in this one, so if you are inheriting this vehicle inside bike, but bike will have only 2 tires. Okay, so specific things will go inside specific objects, but whatever is common will push up. Okay, this example. So as you can see here, if you are creating a class, object of a car, in that you can call get tires, which is its own function, and derived vehicle, which is coming from top. Now there is very important thing which is called access specifier, and here in this case it is inheritance mode. So I am keeping it as public and this is also public. So this function will become public inside this. That's why we are able to call this. Otherwise there are different rules and I have explained that table in the previous video. If you are coming from that video, it will be very easy for you to understand what I am talking about. So I think we'll keep it this much. Thanks for watching. Bye bye. And if you like the video, don't forget to hit the like button and make sure you subscribe to my channel so that you will get the notification for upcoming videos like this. Bye bye. Hello friends, this is Rupesh and you're watching C Peanuts video series on C++ and today's topic is multi-level inheritance in C++. So as the name says, multi-level, so we'll be having more than one level. So this is multi-level inheritance. Let's make this A, B and C. And when it is single level is this one, A and B. So this is single, this is multi-level, and multi-level will have n number of levels. Okay, so number is not defined, but if it is in this hierarchy, then it is multi-level. So let's look at this definition here. If derived class is again derived into some another class, then it is called multi-level inheritance. So here, if you will see in the single inheritance, this is your derived class and this is your base class. And here it is telling that if derived class is again derived, here this is derived class, but we are not deriving it further. But in this case, this is also a derived class and we are deriving it further. And this is also a derived class and we are deriving it further. Okay, in this one. So when there is this type of design or class hierarchy, you will call it multi-level. Okay. And if you have watched my previous video, which is talking about what is a relationship and what is has a relationship, you'll be able to understand this point very well. So we only derive a class when we can satisfy is a relationship with base class. So what is a relationship? It is nothing but, let's suppose there is some class vehicle and there is another class car. You can inherit this vehicle inside car Because you can say that car is a type of vehicle. So there is this is a relationship fallout. Okay, that's why you're inheriting it. But this is not true in reverse order. Okay, it means you cannot inherit car inside vehicle and say that vehicle is a car. No, you will inherit vehicle inside car. And this is how it works. Car is a vehicle. That's why I'm inheriting this vehicle inside car. And if you will see the example here, we have this animal, cat, and Russian blue cat. So this is one specific type of cat. So what would be the diagram for this class? Yes, exactly. I have put it in the correct order. So first it will be animal. Okay. And then cat is an animal. And this Russian blue is a cat. So you will inherit cat inside Russian blue. So this is how it should be. Cat is animal. So you're inheriting animal inside cat, and then Russian blue is a cat. And can you see one hidden message here that this Russian blue is indirectly inheriting this animal also, because Russian blue is a type of cat and it is an animal. Okay, so hierarchy goes like this. You will put something very general on top, and in down the hierarchy you will keep on placing the concrete ones. Okay, because if you'll say animal, then there is a very big field. But if you'll see cat, you have some picture in your mind, right? I mean, you had picture in this time also, but you had so many pictures. There was nothing to specify. But cat, now you have a picture that what cat looks like. Now this is the most concrete one, what you're talking about. Okay, so this is how it should be. So I'll write the code and we'll see how it goes. So we will use public animal, and here you will inherit public cat. This is how it should be. Okay, exactly how it is here. Now if you're wondering why I'm using public and why I'm not using protected or private, it's up to you. If you don't know what is the difference between public, protected, and private inheritance, I mean modes of inheritance, watch the introduction part of this series, you will get it. Okay, or tell me if I have not included the link in the description field, or you will get the link somewhere here. So this is a very simple example. There is nothing to discuss. Only one important thing is this part. The most general thing will come on top, and then less generals will come in this hierarchy. And keep this in is a relationship in your mind. There are two relationships, is a and has a. So if you're not sure what is this is a and has a relationship, I have a video for that, and you will get the link in this area here. So for multi-level inheritance, this is enough to understand. So thanks for watching, and if you like the video, don't forget to hit the like button and make sure you subscribe to my channel so that you will get the notification for upcoming videos like this. Bye bye. Hello friends, this is Rupesh and watching CBNet's video series on C++, and today's topic is multiple inheritance in C++. So we have seen single inheritance, multi-level inheritance. Now today's topic is multiple inheritance in C++. So let's look at the point now. A derived class with multiple base class is called multiple inheritance. So if there is something like this, if we have base 1, base 2 and base 3, and we are deriving all these base classes into derived class, one derived class. So this becomes multiple inheritance. You are deriving more than one class into single class. And there is this ambiguity problem in multiple inheritance. We'll see that when I will show you the example here. So let's talk about this example first. We have YouTuber, engineer, and Rupesh. This is my name. So let's look at the hierarchy, how we can draw the diagram here. So there will be this YouTuber. This is one class. Another class is engineer. So this is engineer class. And this is myself. So Rupesh. You might have already guessed how the structure would look like. And if not, I will explain. Don't worry. So this is the example of multiple inheritance, and this is a real-time example of multiple inheritance. So as I said, in my previous videos that when you will inherit something, you must be able to tell that Rupesh is YouTuber and Rupesh is engineer. So that's why you can inherit both of these inside Rupesh. Okay? But reverse is not possible. What I mean to say in reverse is like if there is Rupesh on top and if you'll put engineer suppose in bottom, then in that case this relationship is not holding because engineer is Rupesh. No, this is not good statement. Rupesh is engineer, that is correct, but engineer is Rupesh, that is not correct. So you should always must be able to tell that derived is base, not base is derived. Okay, so this is not correct statement. So until unless you are able to say something like this, you should not derive any class. So I think you would have got the point now. So let's go ahead and implement all these classes. So we have a YouTuber class and we have engineer class. So let's implement this inside this public YouTuber, comma, public engineer. And yes, this is the syntax of inheriting multiple class into single class. You will be using comma to separate all those classes. And yeah, I wanted to explain one more thing other than this ambiguity problem. We'll see this problem later, but first we'll see something else. So for that, you need to have this constructors, and I will give some message cout YouTuber. And in another one, we must have constructor for engineer, and here we'll give message. Okay, and let's give the constructor for Rupesh as well. So Rupesh, I'm creating myself. Isn't it cool, dude? Yeah, it is cool. So we are done with these constructions. Let's look at the way it is going to call these constructors when you're calling this one. So that is a very important part here. So R1. So let's compile this. Okay, I did one mistake before compiling. I should have done this public and public. So we must have constructors as public in order to call from outside, right? So if this is not public, we cannot call from outside the class. So let's compile this now. See, it is YouTuber, engineer and Rupesh. So let's see why this YouTuber is coming before engineer and then later Rupesh is coming. So let's see why construction is happening in this way. First YouTuber, engineer and then Rupesh. So remember this, whenever you will create a derived class object, see this Rupesh is a derived class, okay, because it is deriving YouTuber and engineer. So whenever you will create a derived class object, first it will call itself here, but it won't go inside, and compiler will automatically append few things here. Let me just write that. Compiler will do something like this: YouTuber, comma, engineer. As this is default constructor, compiler can do this, but if it is parameterized constructor, I mean if your base classes need any parameter from derived class, then compiler will not be able to write something like this. In order to call your base class constructor, you have to write explicitly from your derived class constructor like this, but only when you have parameters to pass to them. What I mean to say is, let's suppose you are passing 1, 2, and from here you want to pass this integer x is there, integer y is there, and if you want to pass this x here and y here, then you have to explicitly give this syntax. But here in our case, we were not using any parameters, so compiler was able to append all these things automatically. Okay? There is one more thing to understand here. The thing is, you can see that compiler is calling YouTuber first, then engineer. Not because compiler is writing here YouTuber first, then it is writing engineer. No, this doesn't matter. The only thing which matters is what is the step of inheritance. First step, you are inheriting this one. So always constructor of this class will be called before then the next class. I mean this engineer class. Okay. So if you have derived YouTuber first, in this case we have derived YouTuber first. So always YouTuber's constructor will be called first. Even though you are writing here first engineer, let's do that. This is engineer and comma and this one. So even if you're writing engineer here first and then YouTuber, your compiler will still call YouTuber first then engineer, because it calls in this order, the inheritance order. Okay, in order to show you that, let's take these X and Y here. So integer Y. Okay, so if I'll compile this now, let's do that. See, order have not changed. It is still YouTuber and engineer, even though your engineer is coming here first. So now let's verify it by replacing this one with engineer, and here we'll write YouTuber. Let's compile this now. Yeah, see, now engineer is coming because engineer is derived first, then YouTuber. So I think you would have got my point. There are two things to remember. First thing, if you're not passing any parameter, before we were not passing anything, then in that case, you don't have to give any base class constructor call, because compiler will do it automatically. Don't worry about that. But if you want to pass any parameter from derived class to base class, you have to explicitly call them. And one more thing, you have to call using initializer list syntax only. I mean, using this colon and this syntax. You don't need to go inside this bracket and write something like engineer here, engineer and Y here, and YouTuber X. You should not do it like this. Your compiler will not work in this way. Okay, so let's verify that as well. Compile this again. See, we got some errors here. It is telling you that error, here is the error. Constructor for Rupesh must explicitly initialize the base class YouTuber, which does not have default constructor. Okay, yeah. The point was you wanted to initialize your base class constructor's value. I mean, this X is a part of your base class somewhere X here. So you wanted to initialize that X, but take that X value from somewhere derived object. So this one was supposed to go inside X and 2 was supposed to go inside some Y here. Okay, and you wanted to do something like this. You wanted to initialize that Y inside Y, and here you wanted to initialize that X with X. So this inside bracket X is nothing but this X. Okay, this parameters X, and this outside X is this X. So if you don't know what is this syntax, please watch my another video which is about initializer list. You'll understand this very well. So I hope you know this. So the error it is saying is, from here we are not able to call your YouTuber and engineers constructor because there is no default constructor. You remember, as I told you in the beginning, that compiler will call only default constructors, and there is no default constructor. I mean, compiler will not create any default constructors if you have provided any constructor by yourself. So that is another point to remember. I know there are lots of points to remember. So this is that error. And this, I think, is nothing but a temporary object creation. So here it is temporary object, here it is temporary object. It is not initializing X and Y of their respective data members for R1. Okay. So in short, don't dig so much because this series is for beginners, and you should remember that you should explicitly write the base class constructor call in initializer list only. Okay, you should not do inside the brackets. So it is very easy to remember that. Okay, so if you will do it like this, let's compile now. See, it has compiled successfully and it is calling in the order of inheritance. Okay, so these are the points to remember. Whatever the order would be, your constructors are going to call in that order. So engineer will be called first, then YouTuber, then Rupesh. So first engineer, then YouTuber, then Rupesh. So if the construction happened in this order, then destruction will happen in this order. Okay, I mean, if engineer's constructor was called first, then YouTuber, then Rupesh, but if you're calling the destructor part, then first this was construction, and if you go for the destruction, it will be in reverse order. First Rupesh, then YouTuber is in middle, so it will be in middle, and then engineer. Okay, so this is what the order should be in destructor. If you don't know why it is like this, why destruction happens in reverse order of the construction, I have a video for that. You will be getting the link somewhere here, or I will give you in the description field. Don't worry about that. So you complete this video and go ahead and watch that one also, because that is some extra bit of information you should be knowing. And if I forgot to give the link, please remind me in the comment section, because sometimes I forget, because I shoot 3-4 videos at a time and I don't remember what I said in some videos. So we have seen how to deal with all these calling way and all. Now let's understand what is this ambiguity problem here. So to explain you a little bit what is ambiguity, let's assume that there are two similar functions in both the classes. So there is this YouTuber, and we have another engineer. In that case, let's assume both are having similar function, one similar function. Let's assume it is work, because both work, so both will have one similar function, work and work. And if you are inheriting these two into Rupesh, yeah, this is going to be a very good example. So at one time, either I am working in my company as an engineer or working as a YouTuber in my home. So at a time, I'll be doing one thing. So at a time, I'll be calling some specific work function. So work is there in YouTuber also, work is there in engineer also. But at a time, I'll be using any one of them, not both of them, because I don't create videos in my office and I don't bring my office in my home. So let's see how to solve this ambiguity. And yeah, what is ambiguity? I'll show you that. So let's implement some ambiguity code here. So as I said, void work and cout working on YouTube, and here we can have similar function work, and here we can give the message working in office, or I should say working as engineer. Will it make sense? Yeah, I think it would. Working as engineer. Okay, now let's suppose you have this R1. I'll keep all these parameters as it is. Don't worry about this parameter much. So R1.work, you just want to call this. That's it. Now let's compile and check the problem here. See, it has said that there are two errors. Okay, first error is some void is misspelled, VOID, and let's compile this again. So there is only one error, and that error is, yeah, member found by ambiguous name. Why? Because as I said, this R1 will have work from YouTuber and similar work function from engineer. So if I'm going to call work, it don't know which one to call. This is the ambiguity problem, and let's see how to solve this problem. So the first way to solve this problem is explicitly telling that which function I want to call, and that would be like this: R1.YouTuber work. So I'm explicitly telling that R1 should call a work function which is of YouTuber class. So let's comment this code and check whether this code is working or not. See, it is working as we want. See, working on YouTube. Okay, so this is working, and similarly you can go for engineer one also. So R1.engineer work. So if we will compile this, let's do that. See, it is working and calling the working as engineer. I should make this U as big U. Okay, so this was the first way to call your functions, by explicitly telling that I want to call this function which is from so and so classes. Now another way is you can typecast this R1 into your base classes. Okay, what do I mean by typecasting here? You can explicitly create Rupesh engineer is equal to R1. So in this case, R1 is being assigned to engineer, but it is RE, so Rupesh engineer. So as we know that R1 is holding both YouTuber and engineer and its own stuff. So actually R1 is Rupesh class plus engineer class plus YouTuber class. So R1 is of these three type combined. But if you are assigning R1 into its base classes, one of the base classes, then it will copy only those materials from R1 which belongs to particular class, engineer class. So you are initializing R1 into engineer, so it will take all the engineers data from R1 and put into this one. So after doing this, you can directly call work, because there is no ambiguity here. This RE is of type engineer and engineer class have only one work function. So let's check that as well. See, it has printed 2 times engineers and engineer. Okay, so second time was because of this one. And similarly, you can initialize this R1 into YouTuber class also. Let me do that just for the sake of completeness. YouTuber Rupesh YouTuber is equal to R1 and Rupesh YouTuber dot work. So if you will call this one, it will do the same thing. Let's compile this. See, in the end it is printing working on YouTube. Okay, so I hope you got the point here. And this thing is called slicing. You are slicing out the rest of the part from R1 and initializing whatever is part of engineer in that. Okay, so this is called slicing. If you don't know what is slicing, I have a detailed video on that. Please search object slicing in C++. You will get that video. And you know what? There is another method also. Let me get rid of all these things. And if you know what is static cast, dynamic cast, and all those casts, it will be very easy for you to understand this third point. Otherwise, please go ahead and watch static cast video. I have that as well. And if I'm telling something that I have this video and you are not getting that video by searching in YouTube, then just write that title, whatever the title you are searching for, and then space and then CPP nuts. So if you type my channel name, it will automatically come, because it might not be ranked as top because I have recently uploaded it or for some other reason. So we are talking about the third type. The third type is you cast R1 using static cast into engineer. Okay, so R1 would be casted into engineer. So you can put the bracket here to exactly understand this, like this, and we can call work on that. Okay, so if you will compile this, it will call working as engineer. Okay, so this is also possible, and this bracket is not necessary, I guess. Let me get rid of this and compile this. See, it is working as it is. So these 3 calls are constructor calls. Don't worry about that. This one is our interest. Okay, so this is not ambiguous anymore because we have typecasted R1 into engineer, and on that we are calling work function. Ultimately, we are calling work on engineer type only. So there is no ambiguity at all. And similarly, we can do the same thing for YouTuber. So if I will replace this engineer with YouTuber and let's compile again, see, it is working on YouTube. Okay, so let's look at if there are 2 different functions. So is there any problem? And yeah, you can have different functions in them and you can use that, and that is pretty good. So let's implement something like void thinking for video, and let's print some message thinking about some video. And here we can have void thinking for project. So I may be thinking about my project or my video at any time. So thinking about project, not problem, project. and these two functions are not similar, so we can call them without any issue. So R1 dot thinking for video and R1 dot project. And if you'll compile this now, see, it is telling that thinking about some video and thinking about the project. So there is no problem in this code because I can think about video or project anytime, but I can work on them one at a time. I cannot work on project here as an engineer, and I cannot create a YouTube videos simultaneously. So we needed typecasting because there was some ambiguity. And when there is no ambiguity, you can directly call those functions because compiler knows only one function is there. I mean, this thinking for video is available in YouTuber class only. So it will directly call that function without any problem. Okay. So I think we should wrap up this video now. Thanks for watching, and make sure to subscribe to my channel so that you will get the notification for upcoming videos like this. I'll see you in the next videos. Bye bye. Hello. This is Rupesh and you're watching C-Beginners video series on C++, and today's topic is hierarchical inheritance in C++. So I have two examples here. Hierarchical inheritance is multiple derived classes with same base class is called hierarchical inheritance. So let's see the diagram for that first. So multiple derived classes. So let's create multiple derived classes. There could be any number of derived classes. Let's give them number 5. And there will be one base class. And everyone is inheriting. Okay. So this is the example of hierarchical inheritance in C++. And this I can say is the most important inheritance in C++ because every programmer uses this like anything. Because this particular example is very good for creating interfaces in C++. If you don't know what is interface, don't worry. I'll be creating a video for that. And by the time you're watching this video, maybe it is already created. So you search interfaces in C++ with space CPP nuts, you will get that video. And actually this is not the only way you will use interface. I mean, you will implement interface, but this is the best way to do that. But wait a minute, I'll give you a little bit of hint what is interface. So you all might be familiar with the pointers, right? So base pointer B, let's make it small b. Here you can initialize either base object or D1, D2, D3, D4, D5, all the derived class object inside this. So for example, I can take new D1. So this D1 object is going inside B, which is of B, base pointer. Now the important part to notice is, let's suppose every derived class is having f1, this is a function. This f1 is there in every class. And this f1 function is different in every class, but the name is similar. So here, simply by writing b f1, you are actually using the interface. And here, you're calling f1 of derived type, whatever the type is. Let's suppose initialized d1 here, so it will be calling d1's f1. If you are initializing D2 or D3, it will be calling f1 of either D2 or D3. It depends on the object type you are initializing in. But this thing will not work if you are not having this virtual base. If you don't know what is virtual, I'll be creating video for that also. Don't worry. Or maybe it is already created, so please check that. So I think you got the idea here. This is how we create the interface. So this B is pointing to any derived object, and you can call that f1, and it will call these f1 function of respective type. So this is called dynamic binding, and I have video for this also, what is called dynamic binding and static binding, and this video is already created, so you can go ahead and watch that one. So this one is the use of hierarchical inheritance. Now let's see the example of hierarchical inheritance. So for that I need to undo all these things. Wait a minute, it will go off. So let's look at the first example. Here, YouTuber, engineer and doctor all will be Yes, derived classes. You guessed correctly. So on top, human, and everyone is inheriting that. So YouTuber, engineer, and doctor, because they all are human. YouTuber is human, engineer is human, and doctor is human. And there is a saying in inheritance world, I don't remember where did I read this, but someone told that if animal and vehicles was not there in world, then it would have been impossible for people to understand inheritance, because everyone take this example to explain these topics, because it is very easy to understand this. So let's go for the another one. I know you might have guessed it correctly. So on top it will be coming like vehicle, and here we have car. Okay, so this is how it should be. So few of the people might be asking that what is the real-time use of all these things? Actually, if you understand this, then you know the real-time use. Let's take the example of PUBG. So if we are creating a game, I'll go with PUBG. It is PUBG. I know lots of the people might be knowing this game already. My brother used to play this game like anything, so I know this game. And he showed me once that how to pick different guns, how to pick this, that, and all that. So let's assume you are a developer and you are supposed to develop 5 guns. Okay, so maybe first gun is Magnum. Actually, I used to play Counter-Strike too much in my college time, so I remember this name. And Maverick and all that, if I'm not wrong. These all are the guns. So AK-47, and let's suppose type 1 and type 2. So these are 5 guns you were supposed to create, and all these 5 guns will have different firing power, firing speed, and stability and all that. So my suggestion is, if you are creating these guns, then better you put a top class like a gun and inherit that gun in all the classes. So whatever is there in all these 5 guns, common you can put here, so that you don't have to repeatedly write all those things again and again. And second advantage is, using pointer or reference, you can achieve the dynamic binding, so that you don't have to use if and else condition. Let me give you the example here. Let's suppose there is a class player. Some player, actual player, is having some gun. Obviously they will be having a gun pointer G. Okay, so dynamically you can initialize this G, and notice this, I'm keeping it as a gun. So this is the type, and dynamically you can initialize whatever gun you are choosing in this pointer, and that player is holding that gun at that time. Are you getting my point? You don't have to write like a Magnum M, and then this one Maverick M2, then this AK-47, maybe AK. Are you getting this? So if you're not having this, you have to have all these types defined inside your class. And let's suppose there is a function called shoot. So void shoot, and here you won't be knowing what gun you are holding until unless you are maintaining another variable to tell you that. Then you have to go for if and else conditions and all that crap. But I'm telling you, what you can do is you can just have this pointer, and dynamically you will be assigning what gun you are choosing in constructor or set gun or something, and you will set this pointer G using any type. And when you are shooting, you will be doing just this. You have this G and fire. Okay, so this fire is there in every gun. Are you getting my point? Fire and fire. And obviously there should be a virtual class so that you can do this dynamic binding. But this is the best use of inheritance. Okay, otherwise you would have gone through a lot of pain, right? So this is a real-time example of where to use inheritance. Not only this, you have seen my single level, multi-level, multiple inheritance. So they all are really very useful when you will be having the problems in your hand, and you will be able to map those problems to the respective inheritance. So if you are having problem in your hand which is best suited for single, then you will go for single inheritance. If it is for multi-level, you will go for multi-level. If it is for multiple inheritance, you will go for that. Otherwise, you will go for hierarchical, hybrid, and all that. So it depends on the problem you have in your hand, and the ability to solve that problem would come with practice. So let's quickly see the real implementation of these. So I'll take the example here, first example. So let's inherit that. I'll be inheriting with public for simplicity, human, and the same thing will go in everywhere. Okay, so you can see that we have inherited human in all three classes, and let's have one common function for human, breathing, and we can just simply print the message that I am breathing, because human have one common property, they all breathe, correct? So this is the best function to keep in common class. You don't have to implement this common function in all the classes. You will directly take it from top. Now, if you will create a YouTuber U and you will ask him to breathe, they will start breathing. YouTubers are breathing. Oh my God, public. So if I'll compile this, voila, I am breathing. And if you'll do the same thing with others, you might be asking this question that, what is this example showing? This example is showing that there was a function common in every class, YouTuber, engineer, and doctor, and that was breathing. So instead of writing that particular function in every class, what I did, I pulled that function on top of the class and created another class and put that function there and inherited that class in all these classes, so that that function will come in all the classes. So I don't have to write that function 3 times or maybe n number of times. This is one of the advantage of this inheritance. And another advantage is I told you that we can implement interfaces with them. And one more thing to notice that this case is not true all the time, because see, if YouTuber is there, they all have some work, right? This engineer will do some work, doctor will do some work, and YouTuber will do some work. And if there is a function called work, and that function is common in all the classes, you cannot pull that function up because they all work differently. What I mean to say is, YouTuber's work is to create the videos, engineer's work is to go into the company and work on the projects, doctor's work, we all know that they save our life. If they all have one function in common like this, void work, you cannot take out these functions from those classes. Okay, you might have understood this because this is very obvious case. So what you will do, you will keep all those functions with them without pulling into this class, and it makes sense. Human breathe, so you are taking that function into this human class and it makes sense. But if you will take this function which is work and put it here, then it might not be true for human class because every human doesn't work. So let's give the specific messages for all these, like creating videos, and engineer will be thinking for their project. So, and this another guy is saving your grandmom. Not a good example, but still. But I think you got the point here. Even though you have work function common in all the classes, you won't take them and put it into a common class. You will do this when it will make sense. So if you will do this now, like work, so YouTuber is working, and then engineer dot work, so this engineer is working, and then this d dot work, this doctor is also working, b. Okay, we got some issue here. Okay, these all functions should be public. Okay, what is this? Did we miss something somewhere? Okay, ENDL. Compile it again, dude. Gotcha. I'm breathing, creating videos. So this is YouTuber. I'm breathing, hello. And I'm working on projects. So this is maybe an engineer. And I'm breathing, saying your grandmom is the doctor one. So this YouTuber will call its own function, and similarly engineer and doctors will call their respective work function. So depending on the situation, you will use hierarchical inheritance, and you can achieve more than this, what I'm explaining you here, if you're having a good situation in your hand. So it's always depending on the situation, what you're dealing with. And if you want to see the real-time use of this particular inheritance, go ahead and watch my another video which is about static binding and dynamic binding, where I have used hierarchical inheritance and explained what is the difference between dynamic binding and static binding. And there are many things to cover in this, like if you are calling or creating, suppose YouTuber object U, then it is not calling the YouTuber's constructor first it will call human constructor, then it will call YouTuber constructor, and all that I have explained in my previous videos. So I don't want to repeat that again because it will be too much. So if you really want to enjoy a full series of inheritance, please watch my video from beginning, which is about introduction of inheritance in C++. That is a little big video, but you won't forget inheritance ever in your life if you watch that video. And please follow all those videos like single inheritance, multi-level inheritance, multiple inheritance and all that, so that you will have a full complete diagram in your mind that in what situation you should go for what inheritance. So I'll keep this video this much. Thanks for watching, and if you like the video, don't forget to hit the like button, dude, and make sure you subscribe to my channel so that you will get the notification for upcoming videos like this. Bye bye. Hello friends, welcome back. This is Rupesh and you're watching C Beginners video series on C++, and today's topic is hybrid inheritance in C++. So before this video, I have introduction part of inheritance, why you should use inheritance in first place, and single inheritance, multi-level, multiple, hierarchical examples. So if you have not watched all those videos, please go ahead and watch them so that you will be able to understand this little better. Because this inheritance is the combination of multiple and hierarchical inheritance. So you must be knowing what is multiple inheritance and hierarchical inheritance in order to understand this topic. Actually, it is not that big. If you don't want to go there and watch them, I can explain these two here as well. So let's give the pictorial representation of multiple inheritance. So multiple inheritance will look like this. Oh, this is looking like some face here. But no, this is multiple inheritance. So this is derived class and this is, let's make it base 1 and base 2. So two base classes are derived into one derived class, and this is the example of multiple inheritance. Not only two, you can have more than two classes. So this is the simplest example of multiple inheritance. And let's go for the hierarchical. And the hierarchical is actually the reverse of this one. So that would look something like this. We have base and we are deriving into D1 and another one is D2. So you can see that it's just the reverse. And by combining these two with each other, we'll get hybrid inheritance. That's why it's called hybrid. You know the meaning of hybrid word, right? Combination of more than two or two is called hybrid. So we will add more than one inheritance type and we'll call it hybrid. And I have taken these examples like student, boy, girl, male and female. Actually, it took a little while to find out the example because it wasn't easy, I'm telling you. So let's draw the diagram between these classes. So I'll just remove all these diagrams from here, and for reference, let's make them somewhere here for shorter introduction. So this is your multiple inheritance, and the reverse of that would be hierarchical inheritance. Okay, so this is multiple, this is hierarchical, and we will create hybrid out of these. So you might have guessed it. Let's draw that. Student is a class and boy and girl will be the student, obviously. So let's make them boy and girl. they both are student. But boy is a male, so there is this another relation here, male, and this girl is female. Okay, so this is the diagram. Now if you look closely, it is combination of these two. And to show you that, let me give you this example here. So this is looking like multiple inheritance. See, two different classes are inherited into single class. So here also student and female is inherited into girl. So this is the example of multiple inheritance. And similarly, if you will see male student and boy case, then also it is multiple inheritance because boy is inheriting more than two classes. And if you will see this one, can you find it here? Yeah, I can see that you have found it. So let me draw that for you. So if you will have this one, then it is hierarchical inheritance. Different classes are inheriting the same base class. Okay, so this is hierarchical and this is how it look like. So we have seen the example of hybrid inheritance, and it really took some time to find this example for you. But you know what? You can make a statement that it is not necessary that girl is student and boy is student. It is obvious that girl is a female, but this case is not a necessary case because there are so many boys and girls, they don't study, right? So nothing is perfect in this world. You can mold one type to another type very easily. I mean, what to say here? See, you can make this female also a male. So if there is some girl, so you can go for transplantation and become a male, and male can become a female. So in that case, everything will be a wrong example here then. But those cases are special cases and we won't consider them. And my goal was to explain you this, and I think we have achieved that. So let's see how we will do this inheritance in programming. So let's do that. So boy is a student. So public student, and for before that you must have this semicolon, and similar thing for girl also. So we'll do the same thing here, and let's take this male and female on top of it so that it won't tell you that I'm not able to find this and that. And yeah, boy is student as well as male, and girl is student and female. So this is how it should look like. So boy is student and male, girl is student and female. That's it. So this is what it shows here. This is the actual relationship, inheritance relationship. Now it's up to you what you want to include in student class, male class, female class, and all that. And just to give you the example, student generally studies. So we'll have a function studying. There could be a message like I am studying, don't disturb. So boy is student and girl is student. So we can call this particular function from boy and girl. But before that, let's make this public, otherwise we won't be able to call this one. So we will create a boy and give some name. I'll give Ram. So Ram dot studying. If you will call this, and let's compile. See, it is telling that I am studying. So student property have come into boy. Similarly, it will come for a girl also. So if you will do something like this, Ram and girl could be Sita. So much into Ramayana today, I don't know. But it's good to have some example which you can relate. Okay. So see, I am studying. So this Sita, no, Sita should be girl. I am so sorry for that. Okay. So if you will compile this, Sita is a girl and she is also studying, and Ram is a boy and Ram is also studying. So they both are studying, don't disturb them. And the motive of this function call example was to show you that if there is some property of student and you inherit that class into your own class, then that property would come inside your class also. But there is one more thing. It depends what is the mode of inheritance and the actual property access specifier. So if this property is private, let's do that. I won't go into much detail because I have explained this in my previous videos in full detail, so it will be not good for my viewers to watch that again and again. So I won't give you a full detail, but one small example. So if I'll compile this now, it will give you the error. It is telling that studying is declared private, so you cannot call that. Okay, so there are situations when you want to keep some function up to your class only. You don't want them to be inherited or to be accessible in derived class, then you make them private. Okay, so this private, protected and public, and here also you can have private, protected and public, and I have given almost all the combinations example in my previous videos. So if you are looking for something like that, please go ahead and watch the introduction part of the inheritance, which is the first video of this series called Inheritance in C++. You will get the link in the description field for full playlist. So watch the first video of that playlist if you're not sure what is this public, private, protected means in these two places. So I'll keep this video this much only, and if you have any further doubt, please ask. Consider me as your virtual teacher. I may take time to answer your question because maybe I'm sleeping when you're posting the comment, but you must expect the answer when you comment. Okay, so it is like I will always be there. Don't worry about that. So if you like the video, don't forget to hit the like button, dude. And make sure you subscribe to my channel so that you will get the notification for my upcoming videos like this. Right now I'm posting videos for C++ basic tutorial, where I'll be covering very basic stuffs in C++, and I have interview question series, so that if you're looking for a job, you can go ahead and watch that playlist. And I have C++ and C MCQ questions also, which will fine tune your small doubts. And later I'm planning to go for C++ 11, 14, 17 and latest 20. So in future you can expect to get all these topics, but for now I'm uploading for C++ basics tutorial. So as I said, don't forget to hit the like button and subscribe if you are interested in all these kind of contents. I'll see you in the next videos. Bye bye. Hello there, this is Rupesh and you're watching C video series on C++, and today's topic is multi-path inheritance in C++. So if you have not watched my previous videos, which is about introduction of inheritance, there I have explained why you should go for inheritance and where you will use that. And I have created videos for single, multi-level, multiple, hybrid, hierarchical, all type of inheritance. And you will get the list of the inheritance topic in the description field. So if you're not sure what are all those topics, please go ahead and watch them. You will get the full idea of inheritance topic. So let's start this multi-path inheritance in C++. So as it says multi-path, there will be more than one path from which you will get this base class into the derived class. So what I mean to say is, let's suppose this is A, B, C and D, and this is inheriting A. So both B and C are inheriting A, and this D is inheriting B and C. So why it is called multi-path? Because this A is coming into D from multiple path. A is coming from B and C both inside this D. So as the definition says, a derived class with two base classes. So this is derived class and it has two base classes B and C, and these two base classes have one common base class, which is A here, is called multipath inheritance. And this is one sort of hybrid inheritance because there are two inheritance type involved here. So this first part is hierarchical inheritance and this second part is multiple inheritance. So hierarchical inheritance plus multiple inheritance is hybrid inheritance. And this is one special case of hybrid inheritance where you have multipath inheritance, where this A will come into D more than one time. Because A is there inside B and C both, and you are inheriting B and C inside D, so A will come two times. And here we have taken the example of human, YouTuber, engineer and Rupesh. So let me just show you that example so you'll get the idea. So as you might have already guessed it, on top human will come, and then we will have YouTuber, and then we will have engineer, and then we have this Rupesh. So this is myself, and Rupesh is YouTuber as well as engineer, and YouTuber and engineer both are human. So ultimately, this Rupesh is also human. But the problem is, this human class is coming 2 times inside this Rupesh from YouTuber and engineer. What I mean to say is, if you will create the object of Rupesh and you will go for the memory layout of that, which would look something like this. We have this stack. So first it will have human, and then it will have YouTuber, and then again human, and then engineer, and lastly this Rupesh will come. So this is the object layout of your Rupesh, because Rupesh will have everything. Okay, so this is nothing but Rupesh object layout, where this Rupesh is nothing but whatever the data members are there only for Rupesh. So this is a class, and if I will have some data member inside Rupesh class like my name, my age and all that, so that data member is specifically for me. So that will come here. So let's write Rupesh data member. So if you will see this engineer class, this is engineer. Okay, so this engineer, okay, here we can see that this engineer is inheriting human also, and we are inheriting engineer inside Rupesh. So this collectively is engineer. So half of that will be human data members and half of that would be engineers data members. And similarly for this one also. So we have human data members as well as YouTubers data members. So this is how it would look like if you will create object of Rupesh. So you would have already noticed that we have human 2 times here. So that's why if you have human 2 times here, it is a problem. And there is a solution for that. The solution is you will inherit into these derived classes, I mean YouTuber and engineer, this human into them virtually. So there is a keyword called virtual. You'll use that. I will show you the example. Let me just only write this. So if you will inherit human inside YouTuber and engineer virtually, and later if you are inheriting into Rupesh, then human will come only 1 time. And there is an ambiguity problem if you will not have this virtual inheritance here. So let's write the examples and we'll see everything in practical way. So human is coming into YouTuber and engineer. So let's inherit them. So for simplicity, I'll inherit in public mode, public human. So you must be knowing what is inheritance for this, because I'm not going to explain you what is inheritance. And initially we will see without virtual case so that I can explain you the problem here. So public YouTuber, comma, public engineer. Okay. And we'll be needing one function here, breathing. Give one message, I am breathing. So this is exactly how you saw this one here. So let's create the object of this one. So Rupesh R and R dot breathing. But I need to have this in public, otherwise I won't be able to call this. Compile this. It is telling you the exact error what I told you. It is ambiguous. Member found by ambiguous name. Look up. It means it is telling that Rupesh is inheriting YouTuber and YouTuber is inheriting human, and similarly engineer and human. So it is telling that found multiple base class. So this is the error. I'm not sure whether the same error will come inside your compiler or not, because I'm using the latest compiler, so it is giving me a good error message. So this is the problem. Okay. So this human have breathing function, and that breathing function is coming here 2 times. Now let's see how to solve that problem. So as I said, you will be inheriting it virtually. So public virtual, and here also it should be virtual. So if we are inheriting human virtually here, I am not going to change code and we'll see the output. See, I am breathing. It means there is no ambiguity at all, and human is coming inside Rupesh only 1 time. And yeah, one more thing. This is a problem actually, and this is very standard problem. It is called diamond problem. This shape is kind of a diamond, right? So this is this shape and this is a diamond shape. And we solve this diamond problem using this virtual keyword. I have a separate video for that. If you'll search in YouTube diamond problem space CPP nuts, you will get that. So the important part to remember is this virtual inheritance here. Okay. So after including this virtual inheritance, the object layout would look something like this now. It will have human and then YouTuber, then engineer, then Rupesh. So you can see that human is coming only one time. You might be thinking that YouTuber is also holding human and engineer is also having human. Then how it is only one time? Because if you will typecast this whole object into YouTuber, then this one should have its own human, right? But wait a minute. When you will typecast this full object into YouTuber object, then it will have human and YouTuber. So this human will come here, and if you are typecasting this full object into engineer object, then it will have first human, then engineer. And yeah, again this edge will come here. And this engineer is coming from here and this YouTuber is coming from here. So you can see that this human is common for YouTuber and engineer both. And why it is common? Because you are typecasting this from Rupesh object. So this is Rupesh object. This full object is a Rupesh object. But if you will have separate object, let's suppose you are having a YouTuber object. I mean, you are creating it something like this. YouTuber Y semicolon. Then this Y will have human and YouTuber data member inside this. And let's suppose if you are creating engineer E semicolon, then this E will have engineer part, this one, as well as human part differently. So they both will have different human and YouTuber, human and engineer. Because you have created different object. So they both will have different human. But in case of this diamond shape, it will have only one. That's the use of this virtual here. So I think we have discussed almost everything. If I missed something, please let me know in the comment section. And if you like the video, don't forget to hit the like button, dude. It will help me a lot. And if this video deserves one like. Okay? So thanks for watching. Bye bye. I'll see you in the next videos. And yeah, make sure you subscribe to my channel so that you will get the notification for upcoming videos like this. Bye bye. Hello friends, this is Rupesh and I'm watching C Peanuts video series on C++. And today's topic is what is has a relationship and is a relationship in C++. And again, this is not only related to the C++, it is common in object-oriented programming. So has a relationship is a composition has a relationship. Actually, it should be is and is. It's my mistake. So has a is a composition is a has a relationship. Composition means, again, there are two types of composition. First is itself called composition. So first type of composition is itself a composition. So it's kind of weird, but this is how it is. And another one is aggregation. So I'll create a different video what is composition and aggregation. But the actual idea of composition is you will be having one class. Let's suppose you have one class vehicle and another class, let's call it engine. So my spellings and handwritings are not that great. Excuse me for that. And let's suppose these two classes are there. And obviously vehicle will have engine. In 99.99% they will have engine. Okay. I'm not sure about that 0.1%. So if you are creating a vehicle class, you will have engine in that. So engine, let's call it E. So here what you did, you used this composition which composed engine into vehicle. So there could be n number of classes, object or classes you can compose here. Let's suppose there is another class called tire. We can call it T. Okay, so vehicle will have engine and mostly tires and wheels and all that. So you will have different classes for every element and you will compose all those elements inside a vehicle. So this is composition. So composition follows, now concentrate, composition follows has a relationship. Okay, so vehicle will have engine, vehicle will have tires. So when there is a has a relationship, you will include all those components inside your class. And what is this aggregation? I won't explain that. I'll create another video and you might get the link in this video. If you're not getting, please let me know in the comment. So you learn what is has a relationship. You can see that vehicle will have engine and tire. So we have included that class inside this, and this is called composition. Now there is another thing. This inheritance is a relationship. So I have explained in the previous videos, if you have vehicle class and you have suppose another class called car, then you will inherit this vehicle here. So public and this vehicle like this. Okay. So when you will inherit, if you can say that car is a vehicle, then only you will inherit that. And that's why it is called inheritance follows is a relationship. So it's very simple. If it is inheritance is a relationship. If it is composition like this, then it is has a relationship. If you'll think, you'll understand this what I'm telling. Okay. So let's look at the code now, and I have given this 3 classes. So let's implement them. So as I said, this vehicle will have tires. So tire T. So this is your composition example. And if you have car, then you will inherit this publicly. Not publicly, you can inherit from any access specifier. It depends on the requirement what you are handling. So there are 2 things. First, this car is inheriting this vehicle. So this is nothing but is a relationship. Okay, you can say car is vehicle, that's why you are able to inherit that. And you are composing this vehicle using this tire, and there could be another class. Let's make that engine. And if there is something like this, you can have engine also. So this is the example of composition. So that's what it is. If you are confused or if you want to ask some question, please ask in the comment section. I'll be very happy to understand and answer you for that. Okay, so thanks for watching. I'll see you in the next videos. Bye bye. Hello friend, this is Rupesh. I'm watching C video series on C++, and today's topic is make a class non-inheritable without using a final keyword in C++. So you can make a class non-inheritable using final keyword. Before, this final keyword was there in Java, but later it came in C++ also. So the use of final keyword is, if you will create a class and declare it final, then you cannot inherit that class. Okay? So that class becomes non-inheritable. But this video topic is how to create a class non-inheritable without using final keyword. So for that we need a class. So this is the requirement for that. We need one class which will make our class as final class. So we'll be having one class and we will inherit some class which will make our class non-inheritable. And let's call that class a final class. So we'll create a final class which will make our class final. And we'll see the example. So the solution to this problem is make a default constructor for final class as private. So we will have final class and its default constructor will be private. So this is the first point, and you should follow these 3 points in order to achieve that. If you'll miss any one of these points, your class is not final class. Or to say your class is not non-inheritable, it is inheritable. So you have to follow these 3 points. So the first point is make a default constructor of final class as private. Second point is inherit final class as virtual. This is really very important. You have to inherit final class as virtual in our class which we want to make a non-inheritable class. And the third point is make our class as friend inside final class. And why will make our class as friend inside final class? Because only our class can call the constructor of final class, not the derived class constructor. That's why it will become non-inheritable. So these 3 points should be taken care if you want to make your class non-inheritable. So this was the trick before people were using if they wanted to achieve this final keyword behavior. But now no one uses this trick. Everyone uses this final keyword, but still they ask in the interview sometimes that, do you know this or not? So let's see how it is working. I'll create a class for you so quickly. So this is the setup for all these points here. So as I said, we'll be needing one final class. So this is the final class, and this is what our class which we want to make final. Okay, so we don't want this base to be derived inside this derived class. So we want to restrict this particular behavior. We don't want this to happen. So for that we need a final class, and this is our actual class which we want to make non-inheritable. So let's see these points again and discuss why it is important. So the first point is make a default constructor of final class as private. So as you can see, this is a default constructor and I have kept it under this private access specifier. And why it is needed? It is needed because when there is a derived class and you will create derived class object, it will try to call this final and it won't be able to call that because it is in private section, and derive will not call this final final class constructor using base class because it is virtually inherited. This is another chain which will help us to achieve this. We have to inherit using virtual, otherwise derived will call base and then base will call final and there won't be any issue. Are you getting my point? The thing is, you have this final, you inherited that into base, and this base is inherited into derived. Now if I'll create an object of derived like this, then it will call derived constructor first. So it will come here first, and if it is not virtually inherited here, then this derived will call base class constructor, and then that base class constructor will call final. And as we have kept this base class as friend inside final, it can call final even if it is in private area. So there won't be any issue. But if we are using this virtual inheritance and doing the same thing, then this is going to work like this. This derived will call base and this derived will call final. Not like this and from here to here. No. So this is the behavior when we are having virtual inheritance, and this is non-virtual inheritance. So let's repeat this again. If derived is non-virtual, then in that case derived constructor will call base constructor, and then base constructor will end up calling this final class constructor. So this is final. But if it is virtual, it will call in this order. Derived will call base and then derived will only call final. And here you can see that if derived will try to call final, it won't be able to do that because final is in private, so that you can avoid base being inherited into derived. Okay, so this virtual inheritance and making this final constructor private is very important. Now we have discussed 2 points: making a default constructor of final class as private and inherit final class as virtual. In our class we want to make non-inheritable. So we have inherited into base class using virtual, and we have created final class constructor private. Now the third point is make our class as friend inside final class. So why this is important? This is third point. Okay, this is first point and this is second point. This third point is important because let's suppose you want to only create base class object like this, base and B. So it should be allowed, right? And if you are not using this friend class base here, base will try to call this class constructor which is in private, so it won't be allowed. But as this class is saying that base is my friend, so it is allowed. So this is a trick, right? And we have to follow 1, 2 and 3 points. So I think I'm clear. Let's run this program and see the outputs. So for that I need to create one object of derived D. So if I'll compile this, it should give the error. See, it is giving some error here. It is telling that virtual base class final has private default constructor. So this is a problem. I can't do this. Okay. And as I said, if I'll remove this virtual, it will work. So let's do that. Just remove this, save this, compile it again, and see, it has compiled successfully. So that virtual is really very important. Don't miss that. So let's get it back and save it. And let's check another thing. If you will not make this as friend, then what will happen? But for that we need base class object. So let's create that base B and just remove this as well as this, because this will not compile if we have this. Okay, so let's save this and compile this again. See, it has compiled. So we can create base B if we have this kind of class structure. And it is obvious that you should be allowed to create base class object and use it with no problem. And yeah, we wanted to see this friend class thing, right? So if I will remove this and compile, it will give you the error. Obviously, because this virtual base class final has private default constructor will give the error. So actually this is making a call to the final constructor. That's why error is shown here. Actually error is not this point, error is at this point, but this is not logical error, and this is actually the correct way to give this error. So our 2 points are covered. Third point is making this constructor as private. So if let me just remove this comment, and if you will not make this as final, then whole game is over. You cannot achieve that. You just think about it, you will get the answer. If you will not create this final as private, final constructor as private, then Derived would be able to call this and this particular code will start working. So let's do that and check if I am saying this correct. Let's compile this. There should not be any error. Okay, we have not uncommented this. So let's uncomment this and compile it again. See, it has compiled and there is no problem in this code. Even though we have completed 2 points out of 3, but still it is not working. So all these 3 points should be fulfilled in order to achieve this behavior. Okay, so this should be private and compile again, and we got the error. Okay, so I think I'm done here. Thanks for watching, and make sure you subscribe to my channel so that you can get the notification for upcoming videos like this. And don't forget to hit the like button, dude. I will get a big help if you will do that, and I'll see you in the next videos. Bye bye. Hello guys, this is Rupesh and you're watching C Beginners video series on C++, and today's topic is how to initialize base class data members from derived class constructor. Actually, this is not a very big topic, but lately so many people were asking me, so I thought, okay, let's go ahead and create the video for this. And if you're a really beginner, you don't know this, so it's really cool if you understand how the calling work. So the points are, actually there is only one point. So the default constructor of base class is called automatically. So if you have a base class default constructor and you are just simply creating a derived class object, then the default constructor of base class is called automatically. We don't have to call it. Okay, actually you can call, but it doesn't make any sense. Compiler will do that job for you. But if you want to call parameterized constructor of base, then we have to call it explicitly. And this is what we'll see in this video. And the actual part is how to call that. You cannot call it as a function. So let's start the coding now. For that we need base class and derived class. Let me create that. We have class base and we have class derived, and you have derived this publicly. So base is derived into derived class, and let's create a default constructor which will have base and one parameterized constructor. We can have integer x. That x can be initialized with x because we have integer x here. This is a traditional example. Let's not go into much deeper. And now this is the time to create derived class constructors. So we have this default one, and let's create y comma integer x. And here goes the magic. Now notice this carefully. This is the syntax of calling your base class constructor. So you'll be writing base and pass x from here. So this is the syntax. So whenever you will have object like this, derived d, and we have 1 and 2, and you want to initialize this 1 inside your derived class
y, integer y, and you want to copy this 2 inside x, so you have to call your base class constructor like this. And if you are creating a derived class like d1 and that's it, you're not passing anything in that case it will call this one, and compiler will help you in that case and it will call this base class constructor. So this is like an automatic. You can write this, so you can actually make this explicit call, but you don't have to do this. Compiler will do this for you. But if you want to initialize this x, you have to explicitly write it. Okay, so let's give some message so that we can see how is it working. And down we will have parameterize constructor, and similarly we will have cout, and here we will have derived parameterize. And there is a way of calling. Actually the order is like this. See, you are creating the object, so it will call the constructor. So as you are passing the parameters 1 and 2, so it will call this constructor, not this constructor. Okay, and before executing this constructor, before going inside like printing this and all, it will call this base constructor. Okay, so it will not go inside and do the stuff. Okay, I just forgot to initialize y here. Okay, so this is how it would be. So yeah, I was telling that it will call derived first because of this, and then before executing derived, it will call this base class constructor. It will initialize this x first, then it will come back and initialize y and execute this. Okay, so I can show you that. Let's compile this. Okay, we got some error here. What is that? Okay, I just forgot to do this. So compile again. Okay, so this base class parameterize constructor, derived class parameterize constructor. So this is calling base class parameterize constructor first. As I said, it will not execute this one first. It will go and execute this one first and then come back and execute this. Okay, and similarly if you're calling this default constructor, because you're not passing anything inside this d1, then it will end up calling this derived, and again this is not going to execute itself. First it will call base class default constructor. That's why you're getting this base default before this derived default. And as I said, you don't need this, so let's get rid of this and save and compile. See, it is giving you the same output. So that thing is totally optional. It's up to you. If you want to write it, otherwise just leave that. Compiler will take care of that. So the main thing was this particular syntax. You should write this colon and then base class constructor name and whatever the parameter you want to pass. Okay, it should be like this only. You should not call this base, let me just do this, from here. Okay, it won't work. Okay, so let me just undo this. And it really makes sense that if you want to initialize base class data member, then you have to call base class constructors. You cannot initialize this x inside derived. And you know what? You may say that, let's suppose this integer x is a public. So let me just do that. We have this as public. In that case, this x is visible here. Okay, so this derived can see this x inside itself. Now you can do this. Let me just remove this, and we have just initialized y here, and here you can initialize this x is equal to x. So why this x? Because this x and this x both are equal, so there is no way to distinguish it. So I'm using this pointer here so that we can point to this x, and this particular x is this one. So we can do this, but this is not good idea. For that you have to keep this as public and protected, because if this is protected, this class can access this protected data members. Okay, so you should be knowing what is public, private and protected access specifiers in inheritance. But that's not the point. The point is you should not do things like this. If you are initializing your base data member, you should initialize it through base class constructors only, because there is a problem here. The problem is, actually I have compiled the code here. You can see that in both the cases this is calling base default and this is also base default. So here also we ended up calling base default. So anyway, you are calling only, okay, you can see that, but you are not initializing there, you explicitly initialized here. And generally we don't keep these data members public, we keep them mostly the private data members. So there is no way to do this. Okay, if you will compile this, you'll get the error. See, we got the error saying that X is a private member of base, so we cannot access it here. Okay, so the correct way of doing this is this only: colon, call the base class constructor with the parameter, and you're done. Okay, so I think we are done, and if I left some point, please comment. It will be helpful for others as well. And if you like the video, don't forget to hit the like button, dude. It would help me a lot. And make sure you subscribe to my channel so that you can get the notification for upcoming videos like this. I'll see you in the next videos. Bye bye.
Hello guys, welcome back. This is Rupesh and I'm watching C video series on C++, and today's topic is polymorphism in C++. And note down that it is very important feature of object-oriented programming. So again, this is not only in C++, it is there in almost all the object-oriented programming. So you might be wondering, what is polymorphism word? So let's break this. Poly means many, morph means forms. Okay, so there are two things involved in one word. So many forms. I know you didn't get anything. Don't worry, I'm there to explain that. So how would you map this many form inside your programming? If I'll tell you in the simple word, then it would be like so many functions with similar name is polymorphism in programming. And that's it. So if it is function and it is taking integer, it is different than similar name with function. This is fun, and it is taking character. So these two functions are totally different functions, even though name is similar. This is also fun, this is also fun. And similarly, if I will have some another fun without taking any parameter, this is different. And let's suppose if it is taking two different parameters, I mean integer, character, then that is different than rest of these functions. So the meaning is you must be able to distinguish it using the parameters you are passing in. Okay, and yeah, I know you might have think about what would be the return type then. No, you cannot distinguish two different functions only on the basis of return type, or I should say you should not consider return type. What I mean to say is, if you have two functions, one is fun and it is taking integer in that, and another one is also fun and it is taking integer, but this one is returning void and this one is returning integer, then you would say that this is different than this one, but no, this is similar than this one, because we distinguish similar function names with their parameters. And remember this, you cannot have similar function name with similar parameters. So here you can see that both are function and taking integer. So this is not allowed. So this was the basic understanding what is maniform or polymorphism in C++ or object-oriented programming. This example is more or less suitable for compile time polymorphism. There are two types. A is compile time polymorphism, B is runtime polymorphism. So you might have seen that function overloading and overriding if you're following my videos and coming through the full playlist. So yeah, these two things are forms of compile time polymorphism. So let's take the example and we'll understand better. So I'll quickly write the code for you. So here is the function. One is taking integer and another one is taking double. So let's create the object of this test class. Let's call it T1, and if you will call T1 and then function and you're passing some integer value here, let's make it 10 or something, and just compile this. You can see that it is calling integer function. No point of printing x, and also I won't be printing that. And let's do the same thing with this function, and this time let's pass double value. So double could be 10.5 or 10.0. Let's make it 10.5 and compile it again. See, first one is calling this one and another one is calling this one, this one. So you can easily see that with the similar function name, you actually can call the different functions. So it is possible, and let's see how it is possible then. Actually, whenever you are writing something like this, then compiler will see, okay, what is the best match for this function to be called? So it is T1, so test is a class and I should look into that. So it will find two functions with the same name, fun and fun. Now it will see, okay, 10 is an integer value. Is it taking any integer value? Yes, this one is taking integer value. Then I should call this function. So when you are compiling and this particular function will go into some memory area, it will write that particular memory area address and it will pass this 10 here. That's why it is called static binding also. Let me write that. This is also called static binding, and this one is called dynamic binding, or you call it lazy binding. There are so many names for them, but they all are actually talking about the runtime polymorphism. And yeah, if it is lazy binding, then this should be early binding. Early binding. So these are the names for actually telling the same thing. Yeah, so we were talking about this one. So you understood that how this will actually call this one and how this one is going to call this one. So this is the example of function overloading. And one more time, what is function overloading? When there are multiple functions with the same name, function, but the different parameters, here it is integer and here it is double, then these functions are overloaded. And this feature is not there in C, it is there in C++ only, because it should be object-oriented programming. Don't miss that. So we have seen function overloading. Now let's look at the operator overloading. For that I would need a different class. So let me write that one. So here is the class. We'll call it complex, and complex means we'll have real and imaginary in that. So this is a complex number. So it has real and imaginary, and here is the constructor for that. We won't be taking any value, then it will be initialized with zeros. So this is default as well as parameterized constructor, which I always prefer because you don't have to write two constructors, default and parameterized. You can actually club them into one. And here is the example of our interest. We wanted to see operator overloading, and this is overloaded, and we are overloading plus operator. So let's do that. Complex C1, and this will have 1, 3, and let's have another one C2, and let's make it 2, 5, and assign them into something else. Then let's make that C3 is equal to C1 plus C2. Okay, so you know that here it will call this particular function, and if you don't know why it is calling this and how it is calling this, I have a separate video for that. That is called operator overloading in C++. I have a full playlist for that. Please go ahead and watch that playlist. You will be very clear about what is operator overloading topic in C++. And for now, I'll tell you that this C1 is a calling object and this C2 is going as a parameter here, and we magically ended up calling this one if you don't know this. So this expression will call this one, and we are adding two things here. You can see that, and returning the result and assigning that result here. So we can just simply print that result by calling c3.show. Okay, so let's compile this. Okay, so you ended up adding two complex numbers. One with 2 is resulted as 3, and this 3 and 5 is this one. So this was the example of operator overloading. I can go and overload minus operator and all sort of operators, but this is sufficient just to give the example here. So we have seen function overloading, operator overloading. Let's move to the runtime polymorphism. This is very interesting. So let me remove all these things and we'll see that. Let me write the program for that.
And let's keep it little simple. We will have only base and derived, which will derive base, and we'll have public void function, and here also we'll have void function. And let's make this base, and here it will be derived. And let's make this one also public. Okay, now listen to me. When you go for runtime polymorphism in C++, then in that case you can achieve runtime polymorphism either using reference or pointer. You cannot achieve this without reference and pointer. What I mean to say is you have to use base pointer b is equal to new derived. And if you will call this now, wait a minute, I know it is not going to call derived. Let's compile this, and it is calling base. So still this is static binding. We have not included virtual here. Until unless you include virtual functions, there is no runtime polymorphism. I wanted to show you that. Now I want to show you how you will do that. So virtual keyword will be added here. So you want to make this function virtual in all derived classes. It means b is a base pointer, but it is pointing to derived class. So if you are calling some function, and if that function exists in derived class, then the idea is it should call that function. But in order to achieve that thing, you must have to have this virtual keyword associated with this function in base class, not in derived class. I'll show you the difference here. Let's compile this. See, now it is printing derived. So this is what our intention was, and we have achieved it. I'll repeat again. This is base pointer, but it is holding derived object, not its own object. So logically, if you are calling this function, which is there in base and derived both, but it is pointing to the derived object, so we will expect it to be calling to the derived class only. And we have achieved it using virtual here. And I said you have to use virtual here, not here. So let's do that. And yeah, one more thing. You can put virtual here as well as here. No worries. But there is no need of doing that, because your compiler is so intelligent that it will see that, okay, this function is here as well as here, and it is virtual here. So I have to consider this function as a virtual. Okay, so let's compile this again. See, it is giving the same output. So no need to write virtual here. Okay, I'll just remove that. Okay, and one more time, if we will remove this one, let's do that. Then it won't call function which is inside derived. Let's compile and verify that. See, it is calling base. So in order to achieve this runtime polymorphism, you must have a virtual function here like this. Then only you can achieve runtime polymorphism. And this is called function overriding, which is achieved using virtual functions. And there are two types of virtual function. One is pure virtual function, another one is normal virtual function. So if you are looking for that video, I'll create another video for that, but let's not mix up two things. So you have seen that how it is performed. I have one more point. Let's change this function with some parameter integer x. Now what? This is virtual. So if it is virtual, it should call this function, right? So let's compile and check that. No, it is still calling base, because now these two functions are totally different functions. Okay? Because it has parameter and this one does not have any parameter. If I will make this one similar, let's make this one integer y or something. This y and x doesn't make any sense. The only important thing is this data type. And I'll compile this again. Okay, we got some error. Okay, I didn't pass anything here. Okay, so let's pass one, compile again. See, now it is calling derived. Okay, so now these two functions are similar. So can you smell one problem here? Yes, I'm going to tell that problem. That problem is, even though your function name is looking similar, and you are thinking that, okay, I am overriding this function here, but you may or may not override because you have
some different parameters for this. So what I mean to say is you can have integer x here and you may have some double x here. So in this case, these two functions are different functions and you will not be able to call derived functions even though you're pointing to the derived one. Okay, so let's try that. If you will call 1.5 and it should call this one because we have virtual, but it won't call that. See, it is calling base 1. Understood? So this is the problem. Now we know that. So what is the solution for this problem? The solution is we have one keyword called override. And if you will use this, it will explicitly check that this particular function prototype exists in base class or one of the base class. Because this is a very simple example, it can have multiple and multi-level inheritance. In that case, it will check in every class whether I'm getting this kind of functions prototype or not. So if it is not getting that, it will give the error. So let's compile that and we'll get the error here. Yeah, you can see that it is telling hidden overload virtual functions base declare type mismatch first parameter. Yeah, see, type mismatch happened because it is telling that first parameter is integer versus double. Okay, so there is a type mismatch, and actually this is a note. This is not a error. The error is non-virtual member function marked override hides virtual member function. So it is hiding that. So we can make this one also virtual and compile this and see that what is the error. Error is fun marked override but does not override any member function. Exactly, this is what we were looking for. Okay, so I kind of think that if you're writing override, you must have this function name as virtual, otherwise it will give that weird message. I'm not sure about that message. I have not come across that ever. Anyways, this is what we were looking for. Compiler have told you that, dude, you was thinking that you are overriding this one, but you are not overriding this one. So let's make it integer now and pass some integer value. Let's make it 10. So we are passing 10 and this is also integer, this is also integer, and we are saying that I am overriding it. And let's compile this again. Okay, now it is printing derived. It means before we did some mistake, we thought that okay, both are same function, and mistakenly we did this double here, and we wanted to be so sure that we are overriding this function. So we wrote override here, and this is the solution for our problem. That what if mistakenly we are not overriding but we wanted to override. So always keep this in your mind that if you are intent to override some function, always write this override keyword here. And this is the syntax for writing that, and that's it. This is how you achieve runtime polymorphism in C++. And yeah, I told you that you can implement using pointers as well as reference. So let's make it using reference. So if it is reference, I have to use this reference, and then we have to refer some object here. So in that case, we need derived D, and we will refer that D here, and we should be calling using B dot. So this is the object of derived class, and we are referring inside base class, and base is not a pointer, so we won't be using that arrow. Now let's compile this. Okay, we got some error here. Exactly, I forgot that I have created it double here, and this is how you get the actual message. Okay, so this is just because of this override keyword here. Let's compile this again. See, derived. So we are able to call this derived if we are pointing to the derived. Okay, so it is possible only with references and pointers. So we have covered almost everything here, and don't ask me how it actually does. There is a magic behind this, something called virtual table and virtual pointers. I'll cover those topics in different videos. If you're not sure what are those things, I'll be creating a detailed video for that. Wait for that video. And thanks for watching this video. I'll see you in the next videos. Bye-bye. Hello friends, this is Rupesh and watching C Units video series on C++, and today's topic is size_t data type in C and C++. So yes, it is there in C and C++ both. And I'm pushing this video today because this is really very small video. Actually, I promised that I'll be pushing either new and delete operator overloading video or virtual function video, but they are very big and I don't have time for that. So maybe tomorrow or the next day you'll get that. Okay. Actually, I went out and couldn't get back on time, so this is the reason for that. So let's discuss about this one. You might have seen this size_t data type in C and C++ more often here and there, but what it is. So we'll discuss the size of t with these points. So let's look at the first point now. It is used to represent size of objects or variables in bytes. So remember this, it is in bytes. So if you're calculating size of your object or variable, the return type is size_t. That's this second point. Size of returns this data type only. Okay, so size of will calculate the size of whatever the object or variable is or the data type is, and it will give in the form of this size_t. And yeah, this size of is not function. Don't confuse with this returns word. And the third point is it guarantees to be a big enough to contain the size of a biggest object that system can handle. This is really very important, and this is the mainly, I guess, the only reason we go for size_t. Let me read this again. It guarantees to be the big enough to contain the size of a biggest object that system can handle. So if your compiler is 32-bit compiler, it means if you have compiled your program on 32-bit system, it is type def of unsigned integer. And you know how to use type def, right? We'll simply write type def and then unsigned integer and this size_t. And if it is 64-bit, if your compiler is 64-bit, it is type def of unsigned long. And this is the biggest size your memory can handle in 64-bit, and this one is the biggest size your memory can handle in 32-bit. Fourth point is it does not work on negative. Okay, it is never negative. See, it is unsigned in all the cases. So if you are assigning a non-negative value inside size of t, it is okay, but if you are initializing negative value inside that is undefined behavior. Your system can crash, you can have so many troubles. And these are the examples I wanted to show you, that some implicit functions, not some, actually so many. I have just taken 3 examples just to demonstrate that. When you pass something in malloc or in new also take size_t type only. So if you write something like new integer is equal to integer x, then this new is calculating the size of this one, and this should be pointer, and returning that much size to this x. But how it is calculating this size? So this new is actually the function. It will calculate this size here and pass this size into this new function, and this new function is somewhere in the system. I will give you the video for that, don't worry. That would look something like this. If you have new, then we have this size_t and number. So this new is calling this new function. I know this is not the actual syntax for new operator, but the idea is it is just passing this size_t, or to say it is taking the type size into this data type. And similarly, malloc also does the same thing. And here, if you'll see memcopy, which takes whatever is there at source location, will be copied at the destination location, but it asks you what is the number, how much you want to copy from source to destination. So you give some number here, right? So that number is also positive number. That's why its data type is always size_t. And similarly, you have this strlen function which will take this data type and return what is the length of the string. And that data type, that return data type is also size_t. So you can see that whenever your system is playing with the size or number, see this is number, okay? This is the count, okay? And this is also the count, but it is giving with size_t, not some integer or long or something. Because this guarantees one thing, it guarantees that it will hold the biggest object that system can handle. So you cannot return more than what your system can handle. So it's very obvious that you should use size_t in those situations. Okay? So to give you an example, let me just try this. We have one function, like suppose it is a print function. It's a very simple thing. We have this while and we have this count. Okay, and this count is coming from here. It is size underscore t, and this is count. And we just want to print something like what could be that? CPP nuts. Okay then, that's it. I'll tell you why I'm writing this. So first let me write this. It is 10. And wait a minute, this is not correct. This should be minus and minus. And let's compile this. So it has printed 10 times CPP nuts. There is no magic in that. Okay, so we got this CPP nut 10 times. Now the point is, I was playing with the size and I don't wanted this size to be negative because I don't want to print something minus 5 times or something. It doesn't make any sense. And if you are sure that it will never be minus, then you should use size underscore t as your data type, as these function does. Okay? I know this was not the great example, but it explained pretty well that what we wanted to achieve. Okay? So if there is something like count or number or something, then you should go for size underscore t if you are sure that it will never be negative. So that's it. I think we are done with this video, and if you have any doubt, please comment and don't forget to hit the like button, dude. It will help me a lot, and make sure you subscribe to my channel so that you can get the notification for upcoming videos like this. Bye bye. Hello guys, this is Rupesh and you're watching CPP Nuts video series on C++, and today's topic is Introduction to the Templates in C++. And I was on big vacation, so many people were asking that why I'm not pushing videos for so long. So from today onwards, you can expect videos. So the points are for templates, and yeah, this is going to be a very much introductory video of template. So there are two places where we can apply templates. First is function template and another one is class template. So remember this, either your function would act as a template or class, and templates are the way to write generic programs. So this is an important point. Using templates, either it is function or class, we write generic programs. Generic means it will work for different data types. You don't have to write the same program for different data types. The idea is that. Okay, so third point is very important point. The main point is we pass data type as parameter. This is the key thing. Okay, we pass data type itself as parameter to function or class, and that's how it becomes generic. So whenever someone is talking about templates, you just have to keep one thing in your mind, that there will be either a function or a class, and you will be passing the data type inside function and class. So when you are creating a class or using that class, you generally don't give or pass data type, right? I mean, when you are using some base class like this, base B, then you are just using this base and creating the object of that. You don't pass anything or stuff like that. But when you call function, so like fun, and you pass few parameters, right? So instead of these parameters, you will pass data type also, and we'll see how to pass data type inside functions and when you are creating object of some class. Okay, so I'll be taking example of a max function, which is a traditional example to understand this topic. So let's jump to the program and start coding. So now if I tell you that I have two numbers, integer x and y, they are initialized with some value, y is initialized with 20. And now I'm telling you, create a function which will tell you which one is greater than another one. Okay, so that function could be get max. So here you will pass x and y, and you can just simply print this get max. Cool, right? So let's create that function. We will be returning integer get max. It will take integer x, integer y, and from here we will return the bigger one. So return if x is greater than y, then return x, otherwise y. So this is our function, correct? So let's compile this and check that. 20. So 20 is the bigger one. So if you will make it, let's make it 180 and compile it again, you will be getting 180. So this function is working. Now what if I say you that let's have another one like character C
is equal to, and you have another character C2, and that is maybe X. And now you have to compare these two, and you want to find that which one is the bigger one. Either make it C1. Either C1 is big or C2 is big. So you wanted to find which one is bigger. So the problem is similar what this function is doing, but it is doing with integer X and integer Y, but you want it with characters. So you will end up doing or creating another function. Similarly, you will copy and paste this here, and you'll just simply change the data type, right? Character, character, and character. And here you are saying that get max integer. Okay, so let's change the name, and here you're saying that get max character and C1 comma C2, and let's change this name, make it get max character, and this one should be get max integer. So we got two functions, but actually they are doing the same thing. And yeah, one more thing, this will return a ASCII value of this character, so let's typecast that into character. So static cast character, and done. Let's compile this. Okay, see, this one is giving 180 because it is bigger one, and X is the bigger than A, so it is returning X. So till now we are good, but if you have so many data types, like maybe 10 or 20 data types to compare with, then you have to repeatedly create these functions again and again, even though they are doing similar thing. So here comes the template. Template says that keep only one function. So just remove this second one and give it as a generic name. So like get max. And instead of defining these types, you define a template type. So the syntax goes like this. You have to write template, then you have to write type name, and then T. So this you can write anything. So generally we write it like T, and this is your type. So just replace everything with this capital T here. Everything means types. So now you can see that you have this getMax function. This T and this T is nothing but this T, and this function is a template function now. I'll tell you what it means by being a template function. So first let's call that function. So just remove this max here, and as I said, you will be passing the data type to this function so that that data type will be replaced here. Okay, so the syntax of passing the data type is like this. You have to write it like this. You are saying that I'm calling this getMax, and this getMax will treat this T as integer. So this X and Y will be treated as integer here, and the return type is also integer. Similarly, if you are calling this getMax on character, then just simply write it character. Then you are saying that now this time getMax will catch this character here in this T, and then we will replace all these three T with character. So let's compile and check whether this is working or not. See, it is working as it is. So no need to write so many different functions just because you wanted to pass different data types. Okay? Maybe this time this character and integer is not a great example, because character can be typecasted internally into integer, but it will be very big advantage if you are using it on user defined data types like structure and classes, and you have overloaded this greater than on your class. And that I will show you in future, that how exactly it will give you the benefit when you are using it for user defined data types. Now you might be asking the question like how it is doing that. So actually when you are compiling this code, your compiler is creating two functions out of this function. Let me give you the example for that. So as I said, it will be creating two functions for this. So the functions would exactly look like this, but this T will be replaced with their respective data types. So if you're calling this getMax with integer, then it will create it like this. Integer. So you can see that it will replace everything with integer. And If you are calling the same getMax with character, then it will create another function. So this is one function, this is another function, and it will be similar function with characters here, like this. So there is no difference. It is exactly what you did without template. You remember you created two different functions with only different data types. First you created integer one and then you created for character. And one more thing, compiler creates these functions at compile time. So whenever compiler will encounter something like this, getMax, then it will check, okay, what is this data type? Then it will create a different function of this data type and it will check whether all the operations, whatever we are doing inside this function with this data type, this data type is valid. Then only it will create this function and start compiling forward. But if it is not able to compile, create this function with this data type, because you are doing some operation which is not allowed with particular data type, then it will fail at that line only. And yes, as you can see that if you are using this getMax with character, then only it will create this function. Let's suppose if you are not using this getMax with this character data type, then it will not create this function. Let's suppose there is another line where you are using not character, double, then it will create the same function with double data type here. So the main logic of template is you pass the data type, and this is the way of passing data type in function templates. So I hope you have learned what is function templates, and I know this was a very basic video, so I have not explained too much inside this, but if you're interested in templates, please watch my other videos, and if you have any doubt, please let me know. Thanks for watching. Bye bye. I'll see you in the next videos. And yeah, don't forget to hit the like button because it will help me a lot. Hello friend, this is Rupesh and I'm watching CV Peanuts video series on C++, and today's topic is overloading function template in C++. So yes, you can overload function templates as you overload the normal functions. And this is the example of that. But before this example, let me go back to the previous video's example. And yeah, if you are totally new and don't know what is function template, then you should consider watching my first video, which is about introduction to the templates in C++. And there I have explained these points, actually discussed these points and given some example. You might be thinking why I'm discussing the previous video. The point is, actually I forgot to mention one more thing in that video. So I thought, okay, let's take that in this video. So let's recap what is happening here. You have this generic function, which is a getMax, which will take t as a type and will replace this t with particular type, what type you are passing in from this getMax and this getMax. So this getMax was passing integer because x and y both was integer. Okay, so this you understood, right? But I forgot to tell you that there is no need of providing this data type when you are calling this function. It can actually deduce the type for you by comparing and matching the types. So no need of this typecast, and we don't need this particular character passing. Okay, so it will actually do that for you. It will search, okay, I have this getMax template function and it takes t and t. So this t is at this point will be integer. So this x and this y both are integer. So this t is going to be integer. So it can do that for you. So no need to pass that data type when you are calling this function. I forgot to mention that. So let's compile and check that correctness. See, it is working as it was working before. And yeah, in introduction part, I should have told one more thing, that instead of this type name, we can use another keyword called class. So instead of type name, you can use class also. Let's compile and check. See, it is working fine. Let's make it little more complicated by passing two different data types. This x and y both are of integer data type, right? What if I am passing one as integer, so one as 20 and another one as 30.5. So this second one is of type double. Okay, So this is integer, this is double, both are of different data type. Now what should be the case here? Actually, it will fail to compile. Let's check that. See, it has given some warning. It is saying that cannot deduce and conflict the type t integer versus double. Exactly. So what is the option now? So you know that you can define two types. So let's call this t2 and let's call this one t1. So this is going to be t1 and this is going to be t2, and now we may return t1 or t2. So let's, for now, you just return t1 and save. Now let's try to compile and check. See, it is working and it is returning 30. Why it is returning 30? Let's see that 20 is coming here. X is 20 and Y is 30.5, and t2 is deduced by double. So this t2 is double now. Now you are comparing x, which is 20, is greater than 30.5. No, it is not. Then it will try to return this 30.5, but it is going to return this 30.5 using t1, and you remember t1 was integer, this 20 is integer. Okay, so 30.5 became 30 because of this t1, and t1 was integer. That's why you're getting this 30 here. Correct? Now you might be thinking, well, this another case is working. C1 and C2 both are character type, but I am taking T1 and T2, so it should be different, right? No, it is not required. When two parameters you are passing are totally different, then you should be taking them as different data types. But if they are similar and you are taking them in different data types, then it's okay. Actually, it is type deduction, so it will try to deduce this T2 and T1 with character only. Okay, so this is character when it is calling this function. But when it was trying to call this function and you had only T data type, not T1 and T2, so it was confused. Okay, there was a confusion between integer and double. So now there is no confusion. Now here you might be thinking that why I am not getting this 30.5. I am getting 30, right? And the actual behavior would be 30.5. So how to achieve that? Let's make this one as T2. So this is not correct way of dealing this, but for now it will work. See, now it is 30.5. But what if someone does this? Just copy and paste this, and instead of this I am passing 30.5 here and 20 here. Now what? Let's compile this. See, first one is giving correct output, but second one is still giving the wrong answer for you. So how to solve this problem? To solve this problem, we can pass a third data type which will say that this is going to be the return type. So you know that the bigger data type from these two are double. Okay, so you can explicitly pass this double here and here. So now you're passing this double, and let's take this double as third parameter. So we can take this class return type. So I'll call this RT. So this is going to be return type. So let's make this one return type. Save this, compile this. Okay, we got this error here. Okay, this error is because of this third one. So just remove this and try to compile it again. See, this time you're getting 30.5 and 30.5. This is what we expected. And if bigger item is integer, so let's make this 30 and this 20.5. So this time this should return 30, right? So let's compile and check. See, it is giving 30. So this is a perfect code, but here you have to pass this double as return type, and you are assuming that this is the biggest data type of these two, so it can accommodate 20 as well as 30.5. So you are writing double here. It is okay, you can do this. But there is another way to solve this problem without sending this data type or the return type, and that is something like this. So for that, let's remove this double from here and this from here, and we don't need this return type. And yeah, just forgot to mention one more thing. You might be thinking I'm just passing one double, and why this double is going inside this return type? What about this T1 and T2? Actually, it is auto reduce mechanism. So this double is the first parameter because you are not passing rest of the parameters. So rest of the parameters will be automatically reduced by the, rest of the types will be auto reduced by the parameters type. So first is double, so this RT is double, this is going to be integer, so this T1 is going to be integer, this is double, so this is going to be double. So this is how it will work in this case, okay? Although you can just specify all these things explicitly, so you can write integer, integer and double, and here you can write double, double and integer. This will also work. See, it is fine, okay? So this first parameter is going to be the first parameter for assignment, first type, okay? So this is the mapping, first, second, third and third. And in case if it is not able to auto reduce, it will throw error. So I will not go into that deep. So let's remove this, and we were talking about how to make it work without giving the third parameter, what should be the return type, because sometimes return type is T1 and sometimes return type is T2, so it is confusing, and we had to give the return type explicitly in RT as double, so it was working. But if you don't want to give that, then what is the workaround? And let me remove this, and there is this something called auto. This will try to reduce the return type automatically. So this auto will find the return type and reduce that type here. So let's compile and check that. We're getting this error. Deduce return types are a C++ extension, 14 extension. Okay, my compiler is little old. It is saying that this mechanism is only available inside C++ 14. So till C++ 11 there was something called decal type, and inside this you give this expression Control C, Control V, and then this arrow. So this shows that you are going to use a trailing return type mechanism. So let's compile and check that. Okay, now it is working. See, 13.5 and 13.5 in both the cases. So this is C++ 11, I guess, but in 14 you don't need this. This is an extra headache, right? Why you want to tell that declare a type of this expression, so it will check it whether X is going to be the final result or Y is going to be the final result, and that will be reduced as return type here. Okay, so this was a problem. So let's remove this, and now in order to show you that it is really working, let's go to online compiler and I will show you that this code is working. So let's go to the online compiler here, and I'll use IDE1.com, and this is C++ 14. Copy that older code, copy, paste it here as it is, no modification. And if you're not able to see this, let's increase the font size. Okay, now you must be able to see this, correct? So the code is exactly similar. We are trying to use this auto for return type. So let's run this. Okay, see, it is working, 30.5 and 30.5, and our compiler is C++ 14. Okay, so in 11 it was not working, but in 14 it is working. So this is the way of getting the return type if it is dynamic, because sometime X could be the bigger one and sometime Y could be the bigger one. So our data type for return will change, and you will achieve this change like this. Okay, now, so we are done with this. So let's go back and start our main video topic. So I haven't explained this function overloading in templates yet, right? So you might be thinking that I have taken so much of time to explain the basic one only, but this is not going to take much time. It is actually already ready. So our main topic was overloading function templates in C++. So these are three functions: max1, max2 and max3. So all are max. This is non-template, this is template, and this is template function. And if we will call this max, and yeah, I'm using this scope resolution operator just to specify that this is not the internal max
function, I'm going to use my own max function here, okay? Because there is one max function given by the library itself. And by using scope resolution operator, I'm saying that I want to use this max as the global scope here, okay? Now, if I'll pass this max 10.0 and 20.0, it should call what? Which one it will call? See, this is a normal function. So this max will be called when you are calling with integer and integer. This is a fixed function when you will call integer and integer. Okay? There is no other way to call this function. So this is double and double. So you cannot call this one. Let's see this one. So this is t and this is t, and this is template function, and it takes 2 argument and both are equal. So this is t and t, so it should be either double double or integer integer. Okay, so it will call this function because this function takes 3 argument a, b and c. So see, you have overloaded max function when you are using templates, and there is no much difference, only minute difference, and you will understand those difference. So this one is going to call this one. I'll compile this, but before that I should be explaining what is happening here. Now what about this one? This one will also call this only because this is character. So this time this t will be replaced with character. So this is going to be character and this is going to be character. Now 10 and 20, this is going to call this one because this is total integer call and we are not using template call here. So 10 and 20, this is going to be called this one. Now we are calling 10 and 20 but with this template sign, which is saying that don't use this one, search in template max function. Because of this sign, it will search inside this or this. So as this is taking 3 parameters, it will try to match the requirements. What is the requirement here? Both should be with the same type. So this is integer and this is integer. So t and t can be replaced with integer. So this is going to call this one. Okay. Now let's see this one. This is obviously going to call this one because first is you're calling a template function and this is 3 parameters and this is going to take only integer, but as you are using template parameters, it only calls template functions and we have only 2 template functions, this one or this one, so it will call this one. And this t will be replaced with double now. So double can accommodate 10 and 20 without any problem. So this is going to call this one. Now this is very interesting because this code is interesting. So it is obvious that it is going to call this function. Now inside this I am calling another max and max 2 times. So see, this 10, 20 and 30 all are integer. So this t will be replaced with integer. So it is like this: integer, integer and integer. And as this is the first call, inside this there is this another call. So this is also max, integer, comma, integer call. So this call is integer and integer because a and b both are integer. Okay. So you remember when you was calling max with integer and integer, it was calling this function. So now this will call this function. And as it is returning integer here, so this full call will be replaced with one integer number. So this integer with c, which is integer, so again it became integer and integer call. And this time this is this max call. So again it is integer and integer, so it is again going to call this one. Okay. So this function, this function call is 1 time this function call and 2 times this function call. So you might have got the idea. So let's compile and check the correctness of this function's calling. So let's compile this. Okay. So this one is calling the template version max tt. So that we know it is going to call this one because this is double and we don't have anything for that. And this is character. So this is also going to call this only. See, we are printing this max tt here. And here we are printing max integer. So third one, which is 10 and 20, is going to call max of integer and integer, which is this first one. And make sure you are on the track, okay? So this is this call. Now let's look at this call. So this is also 10 and 20, as this was 10 and 20, but this is a template call. So it will search for template versions. So we have only 2 template version of max. So this is taking 3 parameters. So we'll cross this. Only one is there, and it suffice all the things what we need to call this function. So we will end up calling this function. So this is the call we are getting because of this one. Now this again TT is coming because we are calling this with double. So again it will call this one. Now we can call our last TT and T. So this is TT and T, and this is the call for this third function, and 2 integer calls. Can you see this? I told you that when I was explaining this to you, that this function is going to call this one time and 2 times this one. So can you see that this function is calling this TTT version and then 2 times integer and integer. So it was very simple, right? Just I wanted to explain and highlight all the points. Maybe it is not all the points. I may forgot something. So if you know something, then please let me know in the comment section. I'll be very happy to include those things in the next coming videos, because I am going to create a series of templates and I would like to cover almost all the points from beginner to advanced, not super advanced, but from at least beginner to advanced. So thanks for watching. Bye bye. I'll see you in the next videos. Hello friends, this is Rupesh and I'm watching CPP Nuts video series on C++, and today's topic is Template Specialization in C++. So before this, you should be knowing what is template in C++, then only you watch this video. Otherwise you go ahead and watch my template videos, then you come back and watch this one. So let's start this video. So the first point for template specialization says that sometimes we have to specialize template for particular data type. What do I mean by that? So we all know why we write template, right? It is used for generic programming. Let's suppose you want to do some operation and it is independent of the data type you want to work with. So you will create one function or one class, and that particular function or class will work with all the data types. But this is not true in all the cases. Let's suppose your template will work for 2 or 3 data types, but it is not working for the 4th one. So what to do in that case? So this full topic is for that purpose. I'll repeat this again. There is a scenario that your template function or class is working for 2 or 3 data types, but it is not working for the 4th data type. Then what to do? So for that, I have taken this requirement, which is add all the elements in the vector. So this is the requirement. So spelling is not correct. Okay. So we'll be adding whatever is there in the vector. So vector can contain integer, double, character, or anything. So when the requirement came, it was like we'll be working on integral data types only, or at least the data types what you can add, like you can add integer, float, doubles, and characters with each other, right? So let's implement that first, then we will see where you will use specialize. Okay. So what I mean to say is, let's suppose you are having one vector here. So this is your vector of integers, and let's have another vector of double, 0, and like this, everything with 0. Okay. So this is integer list and this is double list. Okay. So we want the functionality regardless of what type it is. We just want whatever is there in the vector. I want addition of all that. Okay. So let's create that function. So let's check whether this is working or not. So let's write this cout and call this function add all with integer vector first. So vector of integer, and another time we'll call the same function with vector of double. It should work in both the cases. Okay. So let me save this. We'll compile this. Okay. This template is misspelled. Template. Sorry for that. And compile this again. Okay. Oh yeah, maybe I forgot this
vector here. I know you might be shouting from your end, but I was not listening. Compile again. Okay, another problem. Wow, what is this? Okay, actually I have solved it. The problem was I was not selecting this proper compiler here before I was selecting this C++ single file which is not configured well. So this C++11, if I'll compile this, it will give you 21 and 21. So as you can see that our code is working for both type of the vector. One contains integer, another contains double here. Okay, so we are fine. We don't have any problem here. So now let's come to the actual point here. The point was, what if you have some data type which you cannot add directly like this? Actually you can add, but you want some special behavior for some particular data type. What I mean to say is, let's suppose you are having some vector of string. Let me just copy paste that. Okay, so there are 3 string in this vector. This is vector string, and whenever you have vector of string, you don't want this behavior. You want some another behavior, and that behavior is ultimately you want to get the ASCII value of each and every character added. Okay, so you want the addition of each and every character's ASCII value. So this is what you want. So as you can see that you cannot achieve that with this function. So you have to create another function, but not with the different name. You wanted to have the consistency, so you will create add all function only, and that too with template type. So that is what specialized template means. For some special data type, you will create another function with the same name and same stuff. Okay, but you want different behavior, that's why you are creating different function. You will get to know that in some time. So let me just write that quickly. Okay, so this is the behavior. What I did, I created add all function as this was similar to this one, and instead of getting some type, this type is totally empty. It means that I have specialized this particular function for this particular data type. Before this, t was integer in case of this vector integer and double in case of vector of double, but I wanted special behavior, that's why I used this different function, because I wanted something else to do with my elements. Okay, and notice this, if you are specializing this function, then your function's signature should look exactly similar. I mean, when you are using string here, then here it should be string. Okay, because when you are using t here, your return type is also t. Okay, so when your input type is string, your output type should be string. Otherwise it won't be specialized. It will give you error that I'm not able to find the function for which you are specializing me. Okay, it will say that I am not able to find that particular template here. I mean, there is a template mismatch. Or in other words, you can say that this function will work with most of the data types, but there is some special data type I want to be handled a little differently. So this is the function for that. And this is also a template function. Okay, so let's see how it is working. So as you know that this is a new type of for, and what I'm doing is I'm iterating over my list, which is containing all these elements. So first time I will get this ABC inside this element, and on that element I'm again iterating so that I can get A, B and C separately. Okay, so A will come inside this char, and whatever is there will get added. I mean, the ASCII will get added, and I am maintaining a count with integer type. So once this for loop will be over, we'll be having the count, which will be the addition of all the characters ASCII value. Okay, now the point is I cannot just simply return this count because this count is of integer type. I have to convert this count into a string. So what I did, I created this oString stream. I inserted that count inside that, and then I'm converting that oStream into string, and this is the string, and now I'm returning that string count. So this contains actually this integer count value but in string format, so that I can just simply return that. Okay, so let's see the calling of this one. So cout add all, and this time we will send vector of a string. Okay, and let's compile this. Wow. Okay, it is saying that I just forgot maybe the header part here. Yeah, the header for this is hash include s stream. Let's compile this again. Okay, now you got this 8, 9 and 1. Okay, if you're not sure that whether it is really adding all the characters in the string, let's reduce the size of the string. So only just adding a and b will give you 97 plus 98. Okay, so let's compile that. Okay, 195. So 197 plus 198 is 195. Correct? So you saw that your function, this template function was working with these two data type, but after some time there was a need that you have to create a vector of string also, and you have to give the same functionality but with little different meaning. Okay, so that's why you created another function of your template function, which is the specialization of this function. You have specialized for this particular data type. Okay, I think the purpose of this video is clear now, and yeah, we can specialize both function and class templates. So as I have created this function which is specialized for string data type here, you can create another class specialized, which is specialized for some different data type. Okay, so that is kind of a homework for you. Thanks for watching, and if you like the video, don't forget to hit the like button, and if you have any doubt, please comment. I'll be very happy to answer your comments. Thanks for watching. I'll see you in the next videos. Bye bye.
Hello guys, this is Rupesh and you're watching CPP Nuts video series on C++, and today's topic is Introduction to the Threading in C++ or C++11, because this threading, which is this thread header, was not there before C++11. So if you want to practice this, you must have to have this C++11. Okay, so that was first thing. Second thing is this is not related to the OS threading. How OS take care of threadings and how they are actually managed in processes, how they share the addresses and all that. This is really not about that. This video is about what do you understand by threading, and give some example in C++. So this is actually a C++ threading. How you create threads in C++ and what benefits you get if you use that. So the answer for this question is not that simple, but I have tried to summarize it. Like, in every application, there is a default thread which is main thread. Okay, so whenever you write some program like this, you have some main function, and from here your program starts and it ends here. So whatever you write in between, if it is not threaded application, it will be a single threaded application, because main itself is a single thread. This function is not threading. You can tell this function a single thread, obviously, because OS runs this function, and if there is no thread, this is the only thread. Okay, so that is the only thread if you don't have any thread. But if you want to create threads, you have to create that inside this main thread. Okay, so I'll explain what is threading. I cannot get the actual sentence how to explain that. I will explain with the diagram and calling structure. So wait for some time. And lastly, we will see an example that you really get the benefit of using thread.
Sorry, I'm not sure.
Oh, why did my Alexa wake up?
Alarm for what time?
Sorry Alexa, I have to stop you. So where I was? Yeah, I was talking about, lastly you will get the actual use case why you should use thread if you can. Okay, we'll see the benefit. Your full program will run in half of the time how much it was taking before if you are not using thread. So let's move to the next point. A thread is also known as a lightweight process. So what is process? When you create an application, or in Hello World, if you create a simple program like this is an application and a process. When you run this becomes process inside your operating system.
And if you have not used any multi-processing or multi-threading stuff inside this is just one single process. Okay, so a thread is also a lightweight process. What is lightweight? Actually, process itself is a little bit heavier because it has to have so many things. But if you are creating a thread inside a process, that thread is little bit lighter than the process because you don't have to manage different stuff because threads actually run inside process. Okay, so you can assume that process as a big entity and threads inside that smaller entities. And the idea is to achieve parallelism by dividing a process into multiple threads. If you can create multiple threads, I would say you should create. And for the examples, I have written few lines here. The browser has multiple tabs that can be different threads. So you see so many tabs, right? In browser, they are different threads. If you will open different tabs, they all are handled by threads. Okay, so second point is MS Word must be using multiple threads. One thread for formatting the text, another thread for processing inputs. So you might have used MS Word or something, any editor for sake, and you would have noticed that whenever you type something, it formats your text in some order, whatever order you have selected. So that is nothing but a thread which is running in the background, and it is taking the input, whatever you're writing, and formatting it in some way or other. And another example is, which is a very good example, I used to give this example when I was giving interviews. This example is spell checker. You write something and it will pop up like, oh, you didn't write it correctly. So how that happens? Because you didn't press any button, then who recognizes that you're writing something wrong or right? So it's thread which is running in the background, and as soon as you write something and hit space, it will check that particular word and find in the dictionary whatever it maintains whether it is correct word or not. So that is a good example of threading. So third point is Visual Studio Code Editor would be using threading for auto completing the code, or it's called intelligence. So if you don't know what is intelligence, let me give you the example. So as soon as I start typing, see, these options are coming, right? Like, am I supposed to write INC, include, intelligence, introduction? So these things are coming from some thread. That thread is taking my inputs, whatever I am writing here, and it is matching with its database. If it is able to find something, it is giving me the options here that whether I will be liking this one. So like this. Okay, so this is also a thread running in the background. Okay then, so this was about threading, how it actually looks like. Okay, so you might have understood how thread actually works, I mean in the layman language, but we'll see the example, concrete example, in a couple of minutes. Now, ways to create threads in C++. Actually, this topic is another topic. I mean, I'll create this topic after this video. There are actually 5 ways you can go in C++ if you're creating threads. So function pointer is the point we'll be looking here, but rest of these we'll see in the separate video because everything has its own syntax, and that is really very important. So far so good. Now let's discuss the requirement. What is the requirement here so that we can create a program for that? So find the addition of all the odd numbers from 1 to some number. This is very good number. Actually, it took so much time for me to find this number because it was not easy to find some number which is giving you the expected output what you want to show. Okay, and all even numbers from 1 to 10. So basically what I'm trying to do is find the sum of all the elements from start to end. Okay, so even sum and odd sum, and lastly I'm just printing them. So these are the functions. This is start and this is end. Okay, and this ULL is nothing but unsigned long and long. I have typed def it so that I don't have to write this again and again. So you can see highlighted places. I have to write these many places, unsigned long, I would have grown old. Okay, now as you can see, this is fairly simple program, and you know the working of this program. I know that really very well. You will call this function, it will be called with these 2 parameters. It will come here, it will do the job, it will do the sum, come back, another function will be called, it will do its job, and then it will come back and you will do this. So can you see a thread here? It is single thread. Let me give you an example here. So your program started from here. It saw that, okay, I have to run find odd function. Okay, it went to that find odd function, completed that, came back to this find even function. Okay, it has to go and execute that also. So it went and executed that also, but it came back again and then it executed these two and return. So can you see this? There is only one thread. There is nothing like it is running from here to here and something else is also going on somewhere in the background. No, nothing is going on in the background. So this is kind of a single thread. There is no parallel processing here or multi-threading here. So let's quickly run this program and see how it works. So this is the command for compiling this, because I'm using threading here. So you have to write this pthread and std C++11. This is a very important point because you cannot have this threading until unless you compile it with C++11. So I have not written any threading, but still I will compile like this. It's okay, no problem. So I have compiled it. Let's execute that. Okay, so odd sum is this much and the 1. Okay, so you would have noticed that it took quite a amount of time for calculating this. That's what I needed. Now if you want to know how much time it took, we can calculate that. So wait a minute, I will use something like this. So this is going to be your start time. Okay, so what we are doing is we are taking the start time when we actually want to measure the work here. After that also we are doing the same thing, and stop time doing the difference, and this is the difference. So let's print out the difference as well. So that printing will go here. Okay, so this duration is the result, how much time it was taken, and count, and this is some number which will give you the seconds, because this will give you maybe in microseconds. So converting that into some seconds. Okay, I'm not that good in maths, so leave it. So this will give you the seconds. So let me just write that seconds. Okay, we'll compile this again. We'll run this. Now it will give you the time it took to actually complete this calculation. So it is taking 4 seconds. Okay, good. So I assume 2 seconds for this one and 2 seconds for this one. I mean, that's what it would have done. So total 4 seconds. So now keeping this as a benchmark, we will see how we improve if we use thread. So let's implement the thread now. Now concentrate here. This is the syntax. Now I'm going to explain the syntax. So now open up your eyes. Thread, you have to write thread and T1. This is the name of your thread and you're done. But thread needs a callable object. That's what I said. You need to have these things inside thread so that thread will run them. So as I said, we'll be using function pointers. So I'm going to give function pointer here. So first I will give find even, and this is start and end. Okay, and similarly thread T2, and this time find odd, start, end. Okay, so this is the syntax for function pointer. So if you will create a thread, this is thread, you have created it. As soon as operating system will run this particular line, it will create a thread for you, and that thread will run this function. So threads needs functions, callable stuffs like functor or lambda function or static or dynamic, static member functions or not static member functions, because it has to run something, right? So that's how it works. And after defining what it should run, you have to give the parameters. So this is the parameter section. You can give as many as you want. There are a few points, like if you want to pass these parameters as reference in the thread, you have to use some stdref. So we are not going to discuss all those things. And the same thing goes with this one. Now, as I said, as soon as this is hit, thread is created. Now there is something called joining the thread. T1.join. I won't talk about this join much because it will take so much time. Actually not so much time, but I decided to make another video for this. But for now, you just understand that if you will not write this join, these threads will not be joined to your main thread, and they will be running and if your main thread goes off, I mean if it is completed but your threads are not completed, then there is no way to get the results of these threads, okay, because your main thread has gone. So you have to join these thread with your main thread. That's why you're writing t1.join and t2.join. So what happens when you write this? Actually, when your OS is creating thread, it will start running this function. Okay, so it will actually call this function and come back, and this function is keep on running, and meanwhile it is back and it will create another thread. So this will result into running this function, and this will also come back. I mean, there is no single thread now. I'll draw the diagram, don't worry about that. And they are continuously running, and it will come, I mean your program controller will come back and it will run this t1.join. Now you won't move further, you will wait for the t1 to complete to go further. Okay, and let me comment these two functions because now we are going to test these functions with thread. Okay, it's that simple. Threads are created. Now you're waiting for those threads and they are running in the parallel. Now there is no calling like find odd will be completed and it will come back and then it will call find even. No, they both are running in the parallel thread. Okay, and we are waiting for them here. So let's see what is the output now. I'll create a diagram, don't worry. So let me run this, compiled successfully, run this, and now notice the timing here. It took 2 seconds. Same program, we didn't do anything, we just ran this find even and find odd in 2 different threads. And as I said, maybe this one is taking 2 seconds and this one is taking 2 seconds. That's why we had to complete this one and come back, and this one, that's why it was 4 seconds. But this time we were running this one and this one parallelly. I mean these two functions parallelly. So it took 2 seconds only. You can understand that, right? And if you still find it difficult to understand, let me give you an example with some diagram. So as I said, when you will hit this line, I mean when your OS will hit this line, it will create a thread. So instead of going to this function and waiting for this to complete, it will go to that function, and let's assume there is this find, what is this, even. So there is this find even function, and this is the function. So what this thread will do? Okay, you start. So this function is actually running and it will come back while it is running. Okay, it is occupying the processor and doing its job, and your main thread is actually back and it will execute this one. So this is also another thread calling. So this will go to find odd function, and let's suppose this is that function. So it will start running this function. So this function is also running and it will come back. Okay, and this is also running and this is also running while this thread is doing all these stuff. So it created this one first. So it was actually running when it created this one. So this one is also running now. It came back and now this one was executed. Now as soon as it hits this join, it will know that okay, now I have to wait for this T1 to complete to move forward. So your main thread is waiting for this find number to come back. Okay, so actually it was running and it took maybe some 2 seconds and it came back, and you have to wait for T2 also. So this also took 2 seconds, but as they were running parallelly, both took 2 seconds together. It's not 2 plus 2 because they were running parallelly. So T2 has come. So now you can move forward, check the timings, do all these stuff, and you got the result. So this is how it works. You remember before you actually go to that function, in this case, you actually go to that function and be there till that is finished. And you will be back, I mean your control will be back to this main function, and then you will go for this find even. And that will also take 2 seconds and you will come back and do all these stuff. So that's why it was 2 plus 2. But now in threading, it is running parallelly. So that's why it took only 2 seconds. And I think this much is enough to explain how threading works. So if you liked the video, don't forget to hit the like button, dude. It will help me a lot. And if you have any suggestion or something, most welcome. And don't forget to see the next video, which will be coming in maybe 1 or 2 days. And that is about how many types are there to create threads in C++. So actually there are 5 types. Okay. And we'll see all the syntaxes and it will be fun. So I'll see you in the next videos. Bye bye. Don't forget to hit the like button, guys. Love you. Bye bye. Hello friends, this is Rupesh and you're watching CPP Nuts video series on C++, and today's topic is type of thread creation in C++ 11. So this video is going to be a very basic video. There we'll be talking about only how many ways are there you can create threads in C++. Okay, using callable objects. So I hope you have watched my previous video, which is about introduction to the threading. There I have discussed few basic points and the reason why we should use thread if we can. And there I used a function pointer. Okay, so if you're coming from that video, you must be knowing what is function pointer. I mean, how to call thread. This is T and it's an object of thread type. You are calling this function as a thread, passing 10 as an argument. Okay, so you might be knowing this very well, but there are 5 different types you can create threads in C++ 11, including this function pointer. So we are going to discuss all those things here. Now, there is a note here. If we create multiple threads at the same time, it doesn't guarantee which one will start first. Okay, let's read this again. If we create multiple threads at the same time, it doesn't guarantee which one will start first. What I mean to say is, let's suppose you are having this std thread t1 and you're calling suppose some function with 11. Okay, and this is going to be your thread 2 and you have this thread 1, copy paste, thread 2. Okay, this is perfect code, right? So you are creating t1, t2 function and function. So there are 2 threads creation here. Now what I mean to say is, it is not guaranteed that t1 will be created first and then t2. No, sometime it may happen that t2 is created first, then t1. Okay, so as this is your first type of thread creation, which is function pointer, you know very well like how it will work. You will create a thread. Let me just remove this t2 part here because we don't need this anymore. Okay, so t1 will be created. Function name is used as function pointer because if you will write only your function name, that is a function pointer, and this thread will be created. So it will print some 11 to 0 or 10 to 0. Okay, so this was the first type. Let's move to the second type. Let me just comment this. So second type is your lambda expression. Okay, you might have seen this already. So this is your main function. You have this lambda function, and yeah, actually you can initialize your lambda into some variable and you can give that variable here, and this is actually similar to what we were doing here. Okay, so instead of using function pointer, we are using lambda function, and the comment says we can directly inject lambda at thread creation time. So when we're creating thread, we can directly inject this part here itself. So let's first compile this. So this is the command, compile it. It compiled successfully. Now if you will run this, let's see how it is working. Okay, from 9 to 0. Why? Because we are giving here 10. Okay, so this is exactly similar code to the previous one, but here we are using lambda function. So as I said, we can directly inject this part from here to here. Okay, just comment out this one. So instead of function pointer, you have written lambda itself inside thread creation time. Okay, so let's compile this again. Voila, it compiled, execute, same output. Okay, so using lambda function you can achieve the same thing. Okay, so this was the second point. Let's go to the third point. Third point is using functor. I don't know you have heard about this or not, but this is functor, which is also called function object, and this is how it is written. So if you have class and you are overloading this operator then it is nothing but a functor. And if you want to know about functors, there is a video of mine, you can search it, you'll get it. So as you can see that you have the similar code, and this time this particular function will be treated as callable object. Okay, and this is how we call it. And let me just save this and compile this again. Okay, no problem, compiling the same output. Okay, so this is also giving you the same output. So this was the third way of creating thread. Okay, you're not passing function pointer, you're not passing lambda function, you are passing the functor here. Okay, so let's move to the fourth one. Okay, before that, let's comment this. This fourth one is a non-static data member function. So this is how it would look like. And yeah, here comes the difference. You have this base class and you want to call this function as your thread, then you have to call it like this. First you have to give the address of that function, and then you have to write like base colon run, because this run is inside your base class. Okay, so you have to give this syntax and then address of that function. Okay, and then you have to give the address of the object you want to call this function. Okay, because this is non-static data member function, so you need object to call this function. So you are giving this object, and then rest is the parameter part. So if this run is expecting some parameter, you pass it here. So let's compile this, save this, and compile this. Okay, no problem, same output. Okay, 9 to 0. So this is the syntax for non-static member functions. Let's move to the static one and complete this video. Static one would look like this. Okay, you will do the similar job. Instead of passing object, you will directly pass the argument, because as this is a static member function, you didn't need any object. But in previous case, as this was non-static member function, so in order to call non-static member function, you need object. So that's why you was giving the address of the object. But in case of static member function, you don't need any object to call this function, right? You directly call this function with this syntax. So only function address is required. So that's it. I think we are done here. Next video is about join and detach, because that is not simple thing. Okay, because you've been seeing this join since long time, but you might not be knowing so many things about it. So I will give this video maybe tomorrow. Okay, till then, bye bye, take care. And if I missed something, let me know in the comment section, and don't forget to hit the like button, guys. Bye bye.
Hello friend, this is Rupesh and I'm watching C Beginners video series on C++, and today's topic is use of join, detach and joinable in C++ thread. So if you're following my video series on thread, you might be seeing me using this join, but I did not explain this much. So today we'll see join and its counterpart detach, and what is the use of this joinable here. So let's look at the join nodes first. It says that once a thread is started, we wait for this thread to finish by calling join function on that thread object. So let's write a program to understand this line here. So if you are writing a thread, you need a callable object. So I can say that, okay, run. And this is your function, and this will just simply print Rupesh, okay, CPP nuts. And not only this, let's do something else. Let's take some count here. While count tends to 0, we'll print this. Okay, so this is what your thread will look like. And now let's create a thread. So std thread t1, and here you will pass run and how many times you want to print. Let's make it 10 here, and this is what the join is. Okay, so let's save this, compile and run. So compiled it, successfully compiled. If I will execute it, this will print this CPP nuts for 10 times. Okay, that's it, no problem. So let's try to understand this join here. As I said, once a thread is started, we wait for this thread to finish by calling join function on that thread object. So what we are doing is, as soon as you
create a thread object by passing function and the parameter. If you want to pass any parameter, it will create a thread and it will start running that thread, and the control will come back here. So let's see that. Let's print something here. Let's print main here, main function. Okay, and this thread is not a very big time taking thread. So what I will do, I will make this thread on waiting state so that we can assume that okay, it is taking some 3 seconds or 4 seconds. So std this thread sleep for, I keep changing my keyboard, so this is not working, chrono seconds. Let's make it sleep for 3 seconds. So what it will do, thread will start here, it will come, it will do its job, and then it is sleeping for 3 seconds, and we are simulating that this thread will do some job which will take 3 seconds. So I'm putting this thread on sleep, but don't think that it is sleeping. We are simulating the behavior that it is taking some 3 seconds to complete some task. Okay, so that we can see that it will actually wait here. I mean, your main thread will wait for this thread here and it will not go further. Okay, so we can simply print main after. Okay, sorry, let's save this, compile this and execute this. See, main came. Okay, did you see that? It was waiting for 3 seconds, then only it printed main after. Okay, so it was waiting here. I can show you again. Let's clear this. I will run this. See, it is waiting. Okay, now it has come. Can you see that? So what happened? T1 is a thread. It started this run as a thread and it came back, printed main. By the time this thread is starting, because it is taking a little bit of time, because thread is created using OS, so OS is taking a little bit of time to start this thread. By that time, your main is back. After saying to the OS that okay, you start this as a thread, your main thread is back, printed this main. Can you see that? First it is printing main. After printing main, it is getting that okay, t1.join. It means I have to wait for this t1, which is this thread. But this thread will take at least 3 seconds. After printing these 10 times, it will take 3 seconds. Then only after this, it is printing this one. Okay, so this is the job of join. The moment your program hit the join on some thread object, it will wait there for that thread to be completed. Now you might be thinking, what if I want to go further? Yeah, that is the answer which comes with detach here. Okay, so this was the first point. I think you might have understood. Let's give some 5 seconds. I know it's clear, but still, I have compiled, executed. See, we are waiting for 5 seconds. Yeah, then only it is printing main after. So we are waiting here for this thread, and this thread was doing some great job which took 5 seconds. So this was the first point. Now let's move to the second point. Double join will result into program termination. Okay, what if I write join 2 times? Let's see that. It will not give you a compile time error because syntax and semantics and everything is correct. If you will run this, see, terminate called after throwing an instance of system error, invalid argument, whatever it is saying that 2-time join is not allowed. And it doesn't make any sense because you waited for this thread to be completed at this line. Now again you are waiting for this thread to be completed because you're writing it, and it doesn't make any sense because that was completed before itself. Okay, because you came out from this because it was completed, and again you are waiting for this to be completed, which doesn't make any sense. That's why it's an error and it's a crash. So always remember that you should not double join. And third point is related to that only. If needed, we should check thread is joinable before joining using joinable function. Yes, actually what happens, sometimes you write this t1.join and after this you're writing so much of code. Okay, here maybe 300, 400 lines of code, and after that maybe you happen to rejoin it. You don't remember that, okay, I joined it before itself. So the best practice is, before actually joining, what you should do is you should check if this t1 dot is joinable. If yes, then only you should join. Okay, so let's compile this. Let me just give some little indentation here. Okay, compile and execute. This time it should not fail. See, it didn't fail. Okay, even if you are return it, it is not going there because this thread is no more joinable. This is the use of joinable function. So I think you understood this point also, that you should always apply joinable before actually joining your thread. And if you are writing very small program where you are sure that it is not joined before, or you are not writing any complex program where you may end up joining again and again, then in that case you can omit this. Okay, so let's move to the detach nodes, which says that this is used to detach newly created thread from the parent thread. Okay, what is parent thread here? This main thread. Okay, let me remind you, whenever you write a single threaded program, not using any thread, it is a single threaded program, okay, which is a single process also. So when you create some thread like this one you created here, so this thread will become the parent thread for this one. Okay, so that's what I'm saying here. This is used to detach newly created thread from the parent thread. Okay, we were joining, now we were waiting for that. Let's not wait for that. So let me remove all this extra stuff. And if I will put this detach here, then what will happen? Let's see. And to demonstrate it a little better, let's have this count also, so that we can see how many times it is taking it. I think it should be taking very fast, but still, let's give it a try. Okay, 920 main after. Can you see? This program was completed and it didn't wait for 5 seconds. Can you see? We had this 5 seconds before, and when we were waiting for this thread to complete, it was waiting. Let me just run this again. See, it completed. Okay, it is messing up now, but that's okay. This much behavior is acceptable in threading. You don't know what will start first, okay? But one thing is sure, that you're not waiting for this thread to complete. See, it terminated right away. And to show you that, let's print something else. Thread finished. Okay, so if I will compile this, run this. Okay, this is some different output. Okay, so let's try to understand why this is coming. So it will clear up your few doubts. See, what happened when you created this thread T1, what happened? The request goes to OS. OS takes some time to create a thread, and take this function and create this function as a thread, and then control will come back to this main thread, and this is also running and this is also running. Correct? Then you will print this one and OS will run this thread. But the time taken by OS was little bit more than printing these two lines on the console, and your main thread was returned before actually OS can start this thread. That's what happened here. Because you have detached your thread. You're not saying that wait for this thread to complete. You're saying detach this thread from this main thread. I no longer want to wait for this thread. That's why you're not waiting for this thread, and you don't care whether it is running or not. So this is a really nice example. Okay, so if I will run this again, something else might come. Let's see. No. Okay, why no? Okay, before, did you notice this came and after that nothing is coming? So this is totally unexpected, but actually it is expected. It's okay. Actually your OS is taking a little bit of time for this. Before that you are actually terminating yourself, and if you want to be sure for that, let's play some game here. what can I do here? Okay, let's take this one and place it here or here. Okay, and comment this and recompile and execute. Yay! See, now you're waiting. Okay, so now understand this behavior. What happened? You created thread. The request was gone to the OS and your control was back. You printed this main here. And after that, you said, okay, I am detaching this thread from main. That's okay. Till then, actually, OS didn't started this because we have not printed anything from here. So after detaching, your main thread is printing main after. Till that time, OS could not start this thread because OS is little bit slow as compared to printing these two lines. And after printing this, you are waiting. You're sleeping. So your main thread is sleeping. By that time, 5 seconds is really very big number for OS to start a thread. So OS started this thread and everything was completed and this thread finished, was executed, and your wait is finished, and then you are returning from here. So let's execute this again. See, you are waiting here for 5 seconds on this thread, main thread, and then you're done. Okay, so let's comment this and compile this and run this again. See, it is still giving you that output. And let me repeat this. T1 started means you said to the OS, okay, I want to start this as a thread. OS will take that request, okay, process it, okay, will understand, okay, I have to make some resources for this thread to be started. By that time, your control of main thread is back. So you're printing this main to the console. By that time, OS is doing its job to start this thread actually, and then you did this t1.detach. Still OS is processing this thread, didn't started it yet, and then you happen to print this also, but still OS is busy doing something, could not start it, and lastly you hit this return 0. So you are gone from this main and OS could not start this. So that's why you're not getting any output from this thread. And yes, if you are detaching some thread and your main function is returned, completed, your program is terminated, this thread will no longer available. It will be suspended. Okay? Because OS keep track that, okay, from where this thread is coming. Even if you have detached it, OS will know that which one is the parent. So if parent goes, all the child goes automatically. And maybe that's the point here. If we have detached thread and main function is returning, then the detached thread execution is suspended. And the main point was always check before detaching a thread that it is joinable, otherwise we may end up double detaching. Yeah, they're the same problem of double join. We have the same problem with the double detach also, because you may write t1.detach, and let's compile this and run this. See, it is again a crash. It is aborting your program. So double detach is also a problem. So the simple solution for this is, yes, you will use joinable. So if t1.joinable, then only you detach. And it makes sense, right? If you can join, if this thread is joinable, then only you will detach it. So let's compile this, execute this. Okay, no problem. So all these points are over. Now lastly, let's look at this point. Either join or detach should be called on thread object. Otherwise, during thread object's destructor, it will terminate the program, because inside destructor it checks if thread is still joinable. If yes, then it terminates the program. So remember, whenever you are creating some thread like this, either you should write detach or join. You should not just keep it like this. No, this is a problem. Why problem? Because in T1's destructor, it will check whether this thread is joinable or not. And if this thread is joinable, it will terminate that at the moment only. Okay? So this is very bad if you're not writing any join or detach. So remember, either you have to write join or detach if you are creating thread. So let's complete this video. Thanks for watching. If you like the video, don't forget to hit the like button, dude. It will help me a lot. And if you have any suggestion or if I forgot something to mention here, please let me know in the comment section. It will be very helpful for others to know the topic more detailed and we'll learn together. So I'll see you in the next video. Bye-bye. Hello friends, this is Rupesh and you're watching C video series on C++ and today's topic is Mutex in C++ threading, or why use Mutex, or what is the race condition and how to solve it, and what is critical section. So we're going to answer all these questions in this video. So stay till the end and you'll enjoy this. That's for sure. Okay, so what is Mutex? Mutex full form is mutual exclusion. If you don't know what is mutual exclusion, it means we will be accessing something mutually, like first you access it, then let me access that, and then I'll let you access that and all that. Okay? Or if you want to know, in Hindi, it's called samjhauta. Samjhauta in between two threads or more than two threads to access some common data. Okay, if you don't understand this, leave it. We'll see the example and you'll get it better. Okay, so full form of Mutex is mutual exclusion. Now there is a situation why we use Mutex. So let's discuss those situations. Then you will get to know that Mutex part little well. So there is something called race condition. Race means actually race, like car racing and all. So there is a race condition, but that race is to access the data. Okay. And race means there will be at least two opponents or more than two opponents. So at least two threads or two processes should be there to actually race for some data. So let's suppose there is this data, a common data for thread 1. This is your thread 1 and this is going to be your thread 2, and like this there can be many threads, but we'll take simple example. And thread 1 and thread 2 both are simultaneously trying to modify this data. Remember this, until unless you modify the data, there is no race condition. You are just simply accessing the data, there is no race condition. If you are trying to modify the data, then there is a race condition. So let's look at this definition. Race condition is a situation where two or more threads or process happen to change a common data at the same time. What I mean to say is, let's suppose you have some variable integer x is equal to 0. There are two threads T1 and T2. They both are trying to change this x into something else. Maybe thread 1 and thread 2 both are trying to increment the value whatever is there inside x. So currently we have 0 in x. So T1 is also trying to increment x by 1 and T2 both are trying to increment x by 1. Then in that case, once both are done, the result should be 2, right? But the problem is there is a situation where result might not be 2, it might be 1 also. So let's discuss that situation, and that is actually the race condition. Okay, so as I said, we have this integer x here. So let's have this T1 and T2. Okay, and do you know what instructions are used when you changed some variable? I mean, when you increment, decrement, or do some stuff on variables, some assembly instructions are executed, right? So whenever you change some variable, let's suppose you're doing some x plus plus. So this is like x is equal to x plus 1. So how actually computer does this? There are three things. First is load. Second is increment, and third is store. So load means you will load whatever is there at x inside accumulator register. Do you remember your computer architecture class? Accumulator register is there where you bring all those variables and change that value and push it back. So that's what happens. So first you will load whatever is there inside x. So x is having 0 for now. So what will happen? When there is load, let's suppose T1 and T2 happen to load at the same time. So they loaded x means 0, and this also load 0 in accumulator register, there is some accumulator register, they are loading that 0 inside that accumulator register. Then they happen to increment the variable value. So this increment happened and increment. So the result became 1 at both the places at the same time, because it is thread. So it is possible that they will work together. So it is possible that X is loaded together, incremented together, and then stored back. So there is this third one, store and store. So this 1 will go to X at the same time. So thread 1 is also copying 1 to X, and thread 2 is also copying 1 to X. So ultimately your X will hold 1, not 2. Can you see the problem here? This is called race condition. You have two threads racing for this particular variable because this is common in between these two threads. And I'm calling common again and again because it has very big significance, because if some variable is not common in between two or more than two threads, then there is no race condition for that. If that variable is local to the each and every thread, then there is no problem. So till now we understood what is race condition. So this is the race condition. Here is the race. Okay, integer x is equal to 0. If you don't understand this, let me give you the example here, because I have the similar program here. What it is saying is we have T1 and T2 thread. Add money is the function, and both will start at the same time, and add money will just increment my amount, which is initially 0. So assume this is x, this one. Okay, so this is my amount which is shared between these two threads. See, add money and add money, both are the same functions, but they will run parallelly because they are injected into different threads. Okay, so add money will run for T1 and T2 both, and we have a common variable for both the functions. See, this is global variable, that's why it is common for both. If I will include this integer my amount inside this function, then that is not common for both. That will become individual for both the threads. Okay, to make it common, I made it global. So here race condition is this much portion, only this particular line, not anything else, only this line. Now as you understood what is race condition, and yeah, what is critical section? This is what your critical section is. This particular line is your critical section, or you call it critical region also. So this particular region is critical for you. Now here comes the mutex. When there is a critical situation or critical region or critical section here, you go for mutex or semaphore, but we are not going to discuss semaphore here. So let's settle on mutex. So how to solve this? So for that I have to write a simple program for you. And yeah, before that, what is this mutex? Mutex is used to avoid race condition. Obviously, we will see that how it will avoid. And we use lock, unlock on mutex to avoid race condition. Okay, there is something called Try Lock, but we're not going to use that because I think I will create another video for that. So that being said, let's create a program. So as I said, we will be using mutex. So this is how we use it. So std mutex m, and there you go. You have this mutex, and then m dot lock and m dot unlock. There you go. So this is how you deal. There had to be a mutex variable, and that should be common for both the threads. See, this add money is a function which will be injected into the threads. So this is nothing but thread 2 times, but now we have mutex here. So let's see how it will work. But before that, let's execute it and confirm that it is working fine. Okay, we have does not name type mutex. Oh my goodness, we don't have mutex in std. Why? Okay, hash include mutex. I missed that actually. Yeah. Okay, so there is a header called mutex. If you want to use mutex, you have to include that. So hit enter, it compiled. Now execute it. See, you got 2 here. Now let's understand how this is working. So as you all know that when we create T1 and T2 here, it will create two threads. First T1 and another will be T2. Now they both will start parallelly. Let's assume they will start at parallel or same time. So we have two threads, they started together. So they both will reach to this m.lock at the same time. Let's suppose they are reaching at the same time, but in computer there is a thing. There is a CPU and T1 and T2 both are approaching to CPU, and you're thinking it is approaching at the same time because you have written it like this, but there is always a tiny difference between this one and this one. You may call it 1000 or even bigger portion of 1 second. I don't know why did I said that, because I'm not sure how much time unit it is, but what I want to tell you that is, even if it looks like parallel, but out of these two there is always one thread which reaches first than other one. Okay, so let's suppose you are starting maybe T1 to T100 or 1000 or maybe 10,000. If these threads are starting parallelly, then either of these threads will reach to the CPU first, or to say before others. So in this case also, either T1 or T2 will reach to the CPU first, and by reaching to the CPU first means they will acquire the lock first. So you have this mutex, you will lock it, either T1 or T2 will lock. So let's suppose T1 happened to lock this mutex. So let's suppose before this mutex was 0 and T1 happened to lock it, means suppose T1 changed it. Now it is used. Before 0 means it was not being used, now it is being used, or it is being locked, or actually it is locked. So it is locked by T1, and T2 will also try to lock the same mutex, but there is a situation. It is already locked by T1. So this mutex, this thread will wait for this mutex to get free. So this will go into the waiting, it will be blocked. So this T2 is blocked. So T2's execution is blocked here only, and T1 will move forward. So as T1 got the lock, and see, we are guarding this critical region with lock and unlock. See, so before accessing the critical section, you must lock the mutex, and after completing it, you should unlock it, so that if is there any thread waiting for this lock, that thread will get unlocked and will start using this. So in our case, T2 is waiting for this mutex, so T2 will get unlocked. So let's before this complete this execution, M was locked, and then my amount became 1, and then M was unlocked. So as soon as you unlock it, whoever is waiting for this mutex will get the chance to execute this. So now T2 will get the chance, and see, as you have unlocked mutex, T2 can lock it. So T2 will lock this mutex, T2 will also increment. Now T2 will increment whatever is updated value. So T2 will make it 2, and then T2 will also unlock it. So can you see that there is a mutual exclusion between these two threads, that either you or I will use it, use this critical section, we will enter at this location one at a time. We both won't be working on this location at the same time. That's why we are using this lock and unlock. Okay, and this is how it works. And I'm not saying that T1 is written first, so T1 will get m.lock first. No, either of these two can get lock, but the only guarantee is once T1 has locked mutex, this one, then T2 cannot lock it until unless T1 unlock that mutex. So can you see that you have a gate here? This is a gate. So it's like this. You have arrays. Let's suppose T1 and T2 are two students, and there is this race for one door to be opened, and there is one table here,
and there is this key for this door. Okay, so either of these two students will reach to this table and get the key. So suppose T1 reaches this key, T1 will open this gate and get inside and do whatever it is willing to do. It will come back, lock the gate. Now T2 can take that key, go inside the door. But the situation is T1 and T2 both cannot go inside this door altogether. And this key is nothing but the mutex. And did you saw that? When T1 was inside this door, T2 was waiting here. T2 cannot enter inside that. That's how this is also working. Let's suppose T1 happened to get this lock first, then T2 was waiting here itself. T2 cannot go inside this and execute ++ my account. T2 is waiting and T1 got the lock, so T1 can enter here. T1 actually incremented this and T1 did m.unlock. As soon as you unlocked it, T2 get the lock because T2 was waiting for this mutex to be unlocked. So T2 now can enter and increment this my amount ++. But T2 will work on the updated value, which was changed by T1. So now there is no race condition here. Can you see that? And this is your critical section or critical region. So I hope you enjoyed the video. Don't forget to hit the like button, and if I missed something and you wanted me to include something, then you please comment. I will be very happy to include that in coming videos, or it will be helping to other fellows who are watching my videos and reading the comments. So till then, I'll see you in the next videos. Bye bye. Hello friend, this is Rupesh and you're watching C Beginner's video series on C++, and today's topic is this Mutex Try Lock. So actually this is a member function of this Mutex class, and there are so many try lock functions. So if you want to see how many are there, this is the list. There are total 9 try lock functions. But we are not going to discuss this one. We are going to discuss this one today. And if you see this, we have this mutex variable and we will apply try lock on that. Before, if you remember, we were using this mutex and we were locking it. So this is kind of a blocking call and this is kind of a non-blocking call. So if you are not able to lock the mutex, you will come back and return false here. Okay, that's the job of this try lock. It's that straightforward. Don't worry about that. We'll go through one by one of all these points and complete all the points. Okay, so try lock tries to lock the mutex. Mind it, it is trying to lock the mutex. It is not actually locking the mutex, because if you go and try to lock the mutex like this, then in case this mutex is not free, it means some another thread has already locked it, then you will get blocked. You will be waiting for this particular mutex. But in case of this try lock, you will try to lock this mutex and you will come back if it is not able to be locked. Okay, so it returns immediately. This is very important point. It will return, it won't get blocked. And on successful lock acquisition, returns true. It means if this if statement is true, it means this try lock was succeeded to lock this particular mutex. If it returns false, we actually didn't get the mutex. This is what it is. Okay, so second point is, if try lock is not able to lock the mutex, then it doesn't get blocked. That's why it is called non-blocking. Yeah, that's what the second point is. It is non-blocking. Third one is, if try lock is called again by the same thread which owns the mutex, the behavior is undefined. Obviously, so it is deadlock situation. Yeah, that's what I have written here. Yeah, it's undefined behavior and it's kind of a deadlock situation. If you want to be able to lock the same mutex by the same thread, yeah, more than one time, then go for the recursive mutex. This is another type of mutex which is called recursive mutex. If you want to be able to lock this particular mutex one more time, then you can use this recursive mutex. Okay, but we are not discussing about this recursive mutex. We will see that in coming videos. Okay, so all points are covered. I have this particular example here, which is going to increase the counter for, what is this, 1 lakh time.
Okay, so if I'm going to increase this particular variable in two thread, T1 and T2, and having this same function, it means we have this function acting like a thread two times. So it is going to share this particular counter because it is a global variable. So two thread will be trying to access this counter. That's why we will apply mutex here to handle this critical situation. I mean critical section, not situation. So you understood, right? This is global, so it will act as a common resource in both the threads, this one and this one. So let's run this program and try to see how this try lock will work. So let's compile this. I hope there is no error. Oh my goodness, there is some error here. I don't know. Okay, this function is mismatching here. I just forgot to change this place. Correct. Let's compile this again. Okay, fine. Let's run this. Okay, so the counter could increase up to this number, and this is not a fixed number. If I'll compile this again, there is going to be some another number, see? And if I'll compile again, sorry, run again, and run again, see, it is giving you the different numbers, because first of all, this threading and locking is totally dependent on the CPUs. So sometimes CPU will give you the lock, sometimes the CPU may delay to give you the lock, and even if it is not locked, I mean CPU may give you the permission to lock this pretty fast in some case, and sometime it will give you little slower. So it depends. But why it is not 2 lakh, it is some number like 76,000, 73,000, 79,000, but why it is not 1 lakh? So this is 1 lakh. Oh yeah, then in that case it should be 2 lakh. This counter should be incremented by 2 lakhs, but it is not. So let's see why it is not. So let's suppose this is 41, and let's suppose there is this another thread 42, and they both are trying to access this counter. So let's see what will happen here. And this both threads are this function. Okay, so let's suppose thread 1 is reaching to this counter first, and it will try to lock that, and it will get the mutex because it is not locked yet. So counter will get the lock, and simultaneously when T1 was actually incrementing this particular counter, T2 also came and tried to lock it. But actually at that time T1 was busy in incrementing this particular counter, and T1 actually didn't release that lock, so T2 cannot get that lock. So as I said, if this try lock will not be able to get the lock, it will return false. So in that case T2 will not enter here. Okay, so this loop will again start for I is equal to 1. Okay, and maybe what will happen when it will come again for the second time. So this was first time. If it will come for the second time, maybe T1 was still busy in incrementing this. So T1 came first time here, it was busy. T2 came second time and still it was busy. But when T2 is coming for the third time, that time actually what T1 was doing, T1 had released this lock here, and T1 was maybe incrementing this particular variable, and at that time maybe T2 asked to get the lock, and obviously as it was unlocked, then T2 got the lock. Then T2 will increment this. So did you see this T2 incrementing this particular counter at this second time? Third time it is getting that mutex and going to successfully increment that, but second time and first time it actually skipped. That's why we are getting all those random values. So we don't know what will happen, but I am giving you the rough idea what might be happening so that you are getting those random values. And we don't know what will lock first and what will happen, but just because of this try lock we are not getting that 2 lakh. Okay, this is what number we should get, but as we are not waiting for T1 or T2 to complete and give me the lock, we are actually skipping it. Okay, so if you are not getting that lock, you will skip that particular iteration and you will increment this counter, and maybe
it is possible that T1 was busy in incrementing this particular counter and you actually tried for 1 lakh time. This is quite possible. So I'm giving you the scenarios how to think. But really, if you want to get this 2 lakh number here, what you should do here is you just use lock. So let me just give you that program. So if I will lock it here, then we don't need this particular if condition. Okay, because this will definitely wait for that particular thing. Okay, so let me just remove this. Yeah, so now you won't go further unless you have this lock. So both of the threads will actually wait for another thread to give the lock. So you are not skipping it. That's why this counter will always be 2 lakh. So let's compile this and run this. See, it is 2 lakh. And then if you will again run this, no matter how many times you run this, it is going to be 2 lakh. Okay, because we are waiting for another thread to release that lock, mutex, and you are getting that lock for your thread. But in case of that one, let me just undo this. In case of this one, you was not waiting, you just skipped this iteration and iteration and iteration. So it depends on the CPU speed. If my CPU is very good, it will iterate so fast that maybe T1 or T2 was busy in incrementing this and another loop actually finished. Okay, so that's quite possible. So if I will run this, compile this again and run this. Oh, okay. Yeah, sometime it is possible that you may get this 2 lakh. Okay, so anything is possible in this thread world. So you see this, so many different numbers are coming. Okay then, so we will sum this video. Thanks for watching, and next video is about, I don't know, maybe this thread, try lock. It is really very interesting try lock, it will take so many mutexes like this. Let me show you that. M2, M3, and on and on and on, and it will try to lock all those mutex all together. And we'll see this topic in next video. So thanks for watching. If you like the video, don't forget to hit the like button and subscribe for more videos like this. Thanks for watching. Bye bye. Hello guys, this is Rupesh and I'm watching CPP Nerds video series on multi-threading in C++ series, and this video is about try lock in C++ 11 threading. So this try lock is different than Mutex Try Lock because just before this video we learned about try lock, which was in Mutex class. So that try lock was the member function of Mutex. So that try lock you was using like this, m.try lock. Excuse me for my writing. Okay, so this m is a object of Mutex. Okay, so you was using try lock like this, but this try lock is totally different than this try lock. Let me just erase this. So let's see what this try lock is. This is nothing but a standard, global function which takes number of mutexes and it will try to lock all of them. Let's read this out. Std try lock tries to lock all the lockable objects. Here's exactly, this does not take only mutex, it takes shared lock and other lockable objects also. But for sake of this video, I will use only mutexes so that we can understand this easily. So try lock tries to lock all the lockable objects passed in it one by one in given order. So if you remember, if we ever try to lock some mutex, which is like this, m.try lock, then you was trying to lock only one object. But in this case, you can lock simultaneously so many objects at this line itself. So let's suppose there is some critical section. Before this, you want to lock, let's say 5 mutexes. This is mutex 1, this is 2, 3, 4, and 5. So you have to write m.try lock, try lock, try lock, and try lock. So don't you see there is a very big code which is not needed. So you can combine that into one line saying that try lock m1, m2, m3, and so forth.
and it will go till n because that n is not defined. So you can take as many mutexes as you want. And notice this will try to lock. It is very important to notice that it will try, it won't lock, it will try to lock. Try lock means if it is not able to lock, it won't wait there, it will come back and you will go ahead further. If it is only lock means if you are not able to lock it, you will wait. But here it is try lock, so you will not wait. Okay, so this second point is on success this function returns -1. This is also very important. Otherwise it returns 0 based mutex index number which it could not lock. So here, as I said, I will be using mutexes. It can be shared lock or deferred lock and other locks. So what second point is saying, if it happened to lock all the mutexes, then in that case it will return -1. Then you will get to know that okay, all the mutexes were locked successfully. If not, it will return 0 base index mutex number. It means, let's suppose M3 was not able to lock. I mean, this try lock could not lock M3. Then it will return 2 because this is 0 base index. So this is 0, this is 1 and 2. Then you will get to know that this second number means this M3 is failing in locking. I mean, you're not allowed to lock this M3 at this moment. Then you will take some respective action, or you won't take any action. You will do whatever is given to you without locking any of them. Okay, we'll see all those parts, don't worry about that. So for now you just understand that if M3 was failed, it will return 2. If everything was passed, it will return -1. Okay, and we have to check the return value of this try lock in if condition, and you will get to know that okay, everything was passed or failed. So this third point is, if it fails to lock any of the mutex, then it will release all the mutexes it locked before. Yes, this is also very important point. Let's suppose, as I said, this M3 was failed. What about this M1 and M2 locked situation? Because it was able to lock M1, it was able to lock M2, then it happened to be like it was not able to lock this M3, but M1 and M2 was locked, right? So it will release M1 and M2 and then return 2. So this is also a very important point. And fourth is, if a call to try lock results in an exception, unlock is called for any locked object before rethrowing. So enough talk, let's see the example for this. So the example for this could be, you have two threads. This is T2, this is T1, and this thread is producing some data which is stored inside X, and this is producing some data which is stored inside Y. So thread 1, thread 2 produced data are in X and Y. There is another thread T3, and this thread is trying to consume whatever is produced here. So this will try to access X from here and Y from here. Okay, and after consuming, it will set to 0. Means it will free all the things it was generated in T1 and T2. This example can be assumed like there is one bucket. Don't bother about the size. The bucket name is X and this thread has bucket Y, and they both are getting filled. Okay, and there is this thread T1 which has the bigger bucket, which will try to pour whatever is there inside this and this into this. And as you have poured this one and this one here, you are actually empty, correct? So I have tried to simulate this kind of behavior in programming. So let's see the program now. And don't worry, if you don't understand this program, I will be giving this program in one of my blog. Yeah, I have started giving my programs in blog so that you can copy paste and do some experiments on them, because I have realized that so many people are asking my programs because it is really very hard to type these things to actually do some experiment, and I can understand that. So I have decided I'll be writing a small blog and I'll copy paste this full code so that you can get that there. And I'm going to start that thing from this video, so don't complain if you're not getting code for some another video. Okay. So as I said, you will need 3 threads. So we have T1, T2 and T3. So T1 and T2 are producing something in X and Y, and this consume will actually consume X and Y. So this is another thread. So let's look at the code here. This code is very simple. This is increment X and Y. So I have only one function which will act as a T1 and T2 both, because if you see here in main I have created T1 and T2, but increment XY function is similar. Okay, so two threads will be created on the same function, and X and Y I am passing from outside as a reference, and mutex is also passed as a reference. So this function will treat them and work accordingly. So let's compile this from beginning. I have created T1 and T2 and T3. So these threads will get created, and I have joined here, so they will wait. Your main will wait for them to be completed. Let's suppose T1 and T2 is started and T3 also is started. T3 will try to lock M1 and M2 together because it needs M1 and M2 locked in order to access this X or Y variable. Okay, and here this M will be treated as M1 for this thread 1 because we are passing M1 here and catching that M here, and we are locking that, and it will become M2 when it will come to this thread 2. Okay, I think you will be able to understand this. So with this feeling, I will go ahead and explain you this. So as I said, if this is returning, this is the return value. If it is -1, in this case, it was actually successful to lock M1 and M2. So if it was successful, then we will see that if X is not equal to 0 and Y is not equal to 0, we will consume them inside X plus Y variable. See, X plus Y goes into this consumed. This is our bucket, bigger bucket. This is smaller and smaller bucket. You remember? And after that, we are emptying those buckets, and I'm just simply printing this. And yeah, notice this, I have to unlock them explicitly, even though I didn't actually wrote any lock, but you have to unlock, because this try lock would have locked M1 and M2, then only you reached inside this if condition. Okay, and if use count is equal to 0 means I have set some condition how many times I want to consume them. So if I have successfully consumed them for 5 times, I am happy. Okay, and I'm breaking this loop and I'll come back. So we will return from here. So let me just run this program. Okay, we can just simply compile this. Compiled. If I will run this, okay, see, as I said, I will be consuming till 5, and you can see that this is producing, incrementing plus plus means it is incrementing by 1. So first time X is equal to 1, Y is equal to 1, and after doing that, I am asking this thread to do something else. Means this is a very heavy duty thread. It will do something here, and that doing something I have simulated for this thread as sleeping. Okay, so it will sleep for 1 second, means it is doing something for 1 second, and as this one is sleeping, this one will take X and Y and fill its own bucket. Okay, so this is how I have achieved this, and this is why you are getting this answer. X plus Y becomes 2 after adding these two, and then these two will go inside this, then these two will go inside this, and at the end, after 5 count, you have total 10, because 5 times X and 5 times Y become 10. So you can see that you have successfully filled your bucket. So you can see that it was fairly simple program, and don't worry, I will be giving this program inside my blog, so you can do some experiments on this. Okay, so we'll sum this video here. Thanks for watching, and don't forget to hit the like button because it motivates me to create other videos. So I'll see you in the next videos, and this is not my doggy. Okay, bye bye. Hello friend, this is Rupesh and I'm watching CVP Nuts video series on C++ threading series, and this topic is about timed mutex in C++ threading. So before this video we learned about mutex, race condition, critical section. Before this video I explained what is mutex and all the things related to that, and we know if there is some variable m dot lock, then this is a mutex, then you have to lock it, and then m dot unlock. This timed music is also similar, but it gives you the timing how long it will wait for this particular mutex. What I mean to say is, let's suppose there are two threads, T1 and T2, okay? And there is one mutex m1 dot lock. You have this m dot lock here. So either m1 will able to lock this first, or T1 will able to lock this, or T2. Either of this will be able to lock m1 first, and let's suppose T1 have locked, then T2 have to wait for this mutex m, correct? So somewhere after some code you have to write m1 dot unlock. Then only T2 can acquire this lock. Till then T2 will wait here. Let's suppose there are few lines of the code. So this was the typical behavior in mutex. Now can you see that if m1 is locked, and let's suppose this time period is taken by T1 to actually unlock it, okay? And let's suppose this time is 1 minute, then T2 will wait here for 1 minute. And it is kind of a time waste if T2 have something else to do. But you will say that then there is something called try lock in mutex, correct? So the syntax would be like, instead of lock, we will write here try lock. Then T2 will not wait for that lock and it will do something else, correct? I have given that video also. You can see that after this video, okay, in the list. That is called try lock on mutex. But the problem with that try lock is it will immediately return false. What I mean to say is T1 acquired the lock, then T2 also tried to acquire the lock, and we are using try lock, then T2 will get false in that case and immediately start doing something else. But I want to wait for this mutex for particular amount of time, let's say 1 second or 100 milliseconds. And then I want to do something else, not right at the moment. Then we have this timed mutex. You will tell the timeout period that I want to wait for this much amount of time for this mutex, and if I don't get that mutex in that particular time, then I'm ready to do something else. Okay, so this is what the definition says. Standard timed up mutex is blocked till timeout or the lock is acquired and returns true if success, otherwise false. So there are two things. If this is timed mutex, this one, then in that case the another thread which is actually waiting for this mutex for this particular amount of time will actually get the mutex in given time. Let's suppose if this mutex, this full work is taking 1 minute and this T2 is ready to wait for maybe 1.5 minutes or 2 minutes, then in that case T2 will get the lock because it will wait for this T1 to finish, okay? Because T1 took 1 minute and T2 is ready to wait for 2 minutes. Okay, then in that case T2 will get the lock and T2 will also come here and do its job. But let's suppose T1 was ready to wait for only half of the minute, but T1 will take 1 minute to finish this. Then in that case T2 will not get the lock. T2 will get false in return, and T2 will understand that no, I'm not going to get this mutex in given time, what is half time. Okay, so I'll tell you the syntaxes and all that. So I have this full program here. This was just the introduction and the glance what we will go through in this video. Okay, so these are the member function what it supports. There is this traditional mutex lock, try lock, these two functions, and this one is exactly similar in mutex and this, but there are two different functions, this one and this one. So we'll be covering these two functions in this video. So we'll take try lock for first. Okay, so the definition for this says that waits until specified amount of time duration has elapsed or lock is acquired. Whichever comes first will happen. Okay, and on successful lock acquisition it returns true, otherwise it returns false. Okay, so let's look at the program and we'll understand this better. So this is your program here. It is fairly simple program. What we have in our hand is there is global amount variable which is initialized with this 0, and we are creating two threads, T1 and T2, and there is this function which will become thread, okay, and this 1 and 2 I am passing as thread 1 and thread 2, okay. So these are the identities for the threads, correct? And as we are learning try lock for, this is the syntax for try lock for. It will take how many seconds we have to wait for. So this is timed mutex M, and we are going to try the lock for 1 second. So let's see how this will work. So T1 and T2 will get created at the same time, and they both will try to lock this M because it is global. So this is common between these two threads, okay? So they both will try to lock this mutex, and any one of them will succeed, okay? So for this moment, let's assume T1 succeeded first. Then it is saying that try lock for this much second, which is 1 second. But as it was in unlock position initially, T1 will immediately get the lock. Instead of waiting for 1 second, it will directly get the lock because it was unlocked already, okay? So my amount will get incremented by 1, which is 0, so it will become 1. And I'm telling this thread to sleep for 2 seconds. So what happened? T1 acquired the lock, mutex, and it is sleeping for 2 seconds. Till now, T2 was actually waiting. It didn't do anything. And then I'm printing this thread number 1 or 2, whatever, has entered, and then I will unlock it so that T2 can lock. Okay? Now, as you know that T2 was also trying to lock this at the same time, but T1 got the race. Then T2 said, okay, I can wait for 1 second if you can give me this lock in 1 second. But what happened? Actually, this T1 took 2 seconds at least. I'm not calculating how much time it took to increment this and to print this and to unlock it. Considering these two things very minimal, I will say that T1 took 2 seconds and T1 took 2 seconds and T2 was ready to wait for 1 second. So as you can see that T1 actually took more time than T2 is ready to wait. Then what will happen for T2? It will return false here and T2 will not go inside this. T2 will come here actually, and T2 will print thread number 2 or something, could not enter. And lastly, we are printing my amount. So as T1 was entered here, it will only increment by 1. So you will get only 1 as output. So let's quickly see the result and then analyze something else. There is no error, and if I will execute this, see, it is saying that thread 2 could not enter and thread 1 entered, and the output is 1. So this is printing 1 and this is printing that thread 2 could not enter. And did you notice thread 2 message was printed before this, and that shows that thread 2 actually waited for 1 second only. Now let's increment this by 2 seconds and make this 1 second. Yes, now it will come. Okay, so let's recompile this and execute this. See, thread 2 and thread 1 both entered, and now you have 2 as an output inside this. Are you getting this? So this time what is happening? Let's suppose T1 got the lock first, then T2 said, okay, I'm ready to wait for 2 seconds. And T1 came inside this. T1 actually did something for 1 second, and T1 unlocked it. And as soon as this got unlocked, T2 was actually ready to wait for 2 seconds, but it got the lock in 1 second only because T1 got it work done in 1 second. That's why you can see that T1 and T2 both was able to enter inside this. So that's why this timed mutex is so beautiful if you have time constraints in your program. I hope you would have understood this. So let's quickly move towards example number 2, which is for try lock until. This is exactly similar to what we did before, but instead of only simple seconds, we will give the reference that you wait from now plus 1 second. So our std chrono steady clock will calculate what is current time. From current time, it is telling that wait plus 1 seconds. Okay, and it will do the same job. Okay, so let's compile this and execute this. See, it will tell you the same thing. Thread 1 was able to enter, but thread 2 could not, because here we are waiting for 1 second. I mean, T2 was waiting for 1 second and T1 took 2 seconds. So actually timeout came and T2 came here. Okay, now let's do the same thing. If you will make this one 1 and this one 2, then both threads should be able to go inside this, correct? Let's see that. See, thread 1 and thread 2 both was able to go inside this and result is 2. Okay, so this is how timed mutex work. So thanks for watching, guys. If you like the video, don't forget to hit the like button, dude. It will help me a lot to make more videos like this. And if you have any comment, let me know in the comment section. I'll be very happy to answer you for those things. Bye bye. I'll see you in the next videos. Hello friend, this is Rupesh and I'm watching C Beginners video series on C++, and today's topic is Recursive Mutex in C++ Threading. So this video comes under Threading series and we'll see Recursive Mutex today. And this look like a very big theory part, but it is not. It is really very easy. So let's go through the point 1. But before that, I want to give you a little introduction about what is Recursive Mutex means in basic terms. So let's suppose you have some recursive function. Let's make it recursive, okay? And this is the function, and this is calling itself in recursion. There is this recursive function call inside this, and it is possible that this recursion somewhere here is accessing some critical data, I mean critical section. So you will be using mutex to solve that critical section problem, right? So here you have m.lock. First time when you call this, you will come here, you will go inside this and you will see that, okay, m is not locked. Okay, before that, let's have two threads, T2 and T1. These two threads were running this recursive function, and there was this mutex lock, and this thread T1 happened to lock this particular mutex first. So this mutex belongs to T1 now. Then again it will call itself. See, recursive will again call itself, and then again it will come inside, and T1 will see that m1.lock. It will try to lock this m again, but as this is mutex, it will say that I am already logged, and it will wait for this. So this is kind of a deadlock situation, because you have the lock, I mean this thread have the lock, but again this thread is looking for the same lock. So this situation should not come ever. So to get rid of this situation, we have this recursive mutex. So instead of writing std mutex, you will use a recursive mutex. Now everything will be same, but when this again call will happen, it will check and it will see that, okay, this m is a recursive mutex and I am the only owner of this lock. So what it will do, it will allow to lock it again, and it will go here, and then it will again go here, and it will come and it will see that, okay, it is recursive mutex. So keep on going like this. Okay, so there is no problem when this is recursive mutex. And one more thing, you have to write unlock. So that unlock should be here, m.unlock. Now as you can see that it is always coming here, and after this recursive function call, it is going back. So whatever is after this recursive function was never executed. So once the terminating condition will hit, it will go back, and then it will start executing this m.unlock. So let's suppose this m.lock was logged for 10 times, then this m.unlock will also be called 10 times. So we are good to go. And this is what the requirement is. The number of times you lock recursive mutex, that many times you have to unlock it, otherwise it will be considered still locked by this thread. So this is the basic understanding. Don't worry, I will show you two code, one with recursion and another with loop. Yes, exactly. This scenario is applicable in loops also, because it is possible that you have some for loop and inside that you have this critical section and you want to lock it again and again. Actually, you don't want to lock it again and again, but your situation is you cannot get rid of this mutex lock statement, and whatever you want to access is inside loop, so you have to lock it again and again. So that is the problem with this scenario, that your critical section, this is, let's suppose, critical section, then this critical section is inside loop, right? And if you are accessing this critical section by mutex first time, then again this loop will come back and you have to again lock it. And if it is normal mutex, you will end up having deadlock, because you're going to lock it again. I mean, you're going to wait for this mutex by holding the lock of the same mutex. It is something like this. You have this mutex in your pocket and you're saying that if someone will give me this particular mutex, I'll go further. So that is not going to happen, right? Because you already have that particular mutex in your pocket and no one can give you the same mutex what is there in your pocket, correct? So this is a problem, and the solution is this recursive mutex. So let's go line by line and try to understand what I have written as a notes here. So the first point is, it is same as mutex, but same thread can lock one mutex multiple times using recursive mutex. That's what I explained here. If it is recursive mutex, you can go ahead and lock as number of time you want. Second point is, if thread T1 first called lock or try lock on recursive mutex M1, then M1 is locked by T1 only. Now, as T1 is running in the recursion, T1 can call lock or try lock any number of times, there is no issue. That's what I said. If T1 have locked it first, then T1 can recursively lock it n number of times, no problem. So third point is, but if T1 have acquired 10 times, either using lock or try lock method on mutex M1, then thread T1 will have to unlock it 10 times. That's what I explained here. If you are locking your recursive mutex 10 times in recursion, then you have to unlock it also in 10 times. You have to write your logic in such a way that you will end up unlocking it 10 times. Otherwise, that mutex would be considered lock. So this is very important line. It means recursive mutex keeps count how many times it was locked, so that many times it should be unlocked. Yes, this is very important point. How many times this lock was called, this M is very intelligent. This will keep the track how many times I was called if it is recursive mutex. Okay? Then only it can track that, okay, I was unlocked that many times. Okay, so the last point is, how many times we can lock recursive mutex is not defined. Yes, exactly. This recursion is, this level of the recursion is not defined. So you can lock this maybe 1,000 times in some system, and in some system it may be way more than that. It depends on the system how much stack it have, okay? Because this recursion works on stack, right? So how much space you have, that many times you can actually go ahead and lock this, correct? And wait a minute, this is very important point. What was that? How many times we can call the recursive mutex is not defined. That's what I said. But when that number reaches, and if we were calling lock, it will return std system error. We have to catch it. Or if we were calling try lock, it will return false. So I have given try lock on mutex. It is like you will try to lock the mutex. If you cannot lock it, you won't wait for that mutex. So this is the logic behind try lock, and lock is it will try to lock. If it is not able to lock, it will wait for that mutex to be unlocked by some another thread, and then it will go ahead and lock it. So in both the cases, these are the respective outputs. Okay then, enough theory. Let's look at the practical. Then we'll go for the bottom line. Actually, these are the similar short lines of these bigger lines. Okay, so let's go for the practicals. So this is your program here. First, we will see
this program and then we'll go for the loop 1. Okay, so this is fairly simple program. You can see that we have two threads, 1, 2. We have this thread ID 0 and 1. I'm passing this as thread ID so that I can print this ID and we'll get to know that, okay, what thread is inside this. And I have this 10 and 10, and this 10 is saying that how many times this recursion will run. Okay, because I'm checking this loop for is less than 0, then I will return. Okay, so you should be knowing how recursion works to understand this little more. Okay, so let's compile it logically. So let's assume T1 was started first and it entered inside this, and loop 4 is not less than 0, it is 10 for the first time. M1.lock, M1 is a recursive mutex. Yes, this is the syntax to write the recursive mutex, and T1 actually logged it. Once T1 logged it, you know that T2 was also about to start this recursive function as a thread, and the moment T1 logged it and reached here, T2 was actually reached here, and T2 also tried to log this, but T2 cannot log this because T1 have already logged it. So T2 will wait for this mutex to get unlocked. Okay, so this T2 will wait here while T1 will actually keep on working. So by T1 we will print this C, which is 0. So 0 buffer plus plus, this is some global variable which will be acting as a critical section in between these two threads. And after incrementing this buffer, we are calling ourselves recursion with the same C, and this time loop for minus minus. So this time 9 will go inside this, and again we'll come here and 9 is less than 0. Yes, it is false. It will again come back. It will try to log this mutex, and it can actually log because it is a recursive mutex, and it will go ahead and keep on doing this until unless this loop becomes minus, and if this is minus, it will hit return. So it will return it, and then it will unlock it, and then that stack will be empty, and again it will return for 0, 1, 2, 3, 4, 5 till like that. It will return for almost 10 times, and it will unlock this mutex for 10 times. So let me show you this by running this, and if you don't understand this, I'll explain you how actually it works. Okay, so before that, let's go ahead and run this so that I can show you that this is a working code. So I compiled it, it has compiled, let's run this. Okay, if you will see this, our output is 0 for 0, 0 for 1. So this first 0 is a thread ID. Okay, let me just write that, recompile this and execute it. See, for thread ID 0, it is printing 0, 1, 2, 3 till 10, and then from 11 to 1 is incremented by thread number 1, and thread number 1 was actually able to lock this because thread number 2 was able to lock it. Okay, there are so much confusion with this 0 and 1. Let me just make this 1 and 2 and recompile this. So thread 1 did its job, and as I said, it have to unlock it how many times it is locking it. So as looking at this number, it is locking this mutex for 11 times from 0 to 10. So it has to unlock 11 times, then only T2 can actually lock that. So let's do one thing. When it is going to unlock it, let's give this message. Okay, then we'll come to know that which thread is locking and which thread is unlocking it. See, it is very crisp and clear that initially it was locked by thread 1, and it was coming here till this location, and it will again call itself. So this thread ID statement was printed 0 to 10 times. After this for loop would have become false, and it went back. So, and back means it came here, and then after that it will start executing this one. So see, it printed that unlocked by thread 1, and it printed this for 11 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. See, it unlocked 11 times, then only thread 2 locked it. See, then thread 2 also have to unlock it 11 times. This is what it is. Okay. So let's see how this actually work. So let's suppose this T1 called first. So there is this bucket for T1, and as I said, it will come inside this, it will check whether it is true or false. So loop for will be initially 2. So 2 less than 0 is false. So it will not return, it will come inside this. And m1.lock will be performed. m1.lock is performed. It will print locked by thread ID. So I'll write in short order locked by thread ID, and ID is 1. So 1, and it will print this buffer. Okay, so initially buffer is 0, so it will print 0. And after this it is hitting recursion. So there is this again REC recursion function called. Okay, so it will create another stack similar to this. Again we will check, but this recursion is not called empty, it is called with loop for and C. So we can assume C is always 1 in this case, and loop 4 is decremented by 1. So loop 4 was 2, this time it will go as 1. So we will have 1 less than 0, which is again false. So it will not go inside this return. It will again try to lock this, and m.lock was performed. And then again it will print locked by thread ID. So locked by 1. And this time this buffer was incremented by 1. So it will be 1. And then again it will hit this recursion. So let's write this REC, and this time this recursion C will be always 1, and this loop 4 will become 0 now. Okay, you remember this loop 4 came as 1, so 1 minus minus will become 0. So we are passing 0 inside another function, and one function call will create one stack. So this is first stack, second stack, third stack. Similarly, 0 less than 0, no, it is not true. So mutex will be logged. Again D1, and this time this buffer will become 2 because we are always incrementing it. Okay, so this has become 2 now, and again we will have this REC. This time it will be -1 because we got 0 here, okay, inside this function call. Okay, so 0 minus minus will become -1, and then we will call function with -1, and this -1 less than 0 is true. Okay, see, this condition will become true. This -1 is less than 0. Yes, then it will return from here, and when this returns, it goes back where it was called. So after this, what is left? It was this one and this one. So after this, these two statements were left. So now it will execute these two. So m1.unlock. So m1.unlock, and then it will print unlocked by thread ID. So it will print unlocked. What is this ID? 1. And once it is completed, so this full stack, forget about this boundary, it is actually this much big. Okay, so once it is done, this full stack is over. So how did we reach to this stack? Because of this call, remember? Then again you will go back to this call only. Okay, like this. Now you had executed this line, so you reached and created this stack. Now you are back, so whatever was left off at that moment, you will execute that now. So what was left? m1.unlocked here and cout unlocked by, and after executing these two, this is again done, and you will be going back here. And similarly here also you went to this stack and two things was left, so it will do the same thing again. Forget about this boundary, it will do m.unlock, which is this one, and it will print unlock by thread ID 1. So can you see that how many times you logged it? 1 time, 2 times, 3rd time, 4th time you went, but this condition was false. See, this condition was false, so you was returned. You cannot go here. You was returned and you came back, and then you started executing
m.unlock. One time, unlock second time, unlock third time. So can you see that you logged one time, two times, second time and third time, you unlocked one time, second time and third time. So you logged 3 times, you unlocked 3 times. And this is how recursion works. And don't forget to hit the like button if you liked how I explain about the recursion here. Oof, it was not easy. Okay then. So as you have unlocked it 3 times, now you remember T2 was actually waiting here. As I said, T1 is this one, T2 is also there somewhere, which will have the similar things like this, and here it will hit return like this. It will again go back, and then you will execute 2 line, and then it will go back. You will again execute 2 line, it will go back. You will again execute these 2 lines. These 2 lines are nothing but these 2 lines, this one and this one. And why T2 was waiting here? Because mutex can be locked by any of the thread, and we assume that thread 1 happened to lock this. Okay, so this was about the recursion. Let's go for the loop example. So this is your loop example. This is fairly simple. There is no recursion, so I don't have to explain it much. It is like you came inside this main and you have this recursive mutex m1, similarly how you saw this before, and in one loop you are trying to lock it 5 times, 0 to 5, 5 times, and you're unlocking it 5 times. So you can do it in loop also. It's just a demonstration. I don't have to explain much here because it is very easy. I just wanted to show you that this recursive mutex can be used in loops. But remember that how many times you locked it, you have to unlock it that number of times. So I think I'm done here. Thanks for watching, guys. And don't forget to hit the like button, dude. It will help me a lot and motivate me to create more videos like this. I'll see you in the next videos. Bye bye. Hello guys, this is Rupesh and you're watching CP Peanuts videos on C++, and today's topic is lock guard in C++ threading, and this is the syntax for that. So you'll be having namespace and then lock guard, and yes, this is a class, a template class, so you have to give the type. So you will pass the type, and this is your variable name, and this is the mutex. So you have to always pass the mutex when you create a lock guard object. Okay, so this is object and this is mutex object. So before going for this notes, let's look at this program first. This program is creating 2 threads, this one and this one, and I am passing this thread number as T0 and T1. Okay, and this 10 is for this loop 4, and it will increment this particular buffer 10 times. So this thread will do this increment for 10 times, and another thread will also do the same increment for the 10 times. So ultimately this buffer will become 20. So we'll print this buffer in the end. We'll see that okay, it is getting 20 because initially it is 0. So these 2 threads are trying to modify this buffer at the same time. That's why we will use this mutex lock and mutex unlock. We know this very well how it works. Okay, if you don't know how mutex lock and unlock work, you go ahead and watch my previous videos on mutex. But still, let me quickly tell you that how it will work. So T1 and T2, any of these can start this thread at any order. So let's suppose T1 started this and T1 will able to lock this mutex first. So T2 have to wait here until unless T1 unlocks this mutex. So this is how it works. Now what if I tell you that you don't have to unlock it, because you can see that when you are done, when you are done with this for loop and going out of this scope and you are about to terminate your thread, before that only you are unlocking your mutex. And the moment you started this thread, you locked it. So instead of this lock and unlock, you can use this lock guard, which will do this. If you will write lock guard here, let me show you that example now. So this is the example with the mutex, and if you'll see this, this is the example with non-mutex with lock guard. And as I said, this is the syntax for creating lock guard. And instead of writing mutex m1.lock and m1.unlock, what this will do, you will just create this, and the moment you create it, it will try to lock this M1. Okay, so it is a wrapper over this M1. So that's the first point. It is very lightweight wrapper for owning a mutex on scoped basis. What is this scoped basis? We'll see that, but the main point is it is a wrapper for owning the mutex. Okay, so both thread 1 and thread 2 will try to lock this mutex M1 with this help of lock guard. Okay, so you just understand that whenever you will create the object of the lock guard, you have to pass the mutex and it will try to lock that mutex at that place only, so that you don't have to write lock, unlock and all that. Okay, so assume that it is locked. Now, as I said, let's suppose T1 locked it, then T2 will have to wait here. Okay, then T1 will go inside this for loop and will execute this buffer, increment this buffer for 10 times, and it will print that for 10 times, and once it will come out of this for loop, and the moment it is going out, this thread T1 is completed, in the destructor of this lock guard, it will unlock this mutex. This is how it works. So you create the object and pass the mutex, it will lock at that point only, and whenever the scope of this particular object is over, it will try to unlock it. So this is kind of an automatic behavior. So let's read the point now. It is very lightweight wrapper for owning the mutex. See, there is owning this M1. Okay, so it will own the mutex on scope basis. See, as I said, when it will go out of this scope, when this function call is over by this thread 0, then in that case it will unlock it. And the second point is it acquires mutex lock the moment you create the object of lock guard. That's what I said. When you create the object, it will lock the mutex. Okay. Third point is it automatically removes the lock while goes out of scope. Exactly. That's what we saw that. And fourth is you cannot explicitly unlock the lock guard. And this is very important point. This point number 4, it says that, point number 3, it says that you cannot explicitly unlock the lock guard as you was doing in this example. Here you cannot do that because this is working on scope basis. So it will unlock it automatically when the lock will go out of scope, and it will go out of scope when this boundary will hit, because this lock was created in this scope. Okay, starting and ending curly braces. So this is direct to this function. Now if you will say that, let's suppose we have this task function, task, and this is starting curly braces and this is ending curly braces, and there is this another start and early end curly braces here, and if you will write lock guard here, then what? Then yes, when it will come out of this scope, then it will call the destructor of this. And the last point is you cannot copy lock guard. Exactly, you cannot have, you cannot pass this ownership of the mutex, you cannot move this. So now you'll ask that when should I use this lock? Because there is something called unique lock. If you have already gone through that, unique lock. People are confused like when should they use this one and this one. So actually you can use this when you want to give an explicit message to the viewer of your code that after owning this mutex, I don't want to release this mutex until unless the scope is finished. So it will tell you the user that okay, you wanted the full scope. You wanted this mutex alive till the full scope wherever it was created. Okay, wherever this object was created, lock object. And about this unique lock we will see in the next video. So let's run this and sum this up. So I have compiled it, compiled successfully. Now I will run this. See, T0 started it and T1 will start with 11 because buffer was incremented till 10 by thread 0. You can see this. Okay. And if you don't know how all these work, you please go ahead and watch my previous videos on threading and watch it from the beginning so that you don't have any gap.
And don't be confused that T1 is written first, so T0 is started first. No, even T1 can start first. Let me try to give you this example. I will run this again and again and will see this just before this. See, this time I was running so many time, and this time see, this T1 started first and then T2 started. Okay, sorry, T1 started first and T0 started after that. I should change this order. Okay, but you understood, right? So T1 is created later, but T1 was created first and T0 was created later. So I guess you would have enjoyed my video. Thanks for watching, guys, and don't forget to hit the like button. If you liked the video, don't forget to hit the like button. It would help me a lot. I'll see you in the next videos. Bye bye. Hello friend, this is Rupesh and I'm watching CPP Nuts video series on C++ threading, and this video is about unique lock in C++ threading. And this is the syntax for unique lock, namespace std unique lock, and it is wrapper over mutex. So it will own the mutex. So this M1 is mutex and this lock is nothing but an object of unique lock. We'll see all these things. So what is the purpose of this unique lock? And before this we saw lock guard in previous video. So if you don't know what is lock guard, I would suggest please go ahead and watch that video before watching this one so that you can link it better. Okay. So first point is the class unique lock is a mutex ownership wrapper. Yes, it will own the mutex whatever you will pass inside object. I mean when you will create the object. Okay. And what I mean by ownership and all, I'll explain all those things later. So don't worry about that. Just understand that there is something or somewhere std mutex m1, then you can own this mutex by writing this std unique lock mutex and lock m1, and then you will handle this mutex m1 with this lock, and this lock is nothing but a variable or object, and it allows these many things. So can have different locking strategies. So when you are writing like this, you have different strategy. So this is one strategy. You don't have to write anything when you are creating this object. Another strategy could be std. Let's assume I have written unique lock and then mutex, and here some obj. Inside this you have to pass m1 and then comma, and then you will pass the locking strategy. And these are three locking strategy. One is defer lock, another one is try to lock, and another one is adopt locking. If let's suppose you're writing defer lock here like this, then in that case when you're constructing this object, this line, it will not try to lock this mutex. It will say that I'll just own this mutex but I'm not going to lock it, or in other words it will wrap this mutex but it is not going to lock it. Okay, the locking will happen in later point of time but not here. But in this case, because we have not given any defer lock here in example, so it will try to lock this mutex at this particular line only. Okay, I'll show you all these things. See, this is the example and this is example number 1. I have two examples. Example number 1 is showing that I have not written any of the locking strategy. Then in that case, it will automatically call the lock on the mutex m1. Okay, and this m1 is nothing but mutex here. And another point is, so we covered this one. Now another point is time constraint attempt at locking. So you can actually attempt the locking using time constraint lock, like try lock for and try lock until. So I have given videos for these two. You can go ahead and check out. They are very simple. It is nothing but you will do something like this: m1 dot, assuming this m1 is nothing but this mutex, m1 dot try lock for. Here you will give time, and let's suppose you have given 2 seconds. There is a syntax to give the timing. I'm just giving you the overview. Then in case if this mutex is not free, then it will wait for 2 seconds. The moment it asked for this lock, from that time to 2 seconds it will wait. Okay, otherwise if you just simply m1 dot lock, if you just simply lock it
try to lock it, and if this mutex is not free, this is going to wait for infinite amount of time if it is taking infinite amount of time. But in this case, you can tell the timing, and here also it is similar, but the syntax for time is little different for this until. Okay, so these things are also possible with this unique lock. So instead of M1, you will use, if it is lock, you will use LOCK, and here also LOCK, not here, leave it. We're not talking about this one, we're talking about this one. So this is also possible. Lock dot try lock for this much amount of time. Okay, so time constraint locking is also possible with unique lock. And third is recursive locking is also possible. I have given the video for recursive locking. If you don't know, go ahead and watch that video. Transfer of the lock ownership. Yes, you can actually move this particular lock somewhere else, but you can only move, you cannot copy, because you cannot have two ownership of the same thing. So suppose you have this mutex, you cannot have two objects pointing to this same mutex. Okay, obj2, obj1. So this is not possible. Okay, so only move is possible. You can move the ownership of this mutex from object 1 to object B. Then object 1 will no longer be the owner of this mutex. Okay, so this is covered. Now condition variable, this is a new topic I'll be covering in next video or the next video of that, and this is very good video or the topic. It is used for notification purpose. One thread T1 is running, and once it is done with some job, it can actually notify to this T2 which is actually waiting. Okay, so T1 is doing some job and T1 is waiting for some particular mutex, and once it is done, it will notify to this T2, or number of threads can be there, so it can notify to all that I'm done, and you just come and try to get the mutex. So that is a condition variable job. I'll explain all these things in the coming videos. So these things are possible with this unique lock, and these are the locking strategies. So defer lock is nothing but do not acquire ownership of the mutex at the same time. I have given this example in example number 2, so don't worry, we'll see that. And second is try to lock. So if you'll use this strategy, it will try to acquire the ownership of the mutex without blocking. So if you are not able to lock the mutex, it will not wait for that mutex. Okay, it will go ahead. And this one is assume the calling thread is already has the ownership of the mutex. It is like suppose you have already logged this mutex inside your thread. Let's suppose you have m1.lock. Okay, so you have done this. After this line, you are creating your object like this and passing this m1 to that. Then this should not wait for this mutex because you have only logged it. Just after this, this particular line, you just assume you have written this with comma here. Let's suppose you have lock and m1 comma, this is strategy adopt lock. So this makes sense, right? And assume that this full thing from here to here is written here. Okay, so you have already logged it. You have already logged this mutex, and you have come to this lines, means you own the mutex. Okay, and then you want to create the wrapper of this mutex, then it is possible. You can just tell that I want to adopt the lock which is already logged. So this is how you use that adopt lock. Now let's look at these examples and we will sum this up. So as you can see that this is fairly simple program here, and this is example number 1. Forget about this example number 2. Let me give some space here. Okay, fine. Okay, so we have 2 threads. Task will act as thread here, and we will create 2 threads. This T1 I'm passing as a thread number, and T2 is going as thread number. So T1 or T2, any one of them can hold the lock here. So let's suppose T1 have locked it, then T1 will come here and will increment this buffer for loop 4. So loop 4 is coming from here. So this 10 is assigned here, and we will increment this buffer for 10 times. And after this, notice this, we are not unlocking it because this unlocking is happening in the destructor of this unique lock. Okay, so this destructor will be called because we have created this object in stack. So destructor will automatically be called when the scope of this lock object will go off. Then in that case, in that destructor, it will unlock this mutex. Then once it is unlocked, this thread 2 will try to lock it and will get the lock and will increment this buffer from 10 to 20. And let's see that. Execute this. See, T1 incremented this from 1 to 10, and then T2 started from 11 to 20. So any one of them can start first. So it is not like T1 only will start this first and T2 will start second. No, T2 can start first and T1 can start later. So you can notice that if you have not unlocked it, T2 would have never got this lock and only T1 would have executed this and done. What I'm saying is, let's suppose if you are just simply using mutex, just that's it. Just compile this and execute it. See, it is executed till T1 and T2 is still waiting. See, we are waiting, and I'm sure we will wait till infinite and we will not get the lock. I mean, T2 will not get the lock because T1 only locked it, forgot to unlock it. So let's try to unlock that again. T1 dot unlock. So this is fine code. Let's kill this, recompile it, execute it. See, it is done. Okay, so you have to unlock it, but in our case we are not unlocking it. It is doing the job automatically because this unlock is happening in the destructor of this one. Correct? Now let's move to the next example. See, we are using the locking strategy now, and locking strategy is defer lock. So does not call the lock on the mutex m because used defer lock. Correct? So this comment says exactly what I said you before, and as you have not logged this mutex here at this line, you have to lock it later. So why we do this? Actually, what happens, we are just saying that I am owning this but I am not locking it. So you can have n number of code here and then you can lock it. So this is the flexibility which is not available in LockGuard, because LockGuard will immediately try to lock this. As I have given the comment here, it is not needed as it will be unlocked in the destructor of the unique lock. So this is fairly simple code. Let me just simply execute this one, compile successfully, executed this one. So this is also compiled and giving you the same output. Correct? So I think I'm done here. Thanks for watching, guys. Don't forget to hit the like button, guys. If you like the video, it will help me a lot, and I'll see you in the next videos. Bye-bye. Hello friends, this is Rupesh and you're watching CVP Nuts video series on C++ threading series, and this video is about condition variable. And this is very important topic if you want to synchronize your threads on some conditions. This is the answer for you. So the important point for condition variable is condition variable are used for two purposes. One is notify other threads. There is thread 1. It is running, and there is thread 2. This is also running. At some point, this went for sleeping on some condition variable. I'll explain everything, just hold for some time. I just want to give you a bigger picture of the problem, then we can go much more deeper. So assume that this thread was sleeping and this thread was working. Now after doing some job, now this thread wants to tell to this thread that please wake up. So this is called notify, and there are two ways you can notify: notify one and notify all. So notify one means, okay, let's suppose there are so many threads. So if you are using notify one and this thread is notifying, and let's suppose T2, T3, T4 till Tn were waiting for some condition variable, and you are notifying one using T1. I'll repeat this again. T1 was running, T2, T3, T4 were sleeping on some condition variable. Now T1 can notify either of this or all of them. So if it is notify one, I mean if T1 is notifying using one, then either of this will get notified. If it is using notify all will get notified. So this is about notifying. And second is wait for some conditions. So as I said, T2, T3, T4 and Tn were waiting for some condition variable. So let's suppose there is some condition variable C, and assume that using this condition variable only T1 is running. So it is running, and on this condition variable all of these are waiting. And obviously to synchronize these, you have to have this common condition variable. Okay, so for some reason all these threads were waiting for this condition variable, and this thread was running and it uses this condition variable to notify either of these or all of them. Okay, so these are two purpose of condition variable. You will notify and you can wait. Now that being said, let's directly jump to the program. We'll see all these come in a little later. So this is the program. This is very simple program. We have this balance. Let's suppose this is some kind of account and we have this balance, okay, is equal to 0. And now there are two threads, T1 and T2. One thread is trying to withdraw the money and another thread is trying to add the money, okay, and currently the balance is 0. Now what do you think? Which thread should start first and which should start second? I mean, logically, add money should start first, because if you don't have any money, you cannot withdraw it, correct? And let's suppose this withdraw money thread is starting first. So it will come here and it will try to acquire the lock, this mutex, with this unique lock. So what it means is, it is just kind of a wrapper for this mutex and owning the mutex. So this line means you are locking this mutex M here. You have successfully locked it. Now you will come here. This is condition variable dot wait, and you have to pass this unique lock object here, and there is this predicate or the condition you will check in order to go further or to wait. So that condition is, so balance is not equal to 0. Is it true? No, currently balance is 0. So it will return false. So if this predicate is returning false, then this thread will wait by releasing this mutex. So what will happen is, let's suppose this is withdraw thread. First it locked M, which is this mutex, and then it is saying that I'm waiting for this condition to be true by releasing this mutex. So this unlocking is internal inside this statement. So it will unlock and wait for this condition variable. So waiting by releasing M. So this is first and this is second. And as this is started first, it will acquire the lock first and it would have done all these things. But parallelly, this thread was also started and this is using lock guard. You can use this unique lock here, not a problem. But I didn't find any use of this unique lock here, so I just went for lock. Now the point is, this will also try to lock this mutex, but as I said, this will lock the mutex and do all these things. So it would have gone in the waiting state for this particular mutex. And as this thread 2 release this mutex, this will acquire the mutex, will add this money, which is 500, inside the balance, and it will say that okay, amount added and current balance is 500. And after adding the balance, see, this is very important point. It is saying that whoever is waiting for this condition variable, I want to notify them, and I'm using notify one because only one thread is waiting. Notify one will get executed and this thread will awake. So after awaking, this is the process. It will try to lock the mutex. If it is succeeded, it will check this condition. If this is true, so yeah, this is true because we have changed the balance. So balance is not 0 now, it is going to return true, and if it is returning true, it will go further. Okay, then it will go for if balance is greater than equal to money and all that stuff. So first step is it will try to lock the mutex. Second is it will check the condition. And what if it is awake? I mean, you notified it without changing the balance. It will again check, okay, yeah, balance is not equal to 0. It will again start waiting on this condition variable. Okay, so it is not going to go further until unless this balance is not 0. So this is very simple. I'll quickly recap it. I assumed this withdraw money thread will start first. So it will go here and it will acquire the lock. It will go here. We have condition variable dot wait, and we have to pass this UL, which is this unique lock, so that it can unlock this mutex while it is waiting for this condition variable. Okay. And we have this predicate and we'll check whether we should go further because we have this condition to go further. Okay. That's why we are using this condition variable. There is no point in deducting the money if you have 0 in your account, correct? So it will wait because currently you have 0 in your balance. So it locked the mutex, first step. Second, waited by releasing the mutex M. So this wait will release the mutex which is acquired by this UL here, okay? And as soon as you release the mutex, this one was waiting for this mutex, so it will get the mutex and it will add the money what it got from here, okay? And it will notify this thread now which is waiting on this condition variable. So see, this CV and CV has to be similar. So as this one will notify it, this thread will try to acquire the lock, okay? It will get the lock and then it will again check whether I should wait because maybe the balance is still 0. So it will check whether this condition is true, and this time it happened to be true, then it will go and do the job. So that was the first case. Let's suppose this one started first. Then it will acquire the lock, it will add the balance, and by that time this withdraw money is waiting for this lock because this mutex is already locked here, okay? So this thread is already waiting here only, okay? This is waiting here only, and this has executed and done everything. Now we don't need this condition variable notify 1 because we have not waited on this condition variable. We could not reach to this place. What is happening in this case, this is very simple. Once you have done this, you are notifying 1, but this call is totally waste because no one is waiting for this condition variable right now because this thread could not go further after this, okay? It is waiting at this line only, okay? But it will work correct because after completing this function or this thread will go off, then in that case this lock guard will call the destructor and there this mutex will be released. So once this mutex is released and this was waiting for this mutex, then it will start and it will check whether condition variable is satisfying or not. So this balance was updated. You don't have to wait here. It will return true and then you will do the job. So let's see, let's run and see the behavior of this and then we'll conclude it. I'll compile this, compile successfully. If I'll execute it, see, it is saying that amount added and current balance is 500, and this statement is coming from thread number 2. So this started first. Let me give some wait here. So as you can see, I have written this waiting statement here. So what this will do, it will call this thread and this main thread will sleep. So what I'm telling you is you can start this thread first. I don't bother because I have this condition variable and it will obviously wait for this condition variable. Just to prove that I am writing this sleep here, okay? So let's compile this again and execute this. See, it is waiting for 2 seconds and then also it did the same thing. This thread added the money first, even though this one was started first. So this is actually going and waiting because this balance is 0, okay? In this case. So let me just remove this. This is perfect. Now what if you want to deduct more than 500? Let's suppose you want to withdraw 600 but you have only 500 in your account. Then if you compile it and execute it, it is saying that amount added, current balance is 500. So again this will add the amount first and it will notify to this one, and it is saying that amount can't be deducted, current balance is less than 600, and it is saying that current balance is 500 now. So it didn't actually deducted the amount, but that is not the point. The point is whatever you do, your add money will always start first. So this is also very good way to utilize this condition variable if you want to start some thread first, but you are writing both the threads or all the threads at the same place. So it can start, your OS can start any of the thread at any time, but you want some thread to start first, then you can use these condition variables to actually run some thread before other threads. So let's quickly go through these comments. Condition variables allow running threads to wait on some conditions, and once those conditions are met, the waiting thread is notified using notify 1 or notify all. And that's what you did here, correct? You notified. Then second point is you need mutex to use the condition variable. Obviously, it will use this particular mutex to actually wait on. okay? And the mutex release is automatic inside this. Don't forget that. Third point is, if some thread wants to wait on some condition variable, then it has to do these things. So these are the step A, B, C. If you want to wait on some condition variable, you have to do all these. One is acquire the mutex lock using std unique or whatever object you want to write, but you have to acquire the lock. Second is execute the wait for or wait until. There are 3 flavors for this. You can go and check that. There are not much difference for these things. They are just for time constrained. Okay. Our main focus is on this one, wait. So we'll say that we'll execute wait, and the wait operation automatically releases the mutex and suspend the execution of the thread if that condition is not true. And the third is when the condition variable is notified, the thread is awakened and the mutex is automatically reacquired. And the next thing is the thread should then check the condition and resume waiting if the wake up was spurious. What I mean is, after locking, you can again check whether this condition is meeting or not. If it is not meeting, you will again go for sleeping, because this notification can be spurious. And what I mean by spurious is, for now you just understand that the false wake, okay? Someone did this by mistake. You just understand like this. Someone notified you by mistake, even if this condition is not met. I mean, this balance is still 0, but someone notified you. So you will again wake up and check whether this balance is 0. If it is 0, you will again sleep. Now the take home is, condition variables are used to synchronize 2 or more threads. Yes, you can synchronize threads using condition variable by saying, okay, now you do the job, now I'll do the job, okay, things like that, okay? You can notify from one thread to another thread which is actually sleeping on some condition. And the best use case of condition variable is producer consumer problem, and this I will explain in next video. So go ahead and watch that video, and thanks for watching. I'll see you in the next videos. Bye bye. Don't forget to hit the like button. It will help me a lot. See you. Bye bye. Hello friends, this is Rupesh and I'm watching C Beginners video series on C++ MCQ questions, and this MCQ question is about a threading MCQ question, and this is number 2. And I didn't had much time, so I'm giving this MCQ video today, and these days I'm explaining threading. So this video is about threading. I mean, this MCQ is about threading. I'll check your knowledge on threading, and I may surprise you if you are not much into the threading and all, okay? So let's see if you can answer for this question. So pause the video and try to understand what is happening here. And if you happen to find that problem's solution, let me know in the comment section. So wait for some time, you'll get the answer. So 1, 2, 3, 4, 5. I think you would have come up with the answers. So let's check out whether there is some problem in this code or not. So first let's compile this. So if I just simply compile this, it has compiled successfully. So compilation error is not there. If I'll execute it, there is no problem in this code. But wait a minute, don't go anywhere. There is a problem in this code, and I'm going to explain that to you. Can you see the locking order is reversed? First thread. Okay, let's start from the beginning. So we have thread 1 and thread 2. Thread 1, thread 2 functions are different. So these two will start parallelly, and thread 1 will try to lock mutex M1 and thread 2 will try to lock mutex 2, and then thread 2 will try to lock mutex 1 and thread 1 will try to lock mutex 2. Can you see this? And recall there was some problem called deadlock. Yes, this is a deadlock situation here. I'll explain you what deadlock is and why this is a deadlock situation. Let's assume this T1 and T2 started. So this is thread access, this is thread, and this is time. The possibility is, as we are starting these two threads at the same time, the possibility is not at 1 second. Let's suppose unit is microseconds. This one is 1 microsecond, 2 microsecond, and 3 microseconds. So at 1 microsecond, these two threads were able to lock mutex M1, and this one was able to lock mutex 2. So here you have M2 locked, and here you have M1 locked. Now at this stage there is no issue, because M1 was not locked yet and here M2 was not locked. Okay, so and let's suppose at second microseconds both are trying to lock. I mean, this one T1 is trying to lock M2 and this one is trying to lock M1. So M2 was locked already by thread 2 and M1 was locked by thread 1. And you know this, if you want to lock and if it is already locked, you will wait. So this thread will wait, and similarly this thread 2 will also wait because M1 is locked before. So this is one of the example of deadlock. Deadlock means, let's suppose there are two resources. Deadlock cannot come in single resource and there are two processes. So this process want to have this while this process is holding this resource. Okay, so this is a resource and this is process. This P1 want this resource while it is holding this resource. So it's like two boys asking that you give me your chocolate and then only I will give my chocolate, and another boy is also telling the same thing. If you will give my chocolate, if you will give your chocolate, I will give my chocolate. Correct? Then there is a deadlock. No one is gonna give chocolate to each other. And the same situation is coming here. And if I will run this, you may not see the problem here because our processor is very much fast that this particular condition may arise in 1,000 times, or it may arrive at first attempt also. But there is a situation, I mean, there is a possibility that it may not come in even 1,000,000 times. Okay, but this can come, and if your system, whatever system you have designed, is not deadlock proof, then this is not a good system. And if I want to show you the deadlock, what I have to do is I have to put a weight in between this one and this one. So you can see that it was not failing. It was perfectly fine code. If I'll run this, see, I'm running it so many times, but still it is not blocking. Okay, there is no deadlock. It is exit successfully. Okay, but if you want to see the deadlock, let me include this like this. Okay, if I'll compile this, compile successfully, see, if I executed it, see, my cursor is actually waiting here. Let me just kill this and clear the console and re-execute it. See, it is waiting. I mean, system is inside deadlock. It is not going to come outside. So let's see what is happening here. Thread 1, thread 2 started parallelly. Thread 1 logged mutex M1 and went for sleep. Thread 2 logged mutex and went for sleep. Then both wake up and asking for each other's mutex. Okay, and this is not going to happen. Before I was not applying this, then in that case it was not coming as a deadlock, but it is a deadlock because our computer is so fast that whenever it was acquiring the lock of this mutex M1, at the same time it was able to lock this M2, and thread 2 was not even started by that time, or vice versa. If thread 2 started first, then thread 2 was able to lock mutex, and after that it was able to lock mutex M1, and thread 1 was not started by that time. As this thread 2 have locked both, and let's suppose thread 1 is actually reaching here, once this thread 2 have both the locks successfully, then thread 1 will wait here. There is no problem. And once this unlock will happen, it will get the lock and will do the job. But the situation is when thread 1 reaches to M1 and when thread 2 reaches to M2 and locked, and then just after that thread 2 is also looking for this, I mean executing the second statement, thread 1 is also executing the second statement, then in that case it will be the problem. Otherwise it is not the problem. Okay, so the solution to this problem is you should not change the order of your mutex lock. There won't be any issue if you have this like this. There is no possibility of deadlock here. because either of this thread will happen to log mutex m1, and if thread 2 logged mutex m1, thread 1 cannot, and if thread 1 cannot, it will wait here, and by that time thread 2 will lock mutex m2 and will do the job, unlock these two, and then it will wake up and do the job. So there is no situation that it can have a deadlock here. Let me just place that again, that wait, and we can see that. See, I'll put the wait here again, and I'll put the wait here, and we can compile this. See, it is still in the deadlock situation. See, so that is what the deadlock is. My goodness. Change this one and change this one. Recompile, execute this. See, no issue. Even if you are sleeping, there is no problem. So thanks for watching, and if you like the video, don't forget to hit the like button, guys, and make sure you subscribe to my channel so that you can get the notification for upcoming videos like this. I'll see you in the next videos. Bye bye.
Hello friends, this is Rupesh and watching C Peanuts video series on C++, and this video is about virtual functions in C++. So this is going to be the introduction video. We will have 3-4 more videos like what is virtual destructor, what is the way compiler actually achieves the dynamic polymorphism, like literally compiler changes the code. Like when you write this as virtual here, I'll tell you everything about this one. But when we create virtual functions, compiler changes the code. So I will cover everything about the virtual functions in different videos, and this video is about why to use virtual functions and how to use them, and few additional notes. So let's start. So the first point is why you should use virtual function. There is only one reason why you will use virtual function is to achieve dynamic polymorphism. If you don't know what is dynamic polymorphism, we will learn that here with this program, but bear with me till that. So why to use virtual function? To achieve dynamic polymorphism, which is the ability to call derived class function using base class either pointer or reference. So I'll repeat this again. Virtual function is used to achieve dynamic polymorphism, and dynamic polymorphism is nothing but calling derived class function using base class pointer or reference. So let's see that with this example. You have this base class, and we have inherited this base class into derived class, and both classes have same function, fun and fun. Okay, so if I will do something like this, we have base pointer b is equal to new derived, and if I'll just simply call b this function fun, what do you expect this function to return? Print. Is it going to print am I base function, or I am base function, or I am derived function? Now here's the point. This b is of type base, but it contains derived, meaning it is pointing to derived object, even if it is of base type. So sometime what happens, you want to call this one, and sometime you want to call this one with the same piece of code, So when you want to call this one, you don't have to do anything. You don't need virtual function. It will call without virtual function. But when you have to call this one with this line or these two lines, then you have to have virtual function here, meaning you have to write virtual keyword here. You have to make this function virtual. That's it. That's the only job you have to do. So let's see the practical and we'll understand a little better. So as I told you, we can have base pointer b is equal to new derived, and base is actually calling this function. What do you think should be called here? So I'll compile the code and try to execute this. See, it is saying I am base fun. So this piece of code is actually printing I am base fun. Okay, that's cool. We can understand that. Okay, we are not using any virtual function here, so it will not call the children, the derived one. It will always call the base one, this one. So now let's apply the virtual keyword here and we'll see the magic. Let me compile this and execute. See, it is saying I am derived fun. So this piece of code is exactly same, but what you achieved is calling this one. So it's very simple, and the same can be achieved with the reference. So only reference and pointer can be used with the virtual function. Don't forget that. This is very important point. Okay, you cannot use virtual function without pointer and references. So I will create derived D and we'll assign this D here, and we can call this B with this one. So let me compile this and execute this. See, it is still giving I am derived function. And if I'll remove this virtual from here and we can save, compile and execute, see, it will still say that I am base function. So the whole idea is, now you can understand that, right? Like this B here is a container. It is not the whole object. It's just saying that I'm base type, but I contain D, which is of derived type. So now you can see the use here is very clear. If you want to call derived class function from base class, pointer or reference, you have to use virtual function. And so many people, when I say this line, people just get confused like, okay, so let's suppose if I have some another function like fun1, then what? If I'll print something here like this is fun1, that's it. And is it going to print this one? No, it is not, because see, if I will try to do b dot fun, no, there is no fun1. We have only fun, because b knows only this function. B doesn't know anything about this one. This is inside derived. So no matter what object this b is containing, you cannot call that function which doesn't belong to base, because base doesn't have any information about that. And this is compile time checking. So you have to have this fun1 in base also. So then you won't have any problem. So fun1, and that's it. And then this problem will go. See, it's gone. So there are few rules. We will see all these theory here. And I must tell you, if you're a C++ developer, this feature is a killer feature for you. We'll see this in more detail in coming videos, and I'll explain you how compiler will actually change the code in order to achieve this. Like, you remember, right? I mean, same piece of code, this will sometime call this one and sometime call this one. Correct? We are not changing the calling here. We are just changing the function declaration, and it is changing which one to call, meaning it is picking at runtime. That is dynamic polymorphism. Dynamic meaning it is not static. It's not at compile time. It is at runtime. It takes the decision at runtime which one to call. And this piece of code here will change. And how it changes, I'll show you that in coming videos. So for now, let's go for this theory and we'll understand this better. So we have seen this line so far. Let's go for how to use virtual function by declaring function as a virtual in a base class and overriding that function in a derived class. So this overriding is very important word here, because you have to have both function signature exactly same. Then only you can achieve this virtual functions behavior. Otherwise, I show you that, right? Like function 1 was not accessible here. And even if it is accessible, if your function signature is not similar, it won't do. So I have mentioned here like function signature should be same in the base and derived classes. And second point is declaring a function as virtual in base class is enough. Derived class function need not to be declared virtual. What I mean is we have this function and I'm just writing virtual here, right? Like this. I can write virtual here also, but this is not needed. Okay. You just have to declare this function virtual, meaning the top hierarchy would have function declared as virtual, and then in consecutive hierarchies like we have base, and then we have D1, and then D1 is inherited into D2, and then D3, and then D4. Then here also, if you have that fun function, you don't have to mention that virtual keyword for this one. You just have to mention here, meaning here. And this function would be treated as virtual here, here, and here, and here, everywhere. You don't have to do that virtual thing everywhere. Clear, right? So let's look at another point. Virtual function should be accessed using pointer or reference of base class type to achieve the runtime polymorphism. We understood this very well. And the additional notes are virtual function cannot be static. Okay, this is a very important point. You cannot have static keyword here when you have virtual keyword, okay? And a friend function of another class. So there are some restrictions
with the virtual functions. Another point is a class can have virtual destructor but can't have virtual constructor. So you know that you cannot create a virtual constructor. It is really very famous thing in C++. You cannot have virtual constructor, but you can have virtual destructor. And I will show you how to create virtual destructor and what is the biggest use of that. And the third point is, so there are two types, virtual function, which I explained you here. So this is virtual function type. Another one is pure virtual function. I'll show you what is pure here. Pure meaning, let's create another virtual function here. Virtual void fun1 is equal to 0. So this function is now a pure virtual function example. Pure meaning it doesn't have the body. You have to use this syntax in order to tell that I'm creating this function as a pure virtual function. So when you have pure virtual function, you don't give the body. And when you don't give the body for some class, like base class, you are not giving the body of this function, then this base class becomes abstract class. Now you cannot instantiate the object of base class. So if you don't have this, and if you write this, let me quickly show you that, like base B, if you want to do this, you can clearly do this. I will say B1. So you can do this. Forget about this one. You can do this. If I'll uncomment this one, it will tell you that you cannot have it because it is abstract class. See, it is saying that object of abstract class type base is not allowed. Meaning we have created this class as abstract. Abstract meaning your class is not fully constructible because there is some missing information in that. And let's suppose you inherited this abstract class into this one and you didn't give this function body here. Then this class, derived class, will also automatically become an abstract class. Let me uncomment this particular piece of code and this will also tell you the same thing. Like, see, object of abstract type derived, meaning both the classes are not instantiable now. You cannot create the object of these two classes. They are abstract classes. Now how to get rid of this? You just have to give the body. Like void fun1 and that's it. See, that error is gone here. Now you can instantiate derived class, but still base class cannot be instantiated because we have pure virtual function inside that. So now you might be wondering that why we create some function as pure virtual function. What happens, like sometimes you don't have the actual definition of that functionality, meaning let's create this like animal, and we have animal here, and we have like, let's make this cat, and I'll just simply copy paste, and this is going to be maybe a cow. Okay, so this is cat, this is cow, and let's make this function as eat, and this is going to be eat, and let's remove this one and this one, and let's make this one removed, and we don't have the body for this one because I'll tell you why. See, I can create this eat is equal to 0 here. Okay, and if it is cat, I would say eating non-veg, and when it is cow, I can say eating veg. So it depends on the derived class what the definition of that particular functionality would be. It's not the parent who will tell what that functionality would be, but parent would obviously tell that if it is animal, they definitely eat, but I don't know what they will eat because animal can be cat and dog and n number of animals. So they have their own taste and eating habits. What they eat, it depends on them. But I know for sure that they all will eat. So I will give you the functionality, but I cannot give the body. So we'll remove this, and this one will remove everything. And we can have the similar code like animal pointer a is equal to new. We have cow here and a eat, and we'll save this. Let's run this and execute eating veg. See, because it is cow. And if we will have a cat here instead of cow, it will eat. Okay, I didn't save. I was confused like what happened. Okay, see, eating non-veg. So now you must be able to understand why we use virtual function and what is the essence of using pure virtual function. Pure virtual function just tells to the world that actually I don't have the definition for this particular functional or functionality, but I do know that if this is the class, this functionality should exist. If you are not giving the body of this functionality in your derived classes, like cat and cow, you cannot create those classes. So this is the beauty. Like if I'm not giving this eat function inside this cat, let's say, or instead of commenting, I can just say eat1. And if I'll save this, see, it will tell that you cannot create this class because you have not given the body for this eat function. So if you want to become animal, meaning you are inheriting this animal inside this cat, meaning you are saying that cat is an animal. And if you want to become an animal, you have to give this body. If you're not giving the body, you cannot become animal. So this is the restriction you impose to the derived classes by creating pure virtual functions. So I think we have learned pure virtual function and virtual function. Don't worry, I'll create a separate video for virtual function. I just explained a little bit about virtual function. I'll have a better example in next video maybe. But I know you might have understood this pretty well. So thanks for watching, guys. Consider liking and subscribing this channel so that you can get the notification for upcoming videos. Bye bye. Hello friends, this is Rupesh and I'm watching CP Peanuts video series on C++, and this video is about virtual destructor. So before this video, we have learned about virtual function. There I explained what is the use of virtual functions and how to use them. So if you don't know or not sure about the topic, please go ahead and check this. You'll be getting this link somewhere here as a pop-up. So I hope you know virtual function very well. So let's understand what is virtual destructor and why do you need that. So the whole point about virtual is you always have this kind of scenarios, like you have base pointer and you have a derived class object into base pointer or base reference. But in case of virtual destructor, we will only have base pointer or pointer example, not the reference example, because references are not deleted using this delete keyword. We always delete pointers. So you actually have this scenario. Now what happens when you delete this B? Because you created this pointer, meaning somewhere you wrote new keyword. And the moment you write new keyword, you have to write delete keyword. It's just very simple to understand. Whenever you create your own memory, you have to take care to delete that. This much is clear, right? Now, when you delete it, what happens? Because it's not straightforward delete. See, the catch is you have a wrapper of base type, but inside that you have object of derived type. So basically, when you say that I am deleting this B, meaning you are deleting this particular object, because this particular wrapper thing here is just the wrapper. It doesn't have anything of its own. It is pointing to this derived object. So ultimately, when you say this, you should say, or compiler or computers will understand that it has to delete this object. So now I'll tell you what will happen when we'll execute this one. So let's compile this and execute this. See, this code is printing base constructor, derived constructor, meaning this derived object was constructed. This has nothing to do with the construction because it is just the pointer. We are going to point this particular object, okay? So the construction will happen here, okay? So due to this, what will get constructed? It will come and check here, okay, I have to construct this, but it has the base one. So it has to go to the base one to construct first. So it will construct here, meaning this will get printed. So this constructor of base is printed, and then it has to come down and construct this derived object. So this constructor of derived is printed. This is cool. There is no problem. And then what we did, we're saying that, okay, delete this pointer. Then in that case, it is deleting only the base part, not the derived part. To explain you a little better, let me do this. We have a derived D, and if I will save this and compile and execute, see, this one is saying constructor of base, constructor of derived, and then destructor of derived and destructor of base. So you know that destruction happens in the reverse order of construction, because this you can understand it like a stack based operation. Which one got constructed first will get destroyed first. So sorry, which one got constructed last will get destroyed first. because it follows stack, and stack is like last in, first out. So this constructor of derived was constructed first. So that's why it will get destructed first and then base one. So this is clear, right? If you have normal object and when you will go out of this scope, then it will get destructed and then there is no issue. But when you have this piece of code, then the problem starts.
Hey guys, time for a quick pause, and what you're seeing right now is my Patreon page. So if you don't know what is Patreon, it's a crowdfunding website where you can support any content creator like me, and in return you get rewards. So if you join me, I can be your private tutor, or you just want to chat with me and ask your doubts, or maybe you just want to support me with very small amount and I'll still have something for you. So do visit my Patreon page and see if you like it. And if you want to discontinue anytime, you can do that. So if you have already visited my Patreon page, let's continue our video now.
Because you're saying that I'm going to delete this B and compiler will only check, okay, this B is of base type. So it will just simply call the base class destructor. It is not calling the derived class destructor. Your compiler doesn't know that what type of object this B is holding. That's why we have to use virtual destructor. So this is what it is. So in order to achieve virtual destruction, you just have to do this. You have to write virtual in front of your base class destructor. And that's it. Now if I will run the same piece of code without changing anything, see, this is also printing base derived base. So now you understand the problem was, it was not calling the derived class object, destructor, because it didn't know that I'm holding something else. It will just call the delete on B and it will simply just go and check, okay, this is the destructor, it will call destructor for this one. But when we apply virtual, magically it knows that no, whatever the object this B is pointing to, I'm supposed to delete that. Then it will delete the base part as well as the derived part. And this whole thing is happening just because we are wrapping this child class object into base class. If it is child class only, let's suppose we have this derived and this is D. There is no point to change this, but still okay. Now if it is derived, D is equal to derived, then there is no issue. I'll show you that. We don't need this virtual. I'll remove this and compile this. It will still remove everything. See, it destructed derived part and base class part both. And previously, actually we were doing this. We had base class. That's when it was an issue. And you know the problem with this? If you don't delete the derived part, only base part is deleted. The problem is you may have to face memory leak because you're not deleting the derived part. You're just deleting the base part from derived object. So it's just that simple. So let's look at this theory. If we delete child class object through a pointer of parent class, then it is undefined behavior. So yeah, obviously this is not defined. So you may have different result with different compilers. So it is undefined behavior if parent class doesn't have virtual destructor. And if we fail to declare destructor as virtual in parent class, then we end up having memory leak. So this is the problem with this. So the take home note I would say is, whenever there is a chance that you will have this kind of behavior, like you are going to catch your child class into parent class, you just blindly do this. I know there is a problem here because you're increasing your class size, but it is safer code, you know. What do I mean by size of the class is, when you create a virtual function or virtual destructor, you end up having virtual pointer in your class, which will actually hold the virtual table address. So that is the next video part, like what is virtual pointer, virtual table and all. So if you have this, I'll show you the size of your derived class. Let me just have this and we can print size of this D. Compiled and executed. See, it is printing 8. If I will remove this and then I'll compile and execute, it is saying 1. So you know that, okay, there is no data member in derived class. It is empty class, but still the size would be 1. I have given the video why it is 1. But the whole point is, when you had virtual here, it actually created a VPTR pointer here in your class. And if it is 64-bit system, it is 8 byte, and if it is 32, it is 4 bytes. So that would be a wastage, but you will be writing a safer code, okay? Or another point is, let's suppose you have some function void fun, and you declare that function as virtual, okay? Then also you blindly go and do this virtual. No need to think about anything, okay? And you don't have to do this virtual thing everywhere in the destructor. No, the same rule follows. You just have to do it once in the base class. That's it. So that's the whole job of virtual destructor. It will enable you to know that, or enable the computer to know that what kind of object is being holded under the pointer. So it will delete that object instead of just deleting the base part of that. So this video is completed. Next video is about virtual pointer and virtual table. So many interviewers actually ask what is virtual pointer, what is virtual table, and I know people get confused. Like they don't know when these pointers get constructed and where these pointers get constructed and all that. So these are pretty basic stuff you should know if you're going for interview, because I have seen very experienced people also don't know all these answers. So I'll see you in the next video with all the answers about virtual pointer and virtual table. So consider liking this video if you liked it, and subscribe to my channel if you're new to this channel so that you can get the notification for upcoming videos like this. Bye bye.
Hello friend, this is Rupesh and I'm watching CP Peanuts video series on C++, and this video is about pure virtual function. So before this you must be knowing what is virtual function so that you will be able to understand this video, because it's the extension of that, okay? So now I assume that you have watched my previous video which is about virtual functions, so let's go for this video. So the syntax is like virtual return type function name parameter and equal to 0. So this is going to be the syntax of your virtual function, and if you want to exactly see how it would look like in real scenario, this is the pure virtual function, like virtual and then return type move. You can have any parameters here and equal to 0. This looks little weird, like why you will equate some function with 0. We'll come to that. This is the main beauty of this function. The idea is you're telling that, dude, I know I am an animal. I have a function name, but I don't have the body for that. So this is how you will tell to the computer. And why all this? We'll see that. Okay. So there is this example. We'll see that with this. But let's go with the notes first. So the note says if some class can have only signature of the function but not the body, then we use pure virtual function. And why some class will have only function signature, not the body, we'll see that. Second point, which is very important, sometime in base class, we know the function name, but not the definition of the function. So we want derived classes to provide the definition of the functions. So if you will see this, there is this animal class. I'm going to take a traditional example what people take, so that if you don't understand somewhere else, you'll be able to understand here. So as I said, we have animal class, but animal meaning what? It's a generic term where you can think like, okay, there is something which is alive, which can move and breathe and probably can see, walk, run. So all these things will come in your mind, right? If someone says animal. So you will start defining the behavior of the animal here, but you exactly don't know what would be the type of movement. What I mean is, let's suppose we have this move function, and we can have other function for animal like eat. So they all eat, but we don't know, because some animals only eat veg and others only eat non-veg, and there are few animals they eat both veg and non-veg, and we have specific terms for those animals. I don't know those terms, but you know they eat, right? So like this, you can have functions in this animal, but you don't know how they will behave. Meaning if you will call eat, are they going to eat non-veg or veg? So it's like their own type would define their eating pattern, their moving pattern. So similarly, see, I have taken cow. Cow is an animal. So that's why we can inherit this animal class into the cow. And similarly, snake is also an animal. We can inherit this snake into this, animal into this snake. And when we will say snake move
it will move rectilinear locomotion way, whereas cow can walk and run. So the movement of cow, buffalo and animal, they all can walk and run, but snakes like animal movement style is different. So they are called rectilinear locomotion, but both fall into same category. They both are animal. So now you will think, why am I talking all these things? The reason is, when you design a system, you design like this. What you say, okay, I will have one bigger entity like animal, and these things are going to be the behavior of that entity. So for example, let's suppose you're creating a mobile class. So this is going to be the base class. So
hey guys, time for a quick pause, and what you're seeing right now is my Patreon page. So if you don't know what is Patreon, it's a crowdfunding website where you can support any content creator like me, and in return you get rewards. So if you join me, I can be your private tutor, or you just want to chat with me and ask your doubts, or maybe you just want to support me with very small amount and I'll still have something for you. So do visit my Patreon page and see if you like it. And if you want to discontinue anytime, you can do that. So if you have already visited my Patreon page, let's continue our video now.
when you design a system, you say that, okay, I will have something like mobile. Then you define how that would look like or what features you will have. So you will have screen and you will have RAM, how much you'll define. It will play music, it will play game, all that thing. So let's suppose your class is ready and you call that class as mobile. Okay, so this is the one. Now you will inherit so many mobiles will be there, like I don't know, I don't remember the mobile name, maybe Samsung X1, I don't know, is there any mobile like that? Moto GX and some mobile, okay? So all these mobiles will inherit this base class mobile. Then only they can call themselves a mobile. This is how it works in programming. So how did you define this base class mobile? You said it should have a screen. It should play music. It should be able to play game. It should be able to call. Most important feature. But any mobile can have whatever the size of the screen, doesn't matter, right? Maybe it can be X size, it can be Y size, okay? So size can be different. That's why when you was creating this mobile class, you could not give the size, exact size. But what you said, it will have size, it will have this, it will have that. But you don't know the exact figure. But you said, okay, it will have this, that, this, that, this, that. And now if you're telling yourself that, okay, I am mobile, then you have to inherit this mobile and you have to implement all those functions. Yeah, this is very important. Now see this. You said animal move. Now if it is cow, it will have its own movement style, and if it is snake type animal, it will have its own movement style, okay? Now the important point is, as this cow wants to tell that I am an animal, here it is like cow is an animal. This inheritance is a relationship, right? So cow is an animal. And if cow wants to say that, then cow has to implement, or in layman term, have to give the definition of the function what's there in this animal as pure virtual function. Because this class is telling that I know what all functions I will be doing, but the derived class have to give the definition for that, because it depends on the derived class how they want to behave on my functions. And if they fail to do this, maybe let's suppose you're not giving this move function here. See, if you're not giving this, and let's suppose you're trying to create cow, see, it will give you an error. Error is object of abstract class type cow is not allowed. Meaning, in simple term, it is like you have inherited animal, but you are not giving this function definition. So we cannot instantiate, meaning you cannot create an object of that. Whereas you can create a reference and a pointer. So I'll show you that. So if you create this pointer, see, there is no problem. This will automatically go. See, it's gone.
And if you will create the reference, again it will not be an issue. But you cannot create a simple object, meaning you cannot instantiate this object because this is incomplete. This is not complete. You have to give the definition of this move here. Then only you can call yourself animal. So this, you see, is like a restriction to the derived classes, that if you want to call yourself animal, you have to implement this function. So this works this way also. Like if you want to call yourself something, you have to implement all these functions what I provide. Then only you can call yourself animal. You can have your extra functions, I don't care. So this animal is saying that you can have n number of functions with you, I don't care. But you have to have these functions what I give. Okay? And similarly goes for the snack. So let's see the theory if I'm missing something here. So sometime in base class, okay, I have gone through this. Yeah. So sometime in base class, we know the function name, but not the definition of the function. So now you understood, right? Why you don't know the definition of the function? Why you only know the signature of the function? Because it is a base class. There will be n number of derived classes and they will have their own definition for that. Correct? Yeah. And next point is we can actually give body of pure virtual function. Okay, this is cool. I mean, if you will ask this point, no, maybe 10, 15 years, 20 years of experience guy can miss this point, I have seen people really don't know this, that you can actually give the body of this function in animal class. And you can call that body. There is no issue. Now you might be thinking, how would I give that? You can give it like this. Return type, you have void and then animal and then move. So this is how you'll give the body. And you can have, this is, sorry, my keyboard is gone, animal class. So this is going to be the bonus of this video. If you already knew what virtual function meaning and you just wanted to see my video, so this is the bonus. Maybe you didn't know that, okay, this move function can have the body and you can actually call this body from any function here. So let's implement this function also, void move, sorry, it's keyboard, not me, see out, I can walk, oh my god, walk and run. And from here you can access animal move function. But before this, oh, I'm getting some error here. Oh, yes, it should be accessible, correct? Yeah, so this is public. Now you can access this. Okay, shall we run this program and see what is the output? So I'll compile this, compile successfully. If I'll execute this, it's not printing anything. I'm so sorry, I just forgot to call c.move. Okay, compile again. Oh my god, what is this? Okay, c.move. Oh yeah, same mistake. We don't have public here and similarly public here. This is pretty common mistake. Yeah, compile successfully, executed. So this is animal class. This can walk, I mean, I can walk and run. So if you see this, you are calling this move function, which is of animal class. And people don't know that there is something like this facility available to you. So one of the interviewer in some company asked me long back that, why Rupesh, why you will give the definition of this pure virtual function where you say that, okay, I don't want to give the definition because I don't have the definition, and then next line you are giving the definition. What is this contradictory stuff? And I was like, no, actually this can be useful. What if there is a common thing in between all the move of your derived classes like snake and cow? Maybe you just want to print some function before moving. You just want to shout like, hey, I'm going to move. So this is what you will be doing, whatever the animal you are, like cow, snake. If you apply this, that you have to shout, hey, I'm going to move, like this for each and every animal, then that becomes common. And that common thing you don't have to write in each and every function. You just keep it here. And whenever you need that, you just call that here. Or there can be n number of different things you can do here. You can just put some comment like here we can comment like this function would include moving your body part from one place to another place, correct? So this gives you some hint to the implementer of derived classes that what should be the behavior of this move class, correct? I don't know, maybe whatever you want to take this function for, you can do it. But you can give the definition of this function, which you call I can't give the definition for. And I already told you that if you will not give the definition in the derived class, it won't work. So let's look at another point. We can give the body. Yeah, we saw that. If you have pure virtual function in your class, it means that class is an abstract class and you cannot create an object of that class. Yes, I already told you that, but I didn't tell that you cannot create the object of this animal class because this is abstract class. It is incomplete class. See, it is saying that where is the object of abstract class type animal is not allowed because it is abstract, it's not complete. Okay, even if we have this function here, then also it's not complete. I cannot create the object of this, but you can create reference and pointer. So if I'll create the pointer here, see, it's gone, and reference, see, then also it's gone. So that's why I mentioned here, but pointer and references can be created. And the use case of this type of classes, which you call abstract class, is to create abstract classes, obviously, which helps in creating the interfaces, which we call APIs. So I'll create different videos for all these things, maybe, in order to understand better. For now, you just take this much from this video, that there is a way for you to call that I know my class will have this function, but I don't know the body of this function because this is a generic class and you have to inherit this class and you have to implement these functions. And this point, main point, you can give the body of pure virtual function. You didn't knew this, right? Comment. You have to comment if you knew or if you didn't knew this. I want to know how many people already knew this. And you can amaze your friend, professor, colleague with this small thing. I know that it's always cool to learn new things. So with this, I'll sum this video. I hope I'm not missing anything. Thanks for watching, guys. Bye bye. Take care.
Hello friends, this is Rupesh and watching C Peanuts video series on C++, and this video is about object-oriented programming in C++, especially because if you're a C++ developer, you should know what is this rule of 3 and rule of 5. They are pretty old rules, but if somebody tells you that, okay, this rule of 3 or rule of 5 doesn't apply or it does apply, then you should be knowing that, right? Like what he or she is trying to tell you. So first, this rule of 3 came, and this is for before C++ 11. Okay, so this rule was holding good before C++ 11, but after that, this rule applies. Okay, so I just said that C++ 11, afterwards we'll have rule of 5. But what are all these? We'll see that. If you create a class and you see that you need a destructor, then rule of 3 tells that if you feel that you need a destructor, then you need these two also. And if you need copy constructor, then you need this one and this one. And if you need copy assignment operator, then you need both of these. Meaning, if you feel that you need either of these functions, special functions in your class, then you need all of these three, like 99.99% of the time. So always create the whole package, like don't miss out anything. And I'm sure you should be knowing what is like copy constructor and copy assignment operator. And after C++ 11, we have these two new special functions added in C++, which is about move semantics, like you have move constructor and move assignment operator, which I haven't talked about in my videos. I'll come with these videos pretty soon, don't worry. Now after C++ 11, the idea is same. If you are going to create any of these functions in your class, then you probably need all of these 5. So for example, why you need destructor? You need destructor so that, compiler give you all of these 5 functions, right? In built. You don't have to write them if you don't want. And if you're writing these things, meaning you are overriding the compiler's given functions. And you will override that in some circumstances. And one of them could be if you're using a pointer in your class, and when your object is destroyed, meaning deleted, you want that pointer to be deleted. What I mean is class A. So we have this class A and B pointer. So this you want to delete when you are deleting the object of A, right? So in destructor, you will free or delete all these things, correct? Now, if you are having pointer, then you must consider having copy constructor, because if you are not having copy constructor, and if you're using the compiler given copy constructor, then it will have a shallow copy. And I have a video for that, what is shallow copy and deep copy. So if you don't want shallow copy, you have to override the copy constructor, and the same reason for assignment operator. And these two are like very special cases. It actually takes your object from some temporary location to some actual location so that you can get the address and stuff like that. But let's not talk about these two now. We'll have a separate video for these two functions. So to sum this video, I would say if you are creating, okay, let's concentrate on this one, because I don't think nowadays people use this rule of 3, because C++ 11 is like pretty common nowadays. So you always have to use this rule of 5. So the take home advice is, if you think you need a destructor, then you should consider thinking about these 4. Or if you think you need either of these, you should think like, do I need others also? Then you create them. And rule of 5 says that if you create one of them, you just blindly create others. It's just the rule, because it's a rule, right? Yeah. So it's just a stopper. Dude, stop. Think. And yeah, it's called rule of big 5, and this is called rule of big 3 also. So enough theory. Let's sum this up. See you in the next videos. Bye-bye. Hello friends, this is Rupesh and you're watching CP Peanuts video series on C++ programming series, and this video is about Lvalue and Rvalue in C++. So, and then we'll little bit talk about what is Lvalue and Rvalue references, and I'll have a separate video for Lvalue and Rvalue references. So every expression in C++ is either Lvalue or Rvalue expression. So if some expression is Lvalue, so we'll see the definition. Lvalue is if you can take address of expression. So some expression is there, if you can take the address of that, then it is Lvalue. Okay, and they last extended period of time, meaning they last more than one line. I'll tell you what I mean by that. So the important point is you can take the address of expressions. Okay, now Rvalue is exactly opposite. You cannot take the address of Rvalues, and they are temporary. They don't exist after one line. So Lvalue, yes, you can take the address of that. Rvalue, you cannot take the address. And Lvalue lasts more than one line, and Rvalue is like limited to one line only. So let's see the examples here. We have integer x is equal to 10. So this 10 is Rvalue, whereas this x is Lvalue. You can take the address of x, but you cannot take the address of 10. Another example is integer a is equal to 10, b is equal to 20, and then you have integer x is equal to a plus b. So this a plus b, whatever the result would be, that is 30. Then this 30 is Rvalue. So the result of this expression is Rvalue, whereas this x is Lvalue. So x is Lvalue and a plus b is Rvalue. Because you know that you cannot put ampersand here. It's like this. You cannot take the address of a plus b and assign it into some integer pointer p, because it will throw an error saying that a plus b is not Lvalue. Similarly, for classes, if you have some class, let's say cat, and then you create an object like this, then this particular thing, this is like creating an object, temporary object, I should say, assigning that object to this C. So if your compiler is not optimizing stuff, it should do the construction of this cat object, which is temporary, and then it will assign that to this C. So the copy constructor would be called here. Okay. So this cat, which is temporary here, is Rvalue, and this cat object would not last more than this line. What I mean is, can you access this particular object in next line, maybe just after this? Answer is no. You can use only C, but you cannot use what was constructed here. And that's why that is Rvalue. You constructed this temporary object and assign into C, and then this cat is destroyed. But the values you hold in C, and you can use this C afterwards, but this is gone. So that's why it is Rvalue. It is temporary. Similarly, if you see the function, you have this square function, it is taking integer x and returning just the square value of that. And if you call like this, square 10, it will return 100, but that 100 is Rvalue, meaning this expression is Rvalue expression. You cannot put address here, okay? What I mean is integer sq is equal to square 10. Now you cannot put address here. You cannot take the address of this expression because that is some temporary 100. Makes sense, right? Let's look at the code and we'll see with some examples. So first example I wanted to tell is like a is equal to 2 and b is equal to maybe 3 and integer p is equal to, but the address. You can't do this. See, it's not working. Whereas if you are just simply doing this, it will work. See, it is not giving any error symbol here. Now compiler is so smart, it can give you, see, it compiled successfully. If I'll just revert that, a plus b, let's compile this, it will tell you that cannot take address of Rvalue of type integer. See, it's telling you that this full thing is Rvalue. See, it's exactly what I said. Similarly, if you have some function and if you pass 10 here like this, so this is okay. See, there is no error here. And if I'll compile this, it got compiled, no problem, no error here. And now if I'll take the address of this and pointer here maybe, see, it would fail. It will tell you that, let me compile this. It would again tell you the same thing, that you cannot take the address of Rvalue of type integer. See, it's pointing out exactly the same thing. So the bottom line is, if you can take the address of some expression, then it is Lvalue, otherwise it is Rvalue. Now, as I said, I will talk little about Lvalue and Rvalue references. Let's look at that. So integer ref r of x is equal to x. Sorry, yeah. So we know that this is Lvalue reference because x is Lvalue and you are referring that, meaning you are creating a reference for that. So this is Lvalue reference. Now let's look at the Rvalue reference. We have integer double ampersand r is equal to maybe 20. I know you must be surprised to see this, that you can put something like this, but yeah, it will work. I'll just compile this. See, it compiled successfully and it is working. Okay. So as this was Lvalue, so you created the reference of Lvalue. Now this is Rvalue, we know that. And you can create the reference of that one. So if you will print this, okay, let's do that. I'll just print this. It will print 20. Yeah, so this is working. You can take the reference of R values, I mean temporary ones. And we know that, okay, this is like Lvalue reference. This is like traditional one. We can print even this, and I'll compile this and execute this. See, 20 and 10. So this is Lvalue reference and this is Rvalue reference. But so many people would say, if they know or if they can think, that if I do something like this, integer const ref p is equal to 20, then this is allowed. Why it is allowed? Now I'm taking the reference of 20, which is Rvalue, we know that, but using only single ampersand. Why? I should not be allowed to do this, right? Actually, you are allowed to do when you are binding it with constant. I'll remove this constant and then you'll see that, okay, it is giving error. See, it started giving error. So the rule is you can bind Rvalue references, Rvalue to Lvalue only when you bind it with constant. So here compiler must be doing some hack, or I don't know, compiler can do something like this.
maybe some integer temp is equal to 20, and the temp will come here, tmp. So this is still valid, right? We don't know, I mean, who is implementing like what, because we have so many compilers. But the rule says that you can do bind Rvalue with Lvalue reference if you are binding with constant. That's why in copy constructor we always take Rvalue, meaning the object, as constant, because you might be assigning some temporary object, and if you are not using constant in copy constructor, then it will not work. So I think we are clear about Lvalue and Rvalue, and little bit of Lvalue reference and Rvalue reference. I'll talk about why we use Rvalue reference in another video, because that would require some explanation of move semantics and all that. Okay, so that will take another maybe 10 minutes. So let's not increase the size of this video. We'll have that in another videos. So I hope you would have enjoyed this video. Thanks for watching, guys. Bye bye. Take care.
Hello friends, this is Rupesh and you're watching CPNet's video series on C or C++ program, because this video is actually applicable for both. And sorry for exaggerating this video thumbnail for a little more, because I wanted you guys to actually click this video and see if you know this, because I didn't know this when I was giving interviews in my early days. And one of the interviewer told me that this is not correct. What I was telling him was not correct. And I was surprised. And that was the only answer I could not give. And still I was selected in that interview, and I cleared everything and I was offered the position. So I was surprised to know this, man. And I'm like, maybe most of the people would not know all these things. So let's see what I'm trying to tell you here. So memory leak, when you create a pointer like integer pointer p is equal to maybe integer maybe value 10, and later point of time in your program, when you're going to complete this program, you're supposed to delete this, right? Like delete p. And we know that this is really very important. If you miss this, you will have a memory leak. So this much is clear, right? Now, the point was how bad this memory leak could be. And this can be a very big array or something. So don't think that I'm telling you if it is just single pointer, which is having maybe 8 byte or 4 byte, it should be okay if you can leak this. No, I'm not talking about that. I'm talking about what he asked me. He asked, what are the consequences of having memory leak in your program? And I was like, oh my God, this is so dangerous. If you have memory leak in your program, then you are done. You just have to find it, solve it. Otherwise, your program is not going to work. And then he said, listen carefully. Then he said, what if I just close my program? I mean, if some application is running and it is having memory leak, and if I close that program, what happens after that? This is really very important. And at that time, I didn't know that if your program goes down, meaning it is closed, then whatever it took memory from your operating system will again go back to OS. So OS keep the track like how much memory it has given to some program, and if that program goes down, it will automatically take all that memory back to itself. And back then I was so surprised to listen this from him, and he had a pretty good smile on his face. I was like, oh my God, I didn't know this, really? So memory leak is way more dangerous if you're writing some program which is going to run maybe forever, maybe like 1 year, 2 years, and then sometime you will close it and then you will restart like servers. Then it is really very important for you. I mean, it is always important, like even if your application is going to live for very short time, you should care about memory leak. But I wanted to make this clear to everyone. So what I mean is, if let's suppose you have some program and that is like maybe in some while loop, and somewhere here you have a memory leak, and this while loop is maybe in some thread and it is running always in 1 second or maybe 2 seconds or 1 minute. And let's suppose you are running this application for like 2 years, and then you will have some maintenance to shut it down and then restart. So by the time you restart, you know what? This whole memory leak will always be there with you. Meaning OS will always think that, okay, you are still using this memory. There are garbage collectors and all that stuff, but this is the basic thing. I mean, if you don't have any garbage collector or something in your system, then you will be in deep trouble. Cool, right? So I didn't know really that if your application goes down, OS will get all the memory back what it allocated for some particular program. Nowadays, OS are very smart, right? So disclaimer, don't comment that I'm supporting memory leak or somehow. No, I'm not doing that. I'm just explaining the relationship between OS and memory leak with your program and when it is more dangerous. And if you didn't know this, hit that like button. And if you knew already, then also you hit that like button. It will help me to grow this. I mean, it will give good rating to this video and maybe so many people will get to know, because then YouTube will give suggestion of this video to mostly so many people. So give thumbs up and spread the awareness. Thanks for watching, guys. Love you. Take care. Bye bye. I'll see you in the next videos.
Hello friends, this is Rupesh and I'm watching CP Minutes video series on C++, and this video is about very small topic, but I thought, okay, this is interesting, so I included this, and this is going to be the smallest video in my channel, I guess. So what is the difference between function and method in C++ or any other language, I guess? The basic difference is method is a member function in a class. So in C++ you have class like this, and you can have some function like this. So this is a method, and method is equal to function because it runs set of instructions, but you wrote so many functions in your life, right? Like without including those functions inside a class. So if that function is open function, it doesn't come under any class, then that is a function. And all those things applies to all these things. Like function can be called with its name, whereas method is always called with the help of object. So if someone asks you what is the difference between function and a method, you don't have to think about it because you know the answer now. So as I said, this is going to be a very small video. Thanks for watching, guys. Bye bye. Take care.